Haiwezekani. Twende mami sasa ile hapa.
Nimembariki huyu nimempa baraka nambariki zaidi. Apande juu. Amen.
We do the introduction video. The introduction video is done before we start the timer. Okay? So we can even do 2 or 3 takes, doesn't matter. So the independent witnesses, you can be here. Okay. So I need guidance from the camera, main camera. I also need everyone in the line of the camera to be seated. Lugaga. So after this introduction video, anyone who is not directly participating in the lesson will need to exit the lab to just leave the students. Now students, you need to have your lab coat either on or along those benches there so that you have working space. All lab coats are the same size, so doesn't matter even if someone picks what you had picked. Yeah, they are going to speak. Please hold this for me.
1, 2, check. Ongeza kidogo. 1, 2, yes there. Fine. Jacob.
So let's move kidogo this side.
So your camera can see as I write.
When do we start?
There is Julie. There is Julie. Julie is at the tent. Julie is a student manager and one security guy from Champions Security. So are we also live on social media? We are live.
So we are ready to start. Silence in the room. So we begin. You are ready?
Rose is not talking.
I'm talking.
Who is going
I'm
to
talking.
start?
I'm the one starting. Yes.
So silence in the room. And if you have a phone, kindly put it in silence mode.
Phones are not even supposed to be allowed for the students in the lab.
Students should not have their phones in here. So we start?
Yes, so we are ready. Jimmy, are you ready? Christian, ready? Recording in 3, 2, 1, action.
My name is Rose Tata Wekesa, and I am attempting a Guinness World Record for the longest science lesson in Kenya. I am in the Multimedia University of Kenya, and it is now 16:35 hours of 13 February 2024. With me, I have the independent witnesses for this attempt. The proposed record title is Longest Science Lesson, and the reference number is 230613135 LBCL. I repeat, the reference number for this record is 230613135 LBCL. With me, I have 4 independent witnesses who will be working in shifts, and I will allow them to introduce themselves one by one.
Hello everyone, my name is Catherine Muller. I'm an underwriter by profession, and I'm also in sports management. I am the Deputy President of Mombasa County Hockey Association.
Hi everyone, my name is Rhoda Kumu. I'm in the education sector. I'm the EYS and primary Yorkshire schools. Thank you.
Hello everyone, my name is Kelvin Idambo. I'm a teacher of French and ICT in Kenya, an independent witness coming to witness this coming to happen. Thank you so much.
I'm Elvis Miruka, an advocate of the High Court of Kenya, and also managing partner at Nyagucha Company Advocates, and I'm also an independent witness.
Thank you. So the next thing, we are now starting the attempt. Are we ready? I need a bottle of water. They are bringing it in a letter. If anyone needs to exit the room from this side, they can pass through here, but it should be minimized. It should be minimized, because there's no time the camera is off. Black pen, blue pen, red pen, pencil, sharpeners we are sharing, scissors we are sharing, compasses we are sharing, pencils you'll be given. As the lesson goes on, you'll be given, okay? So for students, please, let's try not to be distracted. It is a lesson. It doesn't matter who walks in here, as I had said before. We are going on until Friday, until 66 hours. Are we together? Yes, yes. So we need the timers on, the screens on. One exercise book and
How many books? How many exercise books?
they are saying it's one.
One.
One and one workbook. Yes.
Biro. How many biros?
Masi, nitolee hiyo arimis. Toa arimis hapo. Unipe. Niko sawa huku. Niko sawa huku. Nipe arimis. Arimis. Na maji. Hii simu sikai nayo, utaenda hata uicharge. Sawa. I need a dustbin here, if it's possible. So, at what point are we hitting the timer to start?
Should I explain this? Yeah, time.
To them? No.
This one, eh? You see, so you are stopping after 4 hours
For them,
for break.
official time is this one.
Official time is this one. This is just a stopwatch. Once
Just
this
display
will
this,
continue to
display this only,
Only.
so that it is seen in the video throughout. The rest are not relevant. The timekeepers will do their work.
One, two, 1, 2, 1. So we are ready when you are ready.
tuweke red ama tuachie hiyo color? Tusiweke red. Sawa.
White iPad charger, and it's not in there. Anakuja na? Anakuja na? Na? Can you relax? Relax. Okay? Yes. Are we relaxed? So I think toka mbele ya kamera. No, we won't wait for him. Has it been found? Once we hit the timer to start, we are not stopping, yeah? Yes. Are we ready? Mr. Wekesa? Am I blocking the timer? We start? We start. Yeah, we start. Good afternoon. Good afternoon. How are you? We are fine. Okay, so welcome to the longest science lesson, the first worldwide. For purposes of this lesson, you can clap. Okay. Yeah, so for purposes of this lesson, you'll refer to me as Miss Tata. Miss who? Miss Tata. Or you can say Miss Tara, depending on, on where you are from. Okay? So what's your idea of science? What's your idea of science? So you raise your hand, you say your name, and tell us your idea of science. Yes, Alvin?
My name is Alvin.
Uh-huh.
Science is a subject that is practical.
Mm-hmm. He says that science is a subject that deals with practicals. Well, I agree. Yes, Damaris?
To me, I think science is life because it deals with living things and non-living things, chemicals that are used to do many things. So to me, science is life.
She says that science is life. It deals with living things, non-living things, and chemicals. Yes? I need to hear more. Yes, Cynthia?
My name is Cynthia.
Yes.
To me, science is the study of
Characteristics and behavior of matter. I agree. There is no wrong answer in this class. It just depends on how you're looking at it. When you say a wrong answer, I'll let you know. Anyone else from here? Anyone else? Marston?
I'd say science is the chemical component of life. Meaning, science deals with what constitutes matter, living and non-living.
What constitutes matter, living and non-living. So I agree with all your answers, okay? But at this rate, I want to give you the 3 branches of science. Now we have 3 branches of science, so make sure you write the date. It is always important to include the date in your work. Now the first branch of science is the physical science. Physical science. And this is where we have physics and we have chemistry. Now the second branch of science, we have life science. If I'm too fast, please let me know so that I can slow down and make sure that you write. So the first branch we said is what? Physical science. And the second branch is life science. Now in life science, we have biology and physiology. Now physiology could fall under and into biology. Are we together? Because it's basically physiology of living organisms. And then the last one is earth science, where we study about the earth, components of the earth. This is where we have meteorology, okay? The study of weather and climates. That is still science. And we have astronomy under the earth science. So within this longest science lesson, one of the topics we will look at under earth science is soil. The components of soil, the types of soil, we are going to try and extract a liquid, or rather like a solution from soil, and then get to measure the pH just to see how different types of soils behave. Are you looking forward? Yes. Yes, so I think that's it. Now, let's go now to the definition of specific sciences. Definition of specific sciences. Now, I start with biology. Can someone give me the definition of biology? Yes, Haron?
My name is Haron. So,
Be louder.
Biology is the study of living things. It's the study of living things in the environment.
Okay. He says biology is the study of living things in the environment. I agree with him. That can be expounded. Someone else? We are still on biology. Yes, Bilha?
My name is Bilha. Biology is the study of living and non-living things.
She says that biology is the study of living and non-living things and their interaction in their environment. I'll let you know which part of your answer I have a problem with. Okay? Yes. Someone else? Biology? We are 5 minutes into time. Some people have not said anything. Yes, Alvin?
Biology is a branch of science that deals with living and non-living things.
Biology is a branch of science that deals with living and non-living things.
Study of living.
The study of. Now, anytime you see OGY, histology, biology, physiology, that means it's a study. Are we together? So biology is, let's write, biology is the study of living things, the study of living things okay, living things, their anatomy, okay, their physiology, and their relationship to the environment that they are in. Are we together? So I had a problem with Bilha's answer because she said that biology is the study of living and non-living things. We don't really study non-living things in biology, but we study the relationship of these living things and the non-living things and the environment that they are in. Are we together? I know someone is wondering what anatomy is. Anatomy is the study of the internal structure of living things. Please, spare my handwriting. But I think it's good enough, right? Yes. And then physiology is the study of the external structure. External structure of living things. I think it should be clear. Is it clear? Yes. So do you think science is doable? Yes. Okay, let's see as we proceed. Okay, let's go to the next science that we'll be looking at within this lesson, and that is chemistry. I'm looking for people who have not spoken in this lesson. Let me try and walk to the back a bit. Yes, my dear. Yes.
Hi, my name is Sarah.
Louder.
Hi, my name is Sarah. I can say the chemistry is the study of the chemical composition and the properties of matter and
study of chemical composition and properties of matter. I agree. Any other perspective? Any other suggestion? Clarice, what is chemistry? Uh-huh. Okay. Now, chemistry is very easy. I know most of you in this room don't agree with me. Huh? Chemistry is very easy. When you look at the definition of biology, it was a bit complex, isn't it? Yeah. Now, chemistry is simply the study of substances and their behavior with each other. Imagine just that. Why do they make chemistry to look so hard? Study of substances and their behavior with each other. So we break down those substances into atoms. We break the atoms into subatomic particles. We are just simply studying the substances and their relationship with each other, okay? Now, before I go to physics, I always say that chemistry is married to biology. Are we together? Yes. If you are a chemist, it's very hard for you to escape biology and vice versa. You will agree with me that if you did biology, you found yourself writing chemical equations at some point, isn't it? Yes, that's why I say they are married to each other. I don't know who the wife is and who the husband is, but chemistry and biology are very, very intertwined. And that's why we have a branch of science called biochemistry that tries to merge biology and chemistry. All right? Yes. Now let's go to physics. So here we have said it's the study of substances and their behavior with each other. Now, educate me. What is physics? Hey, Clarice. Huh? you are waiting for me? Okay. Yes, Clarice.
Physics is the study of matter in relation to energy.
Study of matter in relation to energy. Who am I to say no? Okay, repeat that, Clarice. Is that? Study of matter in relation to energy. Anyone else with another perspective? Sorry about that. Anyone else with something else to say about physics? Okay, we can leave it at that. You'll be helping me to wrap the board in turns. So now it is Haron's time. Now, where are we? Where are we now? Where are we? We are in a lab, and in the lab, there are rules to follow. So our next subtopic is lab safety rules. Lab safety rules. Put some ugali and rub nicely. Let it be very clean. Now, you are not, I'll try and summarize them, because they are rich. Now, no one is allowed without the supervision of a lab technician. No one is allowed in the lab. You should be writing as I speak. No one is allowed in the lab without supervision of an authorized lab technician or a qualified lab technician. And so that means that you can only perform authorized experiments in the manner in which you are instructed. So at some point we'll start doing experiments. I don't want you to mix substance B and substance C when the instructions indicate that you should be mixing A and D. Are we together? Yes. We do not want an explosion. Are we together? Yes. Yeah, so do not alter this. Still in the first rule. You should not alter experimental procedures except as you are instructed. Okay, let me go to the second one. Approved safety goggles must be worn. Now, I need the safety goggles at least to show you how they look, how they are worn, when we should wear them. Safety goggles should be worn. Now, as long as you are undertaking an experiment, you should have the safety gear on. Safety gear includes your lab coat, safety gloves, the rubber gloves, and if we are dealing with hot substances, we may provide you with thermal-resistant gloves. So all those are safety wear that we should use in the lab. So as they are bringing for me the safety goggles, thank you. Is there one that is connected properly? Thank you. So these are the safety goggles. I'll just wear to demonstrate. Like that, okay? So if there are any sparks, if there is any spillage, you're safe as long as you have this. Now, in the event that you get some spillage of any kind of chemical on your face, right at the exit, we have an emergency eye wash station, all right? We also have a fire extinguisher, a working fire extinguisher in case of any fire. So let's go to rule number 3. We should wear closed, low-heel shoes at all times. It is summer here in Kenya, but we should always wear closed, low-heel shoes. Now, clothing. Which kind of clothes do you think we should have in the lab? Sorry?
Lab coat.
No, other than lab coat is part of safety. Okay? I'm talking about clothing. Yes? Trousers. I agree, but not everyone is comfortable with them, so it's still okay. Cotton clothing. What are your reasons for choosing cotton clothing? It will not? Cotton. Isn't cotton one of the most absorbent materials? So your answer is right, but your what? Your reason? Yeah. Anyway, baggy sleeves and baggy pants are not allowed. Okay? You should wear fitting clothing in the lab. Now I know we have ladies who have braids, and I'm glad that almost all of them, apart from Cynthia, have held their hair backward. So for safety purposes, you should not have any clothing or hair hanging off your body. All right, so I talked about lab coats, that's number 5. Lab coats of 100% cotton are required upon entering the lab. Now, absolutely, number 6, some people are not writing everything. Absolutely no food or drinks are allowed in the lab. Okay? This includes sweets. All right? Consumption of food, beverages, medicines, tobacco and chewing gum is not allowed. Now, cell phones, still in number 6, cell phones and other personal electronic media can easily be damaged in the lab. Imagine your nice iPhone getting some hydrochloric acid in it. How will you save it? Huh? So sad, eh? All right. Then number 7, you should learn the location and how to operate the nearest eye wash foundation. Yes, Alvin?
It's the second part for electronics.
Or electronics and personal cell phones and other personal electronic media can easily be damaged in the lab. So if you decide to use them, it is at your own risk. Number 7, you should learn the location of safety devices like the eye wash fountain. The eye wash fountain is right at the exit. Safety shower, fire extinguisher, and fire alarm box. So all these safety devices are towards the exit of the lab. There's an emergency fire extinguisher, we have the eye wash fountain, and we have the exit on your right. Are we together? Okay. Which number are we in? 8. Number 8. Now, all operations involving toxic gases, toxic means poisonous, should be carried out in the fume cupboard. Now, in this lab, we have 2 fume cupboards at the back, and you can see they have a chimney connecting to the outside. Have you seen them? Yes. I need everyone to see. Yes, so we have 2 fume cupboards, and that's where we carry out experiments involving toxic gases. Number 9, this is a special dedication to Cynthia. Confine long hair while in the lab. Hair can catch fire while using open flames. Okay? Yes. Lucy has left 2 of them, but she will tie them for her own safety. Now, do not use your mouth to fill pipettes. Let us agree, that is number 10. I know you are laughing, but I've seen students doing that. Do not use your mouth to fill pipettes. In case of any accident, injury, explosion, or fire, you must report to the lab technician on site. Now, I'd want the ones assisting as lab technicians probably to just raise their hands so that you can see. We have Maggie, we have Mark Davis. Your name? Sorry? We have Clara, and we have Marlene. Marlene will come a bit later. So in case of anything, you report to them and also report to me. We also have the St. John's team here waiting in case there is any emergency, and I'm hoping and praying that there will be no emergency, explosion, or fire. Number 12, horseplay, mchezo. You know I'm trying to use a simpler term. Mchezo and carelessness are not permitted in the lab. You are responsible for your safety. You're responsible for your safety and for everyone else's safety. We are in number what? 13, yeah? Keep your working area clean. Clean up all spillage, broken glassware. Be careful that nothing spills on your skin. And basically take care of yourself, okay? Be aware that you are in an unfamiliar ground. Okay, number 14. Put all toxic or flammable waste into the appropriate waste container provided in the lab. So for every practical we'll do, we'll provide you with somewhere to put the waste, both liquids and solids. For liquids, we have sinks. Can you confirm that your sink is working? At least there is water flowing. You have access to flowing water? Yes. That's amazing. So you can rinse off whatever you require to rinse off. You can rinse off your hands still in that same sink. And then, now, number 15, and this should be taken very seriously. Do not carry any container or chemical out of the lab. So don't look at our beakers and say that they can be nice glasses for your visitors. Okay? Yeah, so don't carry any containers or any chemical out of, including a filter paper, as innocent as it looks. Okay? Yes. And then 16, if you have a special health condition, for example, asthma or pregnancy, it's important for us to know. And I'm sure you have been advised at the medical tent. And lastly, if you come to the lab with non-compliant clothing or shoes, you will not be allowed to work in the lab. So which rule has touched you the most? I want to hear. I want to hear which rule has touched you the most. I'm done with the rules. You, Alvin. If you come to the lab with non-compliant clothing or shoes, you will not be allowed to work in the lab. Okay. So when they need to speak, okay. Okay, all right. So which rule has, I know Bilha has been touched by, no, Cynthia has been touched by the one for hair. You have been touched by the one for carrying sweets. This Brian looks like he has been touched by the one for clothing. Sure. Okay. Okay, let's look now at the hazard symbols. So we are looking at hazard symbols. Now, most of these hazard symbols, you'll find them in the containers that have the reagents. Are we together? Yeah, so anytime you're dealing with substances in the lab, you should be aware of the hazard symbols, because you could be dealing with something that is flammable, and then you're putting it near a Bunsen burner that has been lit. Are we together? So I have the hazard symbol charts here. 3 of them. This is where you need your pencils, because I'll require you to draw at least 5. Okay? So I'm distributing this as we discuss them. So there's one here. There's one here. But we are going to discuss all of them, okay? And there is one here. Now feel free to move from your chair. Come and view the hazard symbol. Draw the one that you have seen quickly, okay? We are not going to spend a lot of time in this. And write what it means. Then we are going to discuss them together. So I'll just go around explaining what you have on your table. So oxidizing means it should not be exposed to oxygen a lot, because it will change the nature of that substance, or that substance could catch fire on exposure to oxygen, okay? Yes. Then flammable is self-explanatory. Toxic. Corrosive means that if it falls on your skin, it can eat away your skin, it can burn your skin. We have explosive, we have harmful. Almost all substances in the lab are harmful, so you're going to see this a lot in most of the containers. Okay? Then compressed gas, meaning you should be careful when opening. Environmental hazard, especially to living organisms. And then health hazards. Hi, the way some of you are drawing. Please don't traumatize me with your drawings. Don't traumatize me with your drawings, please. So explosive, that one, means that when it is exposed to a trigger, it can easily explode. Flammable means catches fire easily. Oxidizing means that it should not be exposed to oxygen. Martin, please get a ruler. I can see you're struggling. Thank you. So oxidizing means it should not be exposed to oxygen. Corrosive means it can eat away your skin. Acute toxicity basically means it's poisonous. Then hazardous to the environment, it's harmful to living organisms and plants. Then health hazard, hazardous to the ozone layer, meaning it should not be released in the atmosphere. Serious health hazard, it should not be inhaled. And then gas under pressure, we should be careful when dealing with it because it can explode as well. Okay? What is the third one? Hey, who is this? Okay. Yeah, so I want to explain a few. We have corrosive, meaning that it can eat your skin when it gets into contact with your skin or your eyes. Nature polluting, meaning that if this substance is released in the environment, it is harmful to both plants and animals. So when you see such a substance, even the disposing of such a substance is a key thing to consider. You can't just dispose it. There's a special way of disposing them, like burying. Okay? Then we have explosive, meaning that if it is exposed to a trigger, it can explode. Harmful. Most of the substances in the lab are harmful. Non-flammable gas. This could also mean that it is compressed. Okay? This could also mean that it is compressed. Flammable, it catches fire easily. Toxic, poisonous. Oxidizing, meaning it should not be exposed to oxygen. And on exposure to oxygen, its nature will change or it can catch fire. Then we have hazardous to health. It should not be inhaled by all means. Inhaled or ingested. Ingesting means eating or drinking. Yes. Have you all drawn at least 5?
Almost there.
I saw someone using a ruler. I don't know what time he'll finish. Martin, I'm concerned. You do not draw using a pen. Who is this? Mr. Kithuku does not have a pencil. Someone share, please. We draw, in science, we draw using pencil throughout. You're doing well. Okay, most scientists are not artists. You agree? Yeah, so that's why those are 2 different departments. Okay? Those are 2 different departments, so okay.
I like your spirit.
Now, Alvin, it's your turn to rub the whiteboard. Now, can we finish drawing in the next 60 seconds?
Yes.
Okay. So we are going to mark these drawings of yours and award marks. I'll have mercy on you. Okay, so the next thing we are looking at is apparatus in the lab. Common apparatus in the lab. Now, science involves measurements of different things, different parameters. Are we together?
Yes.
Or we are not together?
Together.
Yes. So science involves measuring different parameters. For example, weight. We can measure height. Let me hear what else we measure in the lab, yes?
Temperature.
Temperature, good. Yes, yes.
Length.
Remind me your name?
Enoch.
Enoch. Length? Okay, length will fall next to height. Okay? So let me... So that means even width. Okay? What else? Your name and the answer? Density. We calculate density. We calculate density. Yes, Bilha? pH, yes. Yes, Clarice? Time, good. No one is saying, there's one I'm looking for. Yes, Alvin? Volume, thank you. Hey, you have taken too long to get to volume, eh? So we have different apparatus that help us measure these different parameters. Are we together? And some apparatus are more accurate than others. So when you're undertaking a science investigation, you should always look for the most accurate so that it can give you dependable results. So that it can give you what? Dependable results. Now in science, we are very, very specific when it comes to measurements. You can imagine if they do not measure the component of a certain medication precisely, what it would do to the population. Are we together? Yes. Vaccinations, I've seen them injecting infants 1.32 ml. That is how precise measurements are in science, and they are very important, okay? So when you're choosing apparatus, you should choose the most accurate, and I'll be giving you an opportunity to choose apparatus in some investigations just to see the kind of choices you're making and the kind of findings you will make while using different apparatus. Then we'll be able to gauge which ones are more accurate than others, okay? Now for weight, we use weighing scale. Can I have a weighing scale? Now we're in the digital era, and so we also have digital weighing scales, okay? So you'll be shown a digital weighing scale. I can already see them there. Yes. Yeah, so Miss Maggie is holding a digital weighing scale. I doubt whether there is an analog one, but we used to use analog ones some time back. So please come close so that you see the digital weighing scale. And then I will explain to you why it is shielded, why it has a covering. Are we together? So if you cannot see it from where you are, walk to the front and look at it and then go back to your seat. So it is powered by electricity. Are we together? Now, why do you think it is covered all round? Someone tell me why. It's okay. Why do you think it is covered all round?
Because it measures the even air. Like when you put your hand in, it gives measurements that are not supposed. We are only supposed to measure what we want to measure, not...
So you have contradicted yourself. Have you noticed?
Yes.
And contradict yourself?
It's covered so as to measure just what we are measuring, the substance we are measuring, because it can also measure air. You can just open it up.
Someone else? Yes, my dear. Imelda, yes.
To avoid the interferences, for example, because this instrument senses even movement, to avoid that interference.
Makes a lot of scientific sense. By the way, the answers you're giving me, zisikuwe stories za jaba, please. Give me science answers, okay? Anyone else with, yes, my dear?
My name is Diana. I guess to avoid oxidation.
That's a reason, actually.
Yeah.
Yeah, and then the last one is, I'll pick it when I need it. The last one is to avoid evaporation of substances as you are measuring so that you get accurate measurements. Are we together? Yes. Yeah, so we used to have analog weighing scales, but now we use electronic ones, we use digital ones for better results. So we'll be using weighing scales in some investigations to come. Now, height, length, and width, what do you think we use for this? Rulers. What else? Yes? Hey, finally, she has raised her hand. Jessica.
Micrometers cribbage.
Again?
Micrometers cribbage.
Uh-huh. She's studying architecture, so I'm not surprised by her answer. When you go to the tailor, what do we use? Yes? Tape measure. I told you to stop complicating things. Tape measure. All right. And then let's go to temperature.
Another question.
Uh-huh.
On the weighing scale, what is the maximum amount of weight that you can measure?
The maximum amount of weight. I think we need to be guided by the lab technician. Excuse me. What's the maximum weight that weighing scale can carry?
Depends, they vary. There are some who can, they can only measure to 100 maximum, others
100
so
grams.
Actually, it is indicated.
Is it indicated?
220
grams.
Yeah.
Okay, yeah, 220 grams. So I think different weighing scales can measure different weights. Yeah, but we use small measures in the lab. 10 grams, 15 grams, so it's 0.05 or 0.5 grams. Okay, so let's go to temperature quickly. Thermometers. Now we have different types of thermometers. We have the mercury thermometer and then we have the digital thermometer. So I need both mercury and digital thermometers. Mercury and digital thermometers. Please distribute to them in pairs. I would want them to take this measurement. So I want us to take body temperature. So the person operating the thermometer will take the neighbor's temperature, okay? And vice versa, just to see if you are able to take the readings in a mercury thermometer. So we also need cotton wool and spirit to sanitize them after use. Let me be distributing. So everyone must have a partner. You can measure each other. Yes. So, okay. So I think we need 2 more. Just 2 more, yeah? Now, this is how you're going to do it. Please don't put it in the armpit, please. Yeah, I know. Now, you see on your hand here, place it right in the middle of this joint, okay? I would advise that you check the initial reading. Check the initial reading. It will give us the room temperature. Now put it right in the middle of your hand, elbow joint on the front side, and then fold your hand such that your muscle for this part of the hand and the upper part of the hand covers the silver part of the thermometer. Now another thing, the thermometer should be held here at the tip, because if you hold here, your hand will influence the temperature that you're trying to read. Okay? Yeah, so no. Put it in the middle like that, and then make sure your muscle covers. Now, observe the temperature until there is no more change, and then record. So you are not recording your own. You are not recording your own. Your neighbor is recording yours. That should take us 2 minutes. So we'll also provide you with cotton wool and spirit, so that you sanitize it before you measure the next person. Now, before you measure the next person also, make sure you allow it to go back to the initial temperature. We are looking at accuracy here. Are we together? So, ability to take measurements is part of science. What is the initial temperature? 32. How come the initial temperatures are different? Huh? Okay, I'll go pair by pair. What is your initial temperature? You think? In science we don't think. In science we don't think. We collect evidence. Okay? So please find out the initial temperature. And your partner, Haron. Initial temperature?
30.
Yours
was
30.
Yes.
30. Yes. Her temperature?
35.
Yours is 35. Yes. Measure hers. Sanitize. Please sanitize before you sanitize the thermometer and allow it to go back to the initial temperature before you hand it over to the next person. Do not hand it over to the next person before you sanitize it. So we are using spirit to sanitize. Let's try and save on the cotton wool also. Just a little. So the rest we can keep for an experiment. Okay, so you said your initial temperature was 30. Initial temperature? 31. 35.0. So I'll know who is sick by the time I finish asking. Initial temperature? Final for who? For her. All of you have 35? Initial 32, final 36. Okay. Yes? 28. Oh, yours, how come it's so different? Because from there to here, we have been at 30, 30, 30. But it's okay. Maybe you're in a different environment. Yes?
28.
From here, we are at 28 degrees. Martin and your partner? 25. Initial. So it's like the deeper you go into the lab, the cooler it becomes. Yes?
Initial was 29.
29? Ah. So if you want to feel cool, come and sit this side, please. Yes? For who? For her. Ah. Yes? Uh-huh. Hey, by the way, now the temperature is going up. 29, 29, 30. That's very interesting. 28? 30, 35 for you. Okay, and then? Hey, this guy has 33 degrees. Are you okay?
Yeah.
Sure?
In fact, we rounded off.
You rounded off. It was less.
Yeah, 32.5 around.
Well, that is interesting. Now, what do you think could have happened? His temperature is 33 degrees. Now, think scientifically. What do you think could have happened?
I was from running, so the cooling effect was taking
He was...
So there was some cooling effect taking place.
He was from running, so the cooling effect was taking place.
Yeah.
Yes? What do you think happened?
I'm going to go with him for the cooling because
Mm.
initially the temperature was at 1, but once it was sanitized, it went back to 26.
Did you measure yours before sanitizing?
Yeah, before sanitizing.
Before? So my explanation is that probably they did not wait. Probably they did not wait for it to finish reading. Well, he's insisting they did. Okay, anyway, he's not sick. So basically, even as you're carrying out investigations in the lab, you should allow the maximum time, okay, for your data collection, unless you're limited, unless you're told to measure temperature within 2 minutes. And then now you have to take the measurement of time versus whatever you're measuring. Are we together? Yes. Have you enjoyed the exercise? Yes. All right. Sorry. Then we look at pH. Tell me something about pH. Somebody mentioned that it is something that we measure in the lab. pH. Yes, Bramwell.
pH is how acidic or alkalinity a substance is found to be.
How acidic or alkaline a substance is found to be. Perfect. I think you can write that down. It's important. So pH means power of hydrogen. Yeah. Our timekeeper didn't know that. Power of hydrogen. pH. Okay? So through pH, we measure how alkaline or how acidic a substance is. Now, we are going to do a whole topic on acids and alkalis, and we will measure the pH of different substances. All right? There's something I would want to measure the pH of, but we'll see. What do you suspect it is? Water? Oh, water wouldn't worry me. Soil, no. Urine, What else? Saliva. Yeah, I think it will be very interesting. Who is willing to volunteer the specimen? Okay, we'll get there. Okay? Now, what do we use to measure the pH? Yes? We use the pH meter. And we have the pH scale, which I don't want to discuss it now. I'll be going ahead of myself. We have the pH scale that guides us. It guides us on what each pH number actually means. All right? So moving on swiftly, we go to time. Kindly distribute the timers to the students. Now, in the lab, we have different methods of, measuring time. But for accuracy, what do we use to measure time in the lab? There's my girl here who is very quiet. I've not even heard your voice. Jelimo, what do we use to measure time in the lab?
Stopwatch.
Yeah, we use a stopwatch. And we are using digital ones, okay? Now, because of the experiments that are ahead of us, please come and pick. At least the way I had paired you, send one person to pick. I need us to learn how to reset it so that when we are doing an experiment and we are timing a reaction, we don't have a problem with resetting. So we have 6 minutes to the end of the first hour. Can you imagine? Yeah, imagine. Huh? Now, can you reset? Now, let me see. Now, it should be reset back to 0. Okay? Now, there is the button for resetting. Who has managed to reset theirs? Tell us the buttons you have pressed to reset.
Mode.
Sorry, start then mode. At the same time? Start then mode. Again? Show me.
This changes to the one that has several zeros. Then you set.
Sorry? Now, anyone who has been able to reset their timer? I haven't managed.
You haven't?
No, I haven't managed. How did you do it?
This one. No, you come here for the mode. For the mode, then start, stop, reset. Stop, reset.
Okay, stand and explain. So please follow his. He's the one now telling us.
Good afternoon. I'm Gideon. So we have the middle button for mode. So there is this for time, then there is this for this one for stopper.
Who is the microphone?
Then there is this button for start, this one. Start, stop. Then this one at this end is for reset.
Okay, is everyone's timer working that way?
Yes.
So as a pair, have you been able to reset your timer to 0?
Yes.
Okay? All right, return my timers to the front, please. Clap for him. Appreciate him. Please don't put the timer in your pocket. Okay, okay. Huh? Sorry? Thermometers. Oh, and my thermometers, kindly. Thank you, thank you. Place the thermometers on this bench. Gently, gently. All right, then now we go to the next parameter to measure is volume. Now I have several apparatus here that we use to measure volume depending on how big the volume we are measuring is. All right? Yes. So this is a measuring cylinder. This one is able to measure 100 milliliters. Are we together? 100 centimeters cubed. And then we have other bigger measuring cylinders. So it just depends on what you're measuring. Now, this one you can't measure hot substances with it. What would happen? It will melt, or it may interfere with the nature of the substances, okay? Yeah, so So you choose the apparatus based on what you want to do. We have other calibrated apparatus here. This is a calibrated boiling tube, very unique for measuring volumes. We have beakers. So they have different levels of accuracy. But I want to talk about one, the burette. I want to talk about the burette, which we use for quantitative analysis. Now, the burette is able to give you very accurate volume measurements, okay? Very accurate volume measurements up to 0.1. So you can measure 31.5 using this. But you can't measure that using the measuring cylinders. You cannot measure that using the conical flask. So all these apparatus are for measuring volume. So that's a burette. Who has never seen a burette in their life? Huh? All of you have seen a burette before? Yes. Okay. Now, we are done with 1 hour. Hey. That's nice, huh? Yeah, we should be happy. That's how we'll say we are done with 60 hours, isn't it? Yes. Now, what is this? Pipette. Yeah, this is a pipette. Now, the pipette measures accurately up to 25 centimeters cubed, or 25 milliliters. All right? And we use it in the same quantitative investigations together with the burette, okay? So we put the acid in the burette, and then we can put the alkali in the pipette. And then we proceed, okay? Now, I have other apparatus, but I don't think I want to continue with apparatus. We are going to see many more apparatus as we proceed. Now, this is a separating funnel. This one helps us to separate immiscible liquids. Immiscible meaning that they cannot mix, okay? And they have different densities. So this is what, so when we put those liquids here and we shake, you still see them separating like water and oil, and then we are able to run out the one that is denser first. So even if we have 5 different liquids, we can separate using this, okay? All right, so that's a separating funnel. Others as we move on, okay? Now, you are given a workbook. By God's grace, I was able to compile that workbook by myself. Yes. So, this is the workbook. This is the workbook we are going to be using. All right? Now, this workbook has notes and spaces to write notes. All right? Where there is no space to write notes here, you now write in your exercise book. When we need to draw a graph, we are going to provide you with graph paper. All right? So where there are spaces, I want you to write as much as possible. I want you to learn as much as possible so that we see by Friday morning whether we can finish this workbook. Are you scared? Well, feels heavy, but we can do it, isn't it? Okay, so let's go to the first topic. Maston, come and rub for me the board. Move faster, faster, faster. Thank you. Sorry. So I don't think I need this. This one's here. Can I have my hazard symbol charts? The 3 of them. Okay. Anything else you have that belongs to me? Someone should go around picking the cotton wool so that we can use it. I mean, like the 2 people seated on the end, come picking the cotton wool. Then we'll use it in an experiment. Okay. So we'll be alternating the three sciences. Are we together? Yes. So let's go now to the 7 characteristics of living things. We define them, we explain them, and we compare various aspects of the environment to living things based on, for example, I've given an example there. Why is a car not a living thing? Why is a car not a living thing? Jessica? It does not reproduce. Hey, you have thought about that very fast. Yes? It does not detect? I think cars of nowadays do. Yeah, like even some cars, when there's a motorbike passing near the car, it alerts you. So cars are able to detect changes in the environment. And some cars, when they detect the temperature outside, they switch on the AC automatically. Mm-hmm. Why else do you think a car is not a living thing? Yes, Clarice? It lacks an elaborate breathing system. Cars don't breathe. They need oxygen for combustion to take place. Why am I thinking that cars are living things? You're saying they can't reproduce? Yes, sweetheart. They do. Yeah. So why is a car not a living thing other than reproduction? Yes?
They don't move in such formats.
But cars move.
Such formats.
Not necessarily in such formats.
Some Teslas can pack themselves to refilling station.
Somewhat?
Teslas can pack themselves to.
Yeah. So can we look at the 7 characteristics of living things? And then after we look at them, you'll tell me whether a car is really a living thing or not. Okay? Okay. Now there's a code that we use. What do we call the ones we use letters? Acronym. Mrs. Gren. But because the male species will feel like we've been unfair, we can call this Mr. Garns. Am I safe now? Okay. So the first one is movement. For the sake of our engineers here, we can say locomotion. So we will list them first and then we will define them one by one. What do you think R is? Reproduction. Hey, this class. Okay, it's okay. S? Secretion. Hey! Which word is that? Enoch, what does S stand for? Hey. Omol, have I heard your voice today? What do you think S stands for? Secretion. Hey. Please allow me sensitivity. Very nice. Clap for Damaris. Sensitivity. G. Growth. Now, we normally combine growth with development. Are we together? Yes. So you can say growth and development. Good. R. Yes. Respiration. E. Alvin, excretion. N. Nutrition. Good. So, based on which one you wrote, you just fill it in. If you wrote Mrs. Gren or Mr. Gans, just fill it in. Now, let us define this one by one. So depending on the space you have preserved for yourself, you'll know where to write, okay? All right. So we start with movement or locomotion, okay? This is an action by an organism that causes a change in position or place. This is an action by an organism that causes a change of position or place. So I'll be repeating 3 times. If you can't write after 3 times, it is sad. Yeah? An action by an organism that causes change of position or place of the full organism or part of the organism. Of the full organism or part of the organism. Of the full organism or part of the organism. Now we have reproduction as the second one. Now reproduction is the process that makes more of the same kind of organism. Reproduction is the process that makes more of the same kind of organism. The third time. It's the process that makes more of the same kind of organism. So you see, biology is easy. Okay. Then we go to S. We go to S, which is sensitivity. So sensitivity is the ability to detect, or sense stimuli. Stimuli. Alvin, write for me the word stimuli on the board. Stimuli. Thank you. Now stimuli is plural. Then one is stimulus. Or if you come from a province I don't want to mention, you can say stimulus. Okay? Yeah. Yeah, so it's the ability to detect or sense stimuli in the internal and external environment. In the internal or external environment, and make appropriate responses. Now, if you sense and you do not respond, that is not considered as sensitivity, okay? So the full cycle of sensitivity is sensing the stimulus, sensing that you're feeling hot and deciding to remove your sweater. That is now what sensitivity is. Are we together? Yeah. So the changes that happen inside your body and externally, not just in your body, but for any living thing, that is referred to as stimuli. The changes. Are we together? Yes. So define stimuli there. Changes in the environment both internally and externally. changes in the environment both internally and externally. Can we move to the next one?
Yes.
Okay, the next one is growth and development. Growth and development. Now growth is, we are starting by defining growth. Growth is an increase in size, permanent increase in size. Don't forget the word permanent. Growth is the permanent increase in size of an organism. Permanent increase in size of an organism as a result of an increase in cell size, as a result of an increase in cell size, comma, cell number or both. As a result of an increase in cell size, cell number or both. So when cells increase in size, if the cell was certain nanometers and it increases permanently, that is considered to be growth. If the number of cells also increases, that is considered to be growth. If both factors increase, cell number and cell size, that is also growth. Are we together? Yes. Now the increase is permanent. So when you swell on your nose, is that a permanent increase in size? No. Yeah, so you can't say that your nose has grown. Are we together? Yes. Yeah, but when your foot grows, when you are wearing number 28, 28 is for children. When you are wearing number 36, and then you are now wearing number 38 or 44, that's a permanent increase in size, and that is what? Growth. Now let's define development. Development. Now development is an increase in complexity of cells leading to formation of organs. Development is an increase in complexity of cells leading to formation of organs. So all cells, they start off looking the same, okay? But as you grow and as cell division happens, the complexity increases and the structure of those cells change. And that change causes an organ to be developed. So like when they change to give us cells that give us the rods and the cones that are inside our eyes. Now those are some of the cells that form the eye as an organ, okay? So if there is a diminished increase in complexity of cells, then the development of organs is affected. So anytime you hear that a child did not develop, the brain did not develop properly, or just any organ in the body, the factor that was affected directly is development. The cells were not able to change and become complex enough to fully form the organ. Are we together? Then we can go to respiration. Respiration. This is a chemical reaction. Respiration is a chemical reaction that breaks down nutrient molecules. Respiration is a chemical reaction that breaks down nutrient molecules in living cells to release energy for metabolism. I repeat the second time. Respiration is a chemical reaction that breaks down nutrient molecules in living cells to release energy for metabolism. We're in number 6 now, excretion. excretion. This is the removal from organisms. This is the removal from organisms of toxic materials, comma. I repeat, the removal from organisms of toxic materials. Now give me an example of a toxic material that could be in your body that needs to be removed. Sorry? Urea. Perfect. Now urea is extracted from excess proteins. So unajua vile mnapenda kula nyama? Na kukunywa maziwa? Extra proteins. That's where we get urea from. Are we together? So that's one example. It's just one example of toxic materials. Other toxic materials are alcohol. Alcohol is toxic. It's just that there is an organ called the liver that is able to break down any toxic substance that you take and converts it into substances that are not toxic. So there are high chances that you have been taking, not you've been taking toxic substances, but your liver has been breaking down the toxic substances for you and converting them into non-toxic substances. And that is why prolonged use of the toxic substances strains which organ? The liver. Have I helped you? Yes. Yeah, so you will not say you were not told. Huh? Okay, Marlon? Okay, yeah, so let's move on. So excretion is the removal from organisms of toxic materials, comma, waste products of metabolism. Waste products of metabolism like carbon dioxide. Can you breathe out? But why are you removing a sound when breathing out? You have been breathing out since you were born. It's not an event. Breathing out is not an event. So when you breathe out a higher percentage of carbon dioxide than the one you breathed in. Now, I want us to change the notion. I know small children say this, that we breathe in oxygen and we breathe out carbon dioxide. That is not really correct scientifically. What do we breathe in? I'd like to hear. We breathe in air. What is air? Air is a mixture of gases. So as we speak, you're breathing in oxygen. What else are you breathing in? Nitrogen, a lot of it. 78% of what you're breathing in. Yeah, our media guy looks very shocked. 78% of what you're breathing in is actually nitrogen. So nitrogen, you breathe it in and you breathe it out with the same percentage, okay? What else do we breathe in? Huh? Iron. Argon. So we categorize that as noble gases, okay? What else? Carbon dioxide, also known as carbon dioxide, all right? Yeah, so you also breathe in bacteria. Breathe in. You have breathed in bacteria. Huh? That's why when you breathe in and the bacteria multiplies beyond a certain level and your white blood cells detect that there's too much bacteria in your system, that's when you get a bacterial infection. Are we together? Yeah, so imagine you're breathing bacteria in. Even today at lunchtime, you ate bacteria. Okay. Okay, so waste products of metabolism. So even water, the water you breathe out a lot of moisture. It's a waste product of metabolism. And you're going to know this is really true when we look at respiration as a topic. You'll see that water, we say drink water, but it is also what? A waste product. Then, so the last thing that we excrete is substances in excess of requirements. Substances in excess of requirements. So there are 3 things that we eliminate from our bodies through excretion. I said the first one is toxic materials. The second one is? Yes. Perfect. And then the third one is? Perfect. Can we go to the last one now? Yes. Nutrition. Nutrition. Now, nutrition is not eating. I've heard people say that nutrition is eating. No. Now, nutrition is taking in of materials. Taking in of materials, in brackets, food and drink. Taking in of materials, in brackets, food and drink, for energy, growth, and development. Taking in of materials for energy, growth, and development. Now, I will not go into the 2 types of nutrition, but just to mention, there are 2 types of nutrition. I don't know if there is anyone who would like to enlighten us about the 2 types of nutrition. We have heterotrophic and heterotrophic, when organisms take in readily available food substances, okay? Then we have autotrophic. Let me write it. Then we have autotrophic. These are types of nutrition. So this one now, heterotrophic, involves taking in of readily available food substances. Of course, it's living things that are taking in the food substances, okay? Then autotrophic involves the ability of plants to make their own food. So this autotrophic nutrition is making own food by green plants, okay, through the process of photosynthesis. Okay? Yeah, so I think we are done with the characteristics of living things. Unless someone has a question. Any question? So can we move on to 1.2? All right. Let's move on to 1.2. And we are defining classification. Grab the board for me. We are defining classification. As I wait for my book to load. Now, how many species of organisms do you think? Okay, before I go there, is a car a living thing? We didn't agree. How many think that a car is a living thing? I said there are no wrong answers. How many think that a car is a living thing? Why do I think it's a living thing? So what disqualifies it? Yes? There is no growth and development. Perfect. Another one? Yes, Marston? Yeah, there is no reproduction. But I think for everything else, it's there. Because the nutrient molecules is the fuel. Okay? Yes, yes, yes.
Fabian?
Yes, Fabian.
Some animals, they don't reproduce.
All living things reproduce. All.
Yes.
They may not reproduce with the familiar mode that you know, but they all, otherwise, that's not what I meant. You guys. Okay, I meant we all know the sexual reproduction, and okay, some of you may not know. But breaking news, there is sexual reproduction. You're fearing to say sexual? Okay. So there is sexual reproduction and there is asexual reproduction. So in asexual reproduction, we have different now methods of asexual reproduction, and that is why you tend to think that some organisms do not reproduce. But I want to assure you, if they were not reproducing, they would not exist, because they all have a lifespan, and once the lifespan is over, how we get continuity of the same organism is because more of the same is being produced. Okay? Okay, so I was asking, how many species of organisms do you think we have on Earth? On Earth? Millions. And let me tell you, we are still discovering others. So if there is no way of organizing them in groups, there would be a lot of confusion. That is why we are categorized as humans, because after study, they have discovered that organisms like us have the same characteristics, and so we are categorized in the same category of humans. Are we together? So what exactly is classification? What exactly is classification then? Yes? What words can you use to describe classification?
It is the grouping of organisms with the same characteristics.
Grouping of organisms with the same based on the same characteristics. Hey. Where is that microphone? The whole world must hear the way you're saying.
It's a grouping of living organisms according to their characteristics.
I'll clap for you. Okay? Yeah. Amazingly, his answer is correct. Are we together? Now, the reason why we classify organisms is because we want to avoid confusion, and we want to be able to study these organisms easily. Are we together? Yes. In your own words, write the definition of classification, and then I'll call you to say which words you chose to write to describe the characteristics of organisms. So remember, as you're defining, you must mention that we use features that these organisms share, okay? So you take like 5 species and see, do they share the same coating of the skin? Yes. Do they laugh the same way? Yes. Do they all have 32 teeth? Yes. So you basically, it's not complicated. You just use the features that they share, right? So I want to go around hearing how you have defined classification. Where is it again? Faith, I believe I've not heard your voice today.
Yeah. Classification is the grouping of organisms with the same characteristics based on their physical appearance and their day-to-day activities.
Mm. Wow, she has brought in the aspect of physical appearance. Dolene. Hey, that's a nice name. Mm-hmm.
Classification is the grouping of living organisms with similar characteristics together.
With similar characteristics together. Uh-huh.
Mine is not so different from hers. The grouping of living organisms according to their characteristics.
Grouping. Anyone else who has different wording? Anyone with different wording? So we all agree that we are grouping them. And the reason is to do what? 2 reasons. To avoid confusion. Okay? Where there is order, there is no confusion. Are we together? To avoid confusion and also to make it easy to study the behavior and the appearance of these living organisms. All right? So that's great. Now, 1.3. Now, basically, explaining the concept of evolutionary relationships to classification, we are basically explaining how the organisms are actually classified. Are we together? Yes. Now, there are high chances from study that organisms that share features originated from the same ancestor. Do you agree? Yes. Now, if I look at Fabian, there are high chances that he has a physical appearance that is similar to his relatives. And if he appears where his relatives are not there, someone will tell that he is different. Okay? So the way we look is as a result of our ancestors, where we originated from. Okay? Like if I can give an example, all mammals have bodies covered in fur, stroke, hair. Okay? How do mammals feed their young ones? Through mammary glands. Okay? So when we study the morphology. Sorry. Morphology. Now, the morphology basically means the shape and the form. The shape and the form and the posture of a living organism. That is the morphology, okay? So when we study the morphology and the anatomy, I had defined the anatomy before. And the anatomy of organisms, then we can tell the organisms that are from a similar ancestor. Are we together? Now we go deeper by studying DNA. Have you ever heard that so-and-so is doing a DNA test to prove paternity? Yes. That tells you that when the DNA codes are similar or close to each other, it is also an indication of what? A similar ancestor or or similar origin. Are we together? Now, we study this using microscopes, and with the knowledge of biochemistry, we do DNA sequencing. Now, we are going to study about DNA sequencing further when we are looking at nucleic acids in biological molecules. So when you look at pages ahead, you'll see a topic, biological molecules. Then there is nucleic acid. So that's when you'll see how you're able to tell how close organisms are. Are we together? Okay, let's go back. So that means that if the sequences for mammals are compared, there's a lot of similarities. And that is what we are calling evolutionary relationships. Studying the morphology, the external appearance of the organisms, then going deeper to study the anatomy of organisms, and then going deeper to taking the cells and studying the DNA and checking the similarity of the sequences. Okay? Yeah, so the DNA sequences are used to determine how closely related organisms are. Now, in your own words, in 2 minutes, explain the concept of evolutionary relationships to classification. Of course, take us through the 3 depths of study: morphology, anatomy, DNA sequencing, and how that makes us to know the origin of each living thing. So 2 minutes, please. And then after that, I'll give you a chance to say what you've written, how you have explained the concept of evolutionary relationships. Feel free to discuss. Ask your neighbor, wa unaandika nini? Yeah? Wa unaandika nini? Which words? Kwani unaandika na pencil? Oh, we started at 4:49. So we have 19 minutes to completing 2 hours. Hivyo tu. Imagine. Si ndio Alvin? Yeah.
Study of hiyo tulikuwa tumefanya mwakenya
Kwanza I'll select you to say what you have written. Unaona venye unazuba? I'll select you. I think you have how many seconds remaining? 50 seconds. Thirty more seconds. Two more seconds, and I'd like to hear what Lucy has written. Let me have the microphone, please. Yeah, so Lucy, you're the one to hand the microphone to the next person. Can we pay attention, please? Let's hear how she has described the concept of evolutionary relationships and whether she has captured the 3 depths of that. Yes, Lucy.
Hello. I've explained by saying this is the study of morphology, anatomy, and DNA of an organism, where morphology is the study of shape, form, and posture of living organisms. DNA, this is to determine how closely organisms are related to each other. And anatomy is the study of internal structure of living organisms. Thank you.
Yeah, that's a good one. Clap for her. My friend here, your name and your answer, yes. Evans.
So, the concept of evolutionary relationship to classification, I have described it this way. It is a study of morphology, DNA, and anatomy, where morphology deals with the posture, shape, and form of the organisms. DNA is more concerned about paternity or the closeness of the organisms. Anatomy deals more with the study of internal structures.
Hey, that's a nice one. Now I just need you to rearrange the order. You have said read again, morphology, DNA, and anatomy.
DNA, anatomy, yeah.
Now rearrange it to morphology, anatomy, and then DNA. Okay?
Yeah.
Can I have the gentleman at the back? My extreme right at the back, yes.
My name is Martin. I have classified the concept of evolution as the concept of evolutionary relationship to classification as the study of the shape and the behavior of organisms, and the study of the DNA and the anatomy. And I've just said as much as what the other people have said too.
That's not an answer. Is that an answer?
It will be a repetition of what they've just said.
Okay,
so
it's okay. Let's appreciate him. Now, looking at those depths, then it means that we start as living things, okay? We start as living things. Then the living things are broken down into kingdoms, okay? Then we keep breaking down until we get to species. So who can remember the order? Who can remember the order? Yes? Some people are singing. You have played a song. I'm interested in hearing that song. Yes?
There's kingdom, phylum, division, class, order, family, genus, species.
Now you need to stand and face them so that they hear you.
You start with kingdom, then phylum, then division, then class, then order, then family, then genus, then species.
Great. You know he's fresh from the studies. Now who is that who was singing a song? We would like to hear that biology song. Is it Jessica? Somebody was singing. Chelimo, is it you? It's Maston. Wow.
The song goes, King David came over for a great soup.
King David came?
For great soup. King David came over for great soup.
For great soup?
Yeah.
Wow. Okay, that's interesting. So the one I have is, can I share mine?
Yes.
I have King Peter David could only find green socks. I don't think you'll forget that. Now, the reason why Peter and David are on the same line is because phylum is for animals and division is for plants. Okay? So, now what do we call this? We call it the Linus system of classification. So, it is a system of classification. Linus or Linus's system of classification. Okay, so I'll just use one example here, and I'll use the humans. So we will classify the humans from kingdom all the way down to species, and then I'm going to tell you what a species is, all right? So let me wrap this. King David Peter could only find green socks. All right. So we are moving from general characteristics, okay, or general features, and we are coming down to specific, sorry. We are coming down to specific features, okay? So you'll find that up here, you'll find us sharing same characteristics. But as we go down, okay, we start being more specific. So, to which kingdom do we belong to? Huh? We belong to the animal kingdom, scientifically referred to as Animalia. What about the phylum? No, just say it. You'd rather say it and then I say it's wrong. The phylum is Chordata, yeah? Chordates. So we are chordates, okay? So we are first animals. Say I am an animal. Okay. We are first animals, and then we are chordates. Are we together? What about the class that we belong to? You guys, you're even okay. Mammalia. So we belong to the mammal class. Then the order. I know you don't want to hear this, but we are primates. All right? Yeah, we have known primates to be our friends across the fence. Is it this side? Yeah, the ones that will visit us at 3 a.m. when we are doing our lesson. Those are primates, eh? Then which family do we belong to? Family. Can you read that word? Huh? Sorry? Hominidae. Huh? Gen Z pronunciations. It's not hominidae. Hominidae. Where? Let's go to genus. The genus is Homo. And then the species is Homo sapiens. You'll understand why I have underlined with 2 lines very soon. Are we together? Yeah, so basically we were at 1.3. And we have managed to look at the concept of evolutionary relationships to classification. Now, the last thing I want us to look at, still in 1.3, the last thing I want to look at, still in 1.3, is I want us to define what a species is. A species. Are you done writing? Okay, 1 more minute. Can I rub? Who has not rubbed? Bill her. Rub for us. So as she rubs, I want to see what you've been doing. What have you been doing? Why have you mixed them?
Mixed what?
Your division is coming after species.
But I noticed.
Oh,
I have
okay,
listed.
okay. Where? Mr. Omol?
Yes.
Are you an engineer? Or you're studying engineering? Okay. I'm impressed. Will you be drawing with a pencil next time? Pencil. You draw with a pencil next time. Hey, you guys are so focused. Wow. I think I'm happy. We are moving on well. All right. So I want us to define species. Species. Now, species, of course, you can see is the lowest branch of classification, okay? So that means that it actually refers to a more specified way of classifying, okay? By the time you're saying that organism X and organism Y are in the same species, it means they have passed through all the depths of classification, okay? So anyone with an idea what species could be referring to? Species? Clarice?
Organisms which can naturally interbreed to give rise to
well-developed. You have missed it out with what that description is. Viable offspring. What's the other name for viable? Fertile. Perfect. So species refers to, we are writing, a group of organisms. So, a group of organisms. A group of organisms that have the same characteristics and can reproduce viable offspring. So I hear that donkeys can reproduce with horses, right?
Yes.
To give us mules. Now, mules are not fertile. Reason is because they are offsprings of different species. Is that clear?
Yes.
Any question about 1.1, 1.2, and 1.3 before we take a health break? Some of you will take a health break, and I'll also require some specimen to be collected from outside. So I'm going to select 4 people who will go outside and collect different types of leaves, okay? So like if you collect 5 types of leaves, you have 5 of each, so that we work in groups, so that each group has all the types of leaves. You understand the explanation? Yes, because the next segment that we are doing for classification involves construction of dichotomous keys, and that requires us to go out and get the leaves. Are we together? So I'm taking questions. Ask questions in the next 50 seconds. Yes, Alvin.
So, about this, about the definition of species, that means organisms of the same genus can reproduce but don't be fertile.
Organisms of the same gender.
Genus.
Genus. Yes, yes.
They
Yeah, but the
reproduce.
offspring will not be fertile.
So as
They'll
long
be
as-
non-viable.
Oh.
All right. Any other question? Yes. Bramwell?
Yeah, my question is, you have said a car cannot be considered as a living thing. What about a plant, rather a tree, since
A tree.
it can't move?
A tree can move. Can you read for us the definition for movement?
Movement is the action by organisms that can cause change in position, place of full or part of the organism.
Now, does a plant move partly?
Yeah, partly.
Thank you. Have I answered your question? So we are down 2 hours. I'll release a few of you. I'll release a few of you to go for a health break, just a few of you. And then the ones who remain, I'll also select like 4. So those going for a health break, just briefly, and then come back. So I'll need 4 people who are remaining to go and pick the specimen for me. Now, when you go for your health break, when you come back, it is you to look for time to do what the others were doing when you were away. Okay? So in between the discussions, you try and catch up. I know you can do that. Yes, yes. So I think I need to move on to the next thing as that transition is happening. And we are moving to 1.4. We are not stopping. We are moving to 1.4. And in 1.4, are we settled? In 1.4, we are explaining the binomial system of classification, stating and explaining binomial nomenclature. Stating and explaining binomial nomenclature. Now, nomenclature means a set of rules. You can write that. Nomenclature means a set of rules. So the set of rules that we use to name organisms is what is being called binomial nomenclature. Now, you need to know that organisms have common names, okay, or regional names that are applicable to every region that that organism is in. For example, in my native language, a human being is called Modo. What do we call a human being? Modo. Thank you. Those who are saying Mondo, it's Modo. Now, can someone share with us what they call a human being in their native language? Yes? Chito. Mali safi Chito. Chito. Oh yeah. Chebi. No wonder. Chito. So now, if Chebi comes to my area and hears Modo, she will not understand. So that means that common names are not acceptable universally. Okay? So it's important for you to note there that all organisms have common names and scientific / universal names. In 1 minute. All organisms have common names and scientific / universal names. So I'll ask Maggie to select for me the ones going to collect specimen. To a maximum of 4, we should be more than 10 left. And then explain to them what they are going to collect. All right. Pardon, where? Or common names and scientific / universal names. Yeah, so they're stepping out to get some species from the environment before it gets dark. All right. Now, the one who came up with these scientific names is called Linus. Linnaeus. Okay? Yeah, and he named organisms in Latin using the binomial system. Now, there are, as I said before, the binomial system, binomial nomenclature refers to a set of rules. Are we together? So, rule number one, all scientific names are two. All scientific names are two. All scientific names are two. By means two. So when I say binomial nomenclature, I mean it's a double naming system. Double naming system. All right. Now the first name is the genus name, and the second name is the species. The first name is the genus, and the second name is the species. That is rule number 2. So rule number 1, we said all scientific names are 2. It's referred to as the double naming system. And then we have said that the second one is? Yes. The first name is genus, the second name is species. Rule number 3, the first name, which is the genus name, starts with a capital letter, and the second name, which is the species name, starts with a small letter. The first name, which is the genus, starts with a capital letter, and the second name, which is the species, starts with small letter. So uppercase and lowercase, okay? All right. When typing, that is rule number 4. When typing, binomial names are always in italics. When typing, binomial names are always in italics. Now, this is just an indication that they are Latin names, okay? So when you're typing in a computer, you need to change and use italics if you're writing a scientific name, a binomial name. That is rule number 4. Now, rule number 5, when handwriting, not handwriting like underline the two names using separate lines. So does that explain to you why I wrote Homo sapiens and then I underlined? Yes. Yes, I was following the binomial nomenclature. Rule number 5, all right? So anytime you see a binomial name, a scientific name, you should be able to identify which rule has not been followed. And if you're a scientist and you're describing a living organism, you should also follow all the 5 rules that I have given. Are we together? Yeah, so now we are going to look at the 5 kingdoms of classification. Let's look at the 5 kingdoms of classification. The 5 kingdoms of classification. I'm going to list them first, and then we will look at them one by one. I know initially we used to think that, or rather, in our biology studies, we used to see living things being classified in only 2 kingdoms. Which kingdoms were these? Animalia and Plantae. But as more research is happening, we now have 5 kingdoms. Just go to your seats. We now have 5 kingdoms of living things. Now, we are going to look at some kingdoms in depth, and then others we will look at them shallowly. Science is very wide. We may not look at all of them in detail, okay? But we will look at the more familiar ones in detail. Now, the first kingdom is the animal kingdom, Animalia. We have plantae, we have fungi, we have prokaryote, and then we have protoctists. All right? So we will look at them one by one, classifying them, looking at their general and specific features, and why they have been classified within that kingdom. Are we done listing them? Now, I know you may be wondering why I have just printed images of animals without saying who these animals are and where they belong to, but that is why we are here. Are we together? Yes. We are here to classify them. Now, looking at the first organism, which is, what's the name of that first organism? Huh? Toad, frog, depends on what feature you're seeing. All right? Now, looking at that first organism, what do we call the class to which that organism belongs to? So we are looking at the organism in our workbook, 1.5. So the organism we have there is an amphibian, and all these fall under animals with backbones, which are called what? Vertebrates, all right? So vertebrates. And the first one that we have there is an amphibian. Now, I would like us to discuss examples of amphibians and the features of amphibians. I would encourage you to look at the diagram and tell me any features that you see that probably were used to classify that organism as an amphibian. So the floor is open. Why do you think we are calling that organism an amphibian? Marston?
It has a thin, moist skin.
It has thin, moist skin. Are you able to see that? It has been labeled. Yes, so you are writing the features of the amphibian. So it has smooth, moist skin, apart from the toad. Now, toads have dry and rough, warty skin. Dry, rough, warty skin. Toads are a bit different, eh? They have dry, rough, warty skin. Anyone who has ever had a what? What? Projections that come on the skin that are hard, not pimple. So the toads are different because their skin is full of warts, okay? Something else? Tell me more about amphibians. Of course, I know you are scared of them. Another thing. The gentleman here, Lenny, I need to hear your voice.
Okay, I had the same thing like for my friend here, but
Okay, he's thinking. But just look at the diagram.
Maybe the visible eardrum.
Yes, visible eardrum. That has been used to classify it as an amphibian. So remember, when you're studying science, you're looking at the appearance, external appearance first, external appearance of the organism. So it doesn't matter how you feel it should be said, as long as it is for that organism, it is a feature that can be used to classify it. Okay? Now, any other fact you know about amphibians that probably is visible? They all have? For this particular one, yes, but not all. All right? Yeah, so you can say they have webbed feet. They have webbed feet. I'd like to add you more so that we move on to another one, okay? Now, their young ones live in water, okay? And the adults live on land. So this is one class of organisms that is both aquatic and terrestrial, okay? Yeah. So that means that also they are able to undertake gaseous exchange both by gills and by lungs, and also skin for the thin, moist skin. So they have several gas exchange. They have several gas exchange surfaces. Yes. There are some students out for a health break, right? Yes. All right. Another thing you need to understand is that they lay eggs without shells because their fertilization is external. They lay eggs without shells because their fertilization is external. They lay eggs without shells because their fertilization is external. And lastly, their eggs are protected by a waterproof leather-like covering. Their eggs are protected by a waterproof leather-like covering. So that's it about amphibians. That's it about amphibians. Now, let's go to organism 2. Organism 2. I'd like to hear what you think about it. And the features that are visible, to which class does it belong to, etc. Look at me. I'm waiting for an answer. Yes? Class Aves or birds. Okay, we note that down. So the second organism is a bird. Now give me features that are both visible in that diagram and others that you know for Aves. Sorry, I'm yet to master your names. Sarah? Yes, Sarah?
Their bodies are covered with feathers.
Their bodies are covered with feathers, but their legs are covered with scales. Please note that down. Remember, science is specific. Yeah, so when you say bodies covered with feathers, someone who is not a scientist will tend to think that the whole body is covered with what? Feathers. So you need to specify feathers for the body and scales for the legs. Quickly, let's proceed. Yes, Jelimo.
They have pigs.
They have? They have? beaks. So you can say that their mouth parts are modified into beaks. Their mouth parts are modified into beaks. Before we move from the mouth, what else can you observe about aves? Or have you ever observed about aves? Yes?
Can you say they have different types of beaks, maybe for the flesh,
Uh-huh.
kind of sharp
Uh-huh.
like
Yes.
the downwards,
Uh-huh.
and then there are the ones that are for the ducks,
Mhm.
they have serrated
Yes.
beaks,
Uh-huh.
and then the nectar, they have the
Long.
nectar.
Yes. Amazing. Yeah, so Sarah is mentioning about the different shapes and lengths and types of beaks and the adaptations of these types of beaks to feeding. To feeding, okay? For example, let me talk about the hawk. Are we all familiar with that organism? Yes. What do you think the shape of its beak is? And for what purpose? Please raise your hand. Yes?
Strong and curved.
Strong and curved. For what purpose?
Tearing flesh.
Tearing flesh and carrying prey. Yeah? It's like this. So when it gets prey, it can even hook a snake on its beak. Are we together? So thank you for mentioning that. But other than the shape of the beaks and the feeding methods of those beaks, what else can you mention about the mouth of aves? Yes, Yoleni? Yes, Lenny? Mm-hmm. Their feet for aves. Some. Yeah, some have webbed feet, depending on their habitat. If they are aquatic and they require to swim, that's when they have webbed feet, okay? The claws. Yeah, so you can say that they are but you're moving ahead of us. We are still talking about the mouth. We'll talk about that, okay? Yeah, we are still talking about the mouth. Yes.
Birds have no teeth.
Yes, birds have no teeth. By the way, who thought birds have teeth? Like, just be honest. If you thought birds have teeth, just really, Clarice. Oh, no. Gen Zs. They have a tongue. They have a tongue. For manipulating food substances in the mouth. Okay? Like if they are eating a worm, figure it out, eh? Like imagine it. Let's talk about the limbs of aves. Into wings. Again, please don't say that all aves fly, because we know that is not true. Are we together? Now, based on the habitat, or rather where the animal lives, the hind limbs, Hind. So the wings are the front limbs, and then the feet are the hind limbs. Okay? The hind limbs are shaped differently. Okay, Lenny, I think I'm answering you now. Are shaped differently based on the habitat and how that particular organism moves. Like, for example, we know that ducks swim, right? Then we have some aves that are specifically live on top of large trees. Others live on shrubs. Are we together? So based on where they are supposed to support themselves and how they move, and even the kind of protection they need, how they need to protect themselves, the hind limbs can be shaped differently. Not all of them have claws. Not all of them have sharp claws. Are we together? Because why would a duck need sharp claws? Huh? Yeah? Something to think about, isn't it? Let's go to the third class. What can you see there? A snake. Nowadays, people are keeping snakes as pets. So these belong to the class reptiles or reptilia, and there are features that help us classify these organisms as reptiles. Okay? Give me those features as they are visible or some that you know. I know you have interacted with reptiles. Yes, Jessica?
They have scaly skin.
They have scaly skin. Their bodies are covered with scales. Hey, let other people answer, Bana. Yes, Cynthia.
They have no legs.
No legs? Limbs? I disagree. They all have 4 limbs except the snake. Okay? Now, did you know that the snake has reduced limbs? Yes. Because of, okay, please, don't think religiously, okay? I know. I know we know that the snake is Satan. Okay? But for purposes of this lesson, please suspend that thought. Are we now together? So evolutionarily, snakes used to have limbs. But because of the environment in which they found themselves in, and how they needed to move, and how they have sensory, very, what can I say, sensitive sensory neurons on their belly, they found themselves wanting to move on their belly because they could hear better on their belly. They could hear danger coming on their belly. So with time, the legs became useless, or rather we say vestigial. Are we together? Yeah, I know it's not making sense, but this is science, eh? Yeah, so the legs became vestigial, and they started being reduced. So they say that this process happened over millions of years. Until now, the snakes we have do not have limbs. Are we together? Yeah, so all reptiles have 4 limbs except the snake. All right? I would have brought you a snake to show you, but I want us to last until Friday. Okay. All right. The other thing about reptiles we need to mention is that they lay eggs with rubbery shells or leather-like shells, just like amphibians. All right? They lay eggs with rubber-like shells or leather-like shells. And the sole reason for this is just to protect the eggs, okay? So another animal can feed on an egg of a snake, and that egg will go through the digestive system of that organism, and it will be digested or excreted, and it will still be intact because of the rubber-like shell that is resistant to digestive juices of organisms. So that is how snakes have been able to survive. So even when you step on an egg of a snake, it will just wobble, but it may not crash because the shell is not hard. You can even press it like this, like a balloon or something, yeah? Yes, so that's what we mean. Now there's something that we did not mention when we talked about birds, and we need to mention that birds are warm-blooded. Go back to where birds are. Birds are warm-blooded, meaning that they have a constant internal temperature. They are warm-blooded. So warm-blooded does not mean that their blood is warm. Are we together? It means that they have a constant internal temperature. All right? And then reptiles are cold-blooded, meaning that their body temperature is determined by the environment they are in. Meaning that the body temperature is determined or it varies based on the environment they are in. So it's important to note that. Now, I'm not going to talk about feeding. You have noticed I'm not talking about whether they are omnivores or carnivores, or because all these organisms, like all these classes, they have some that are herbivores. Okay? We have birds that are herbivores. Then we have birds that are carnivores. So I don't want to, start discussing about the different feeding of the aves and any other class. Okay? Now, some reptiles produce toxic secretions. For example, snakes. Are we together? So it's important to mention that. We have lizards that produce toxic secretions. We also have chameleons that produce toxic secretions. So the production of toxic secretions is a bit more characteristic of reptiles, all right? And the reason why they do this is basically to protect themselves from danger and also to be able to subdue their prey. If a snake wants to feed on a herbivore, it will just need to bite a bit and inject the toxic substance. So that toxic substance weakens the prey and the snake is able to subdue the prey. So that is one of the main reasons why we have toxic secretions. Okay, let's go to class number 4. Class number 4. Yes, which class is this? Sorry? Pisces. Okay. How many are for Pisces? If you are for Pisces, raise your hand. Straight up. If you are for Pisces, raise your hand. Okay. So let's go with Pisces. Pisces. Okay? Or simply fish. Please don't think about fish. Cooked fish. Now. Okay, let's talk about fish. And I want to hear what you know about fish. There are many, many facts that we can discuss about fish. Yes, Marston? Fish have streamlined bodies. Why? Why? Yes, Evans? To enable them maneuver, or another word we use is? Sorry? Yes, reduce friction. No, I'm a bit uncomfortable with that answer. Yes?
To enable them to move.
Sikia mwingine. I think it's to enable them cut through the water or glide through the water, because a streamlined body reduces resistance. Okay? That's why when you're swimming, you are told to arc your body in a way that it will be as streamlined as possible so that you swim faster. Okay? Yeah, so this shape actually helps them to cut through the water and move swiftly in the water. All right. Anything else about fish? Yes? Uh-huh. Yes. So their gaseous exchange surface is the gills. The gills. Now, I know we always say that fish breathe through the gills. What is wrong with that statement? What's wrong with that statement? Thinking about it as a scientist, when you say fish breathe through the gills, yes?
Breathing is the act of taking in oxygen or
Where?
the gases.
Stop there.
It's the taking in of the gases, the air. But the gaseous exchange is that point where the oxygen will be taken in through the system and the waste will be excreted out.
Okay.
So the gills cannot be used for the breathing.
Mm-hmm. Yeah, so saying that fish breathe through the gills, scientifically, it's not correct. Are we together? Yeah, so you just say that they perform their gaseous exchange through the gills. That sounds better. Another thing we need to mention about fish. Fish lay eggs in water, of course. Okay? Now, please enlighten me. Is it internal or external fertilization?
External.
External. So their eggs are fertilized externally. Did we mention that for birds it is internal? I'm sure you have seen the chicken at home. Now, they lay eggs without shells in water. Why do you think their eggs do not need to have shells? For easier fertilization. And then secondly, there is no threat of desiccation. Attack? Hey, are you okay? Yeah, there is no threat of what? Yeah, there's no threat for desiccation because the eggs are in water. Then we go to the last class, which is mammals. Mammals. Now, I'd like to hear what you have to say about mammals. Yes? Mammals are warm-blooded, meaning that they have a constant internal temperature. And we measured the temperature, and apart from Bramwell, we all had the same range of temperature. So we'll check on him later. Now, another thing about mammals. Yes, Lenny? They have internal fertilization, so their reproduction is sexual reproduction. Yes, Haron?
They have a mammary glands.
They feed their young ones using mammary glands. Your name again? Martin. Yes, Martin?
They take care of the young
They take care of their young ones. Okay, that's a bit, well, interesting. Now, Yes. Their gaseous exchange surface is the lungs. So you can mention breathing for mammals, okay? Now, let's talk about the covering of the skin. Jessica? Fur or hair, perfect. Let's talk about the ears. Hey. Chebi. Comment about the ears of mammals. Just look at us and comment about our ears. Please stop suggesting answers for her. Let her tell us what is in her mind. Yes, Chebi? External? Hearing. Yeah. They have external visible ears. Now, what you see is called the pinna. Okay, how many are for pinna? Pinna. Pinna. Yeah. You know, with this generation, you have to be keen. Otherwise, you can say a word, they'll never forget how you pronounced it. So the external ears, also known as the pinna, visible ears. That's typical of mammals. Are we writing? Okay. Now the last thing that I'll mention that is typical of mammals is that they have a placenta. They have a placenta. Because we mentioned that they give birth to live young ones, okay? So they have a placenta that is very important in the pregnancy, process of pregnancy and transferring nutrients from the mother to the fetus. All right? All right. You also have tails. Some. Well, even, okay, another thing, we used to have tails, humans. But with time, because we don't use them, they became reduced and they became vestigial, just like the limbs of snakes. Are we together? Yeah, so that's it about vertebrates. Unless someone has a question, we can move swiftly to invertebrates. Now, for the invertebrates, you'll need to use your exercise books because it is not included in your workbook. Now, remember, we are still in the animal kingdom. We said we have how many kingdoms? 5 kingdoms. So we are still in Animalia. Are we together? Yes. So we have looked at vertebrates, now we look at invertebrates, okay? Now, we can never really exhaust the study of invertebrates. So for this particular lesson, we'll concentrate on arthropods. Arthropods. Now, why we are calling them invertebrates is because there is absence of a backbone. Absence of a backbone. So we have several organisms or groups of organisms that do not have a backbone. But for this particular study, we will look at arthropods. Okay? Now, I'll give you the general characteristics of arthropods, general characteristics of all arthropods. Before now, I can divide them into the different groups or subunits of arthropods. So, general characteristics of arthropods. Now, there was a chart that had some diagrams. But before that, I have a preserved arthropod here. I want you to look at it. It's not alive, okay? Yes. It's preserved. It's a preserved arthropod. You can see all the classification done here, very well labeled. But the common name is a crab. Are we together? So please view it as it goes round. Then we are going to open that chart over here. Then I'll invite you to come and look at some of the arthropods that are in this chart, then we discuss them. Yes, so feel free to come. As the preserved arthropod is going round, feel free to come and view this chart, because I'll ask you questions after this. We have so feel free to come. If you have seen the preserved kitabu yangu online imekataa kufunguka. My online book has refused to open. Mary Jones. It has. It has. I think it had even opened. I was trying to open the pages this way. It's here. Okay, let's go back to our desks. Thank you. Please don't fall on me. Tuko theory na nani yako? Tuko theory na Mark Davis yako ni sawa. Okay, let's be settled now. So we can now comfortably discuss about arthropods. We can comfortably discuss about arthropods now. Now, we are discussing the general features of all arthropods in such a way that when you see those features, you'll know that this is an arthropod. Are we together? Now, is there anything you have gathered from the preserved arthropod that was going round and also from the chart that you are just viewing now? I'd like to hear what you have gathered. Yes, Marlon?
The number of limbs.
Number of limbs.
I've seen that there are 8.
There?
8.
8. Or you were able to count the number of limbs?
Yeah.
Okay. So for that particular organism, it has 8 limbs. Where is the organism, first of all? Okay. Continue taking it round. All right. Another thing that you have observed, either from the organism, because some people have not seen it yet, or from the chart. Yes. They do not have a backbone. You've been able to see that from the chart? By the way, msidanganye. Yes. They have an exoskeleton. Where have you derived that information from? From the chart. Yes. Well-developed head. Okay. From the chart. They have segmented bodies.
Their limbs are joined to a segment of their body.
Is that specifically for arthropods? It is millipede, not millipede. All right, so let's note down the general characteristics. Thank you for that input. Please keep viewing the preserved crab. Because I know who I am dealing with, will not deal with live ones. Okay? Yes. I don't want you to break your legs, and then you see our windows don't have grills. So some people may jump through. Anyway, now the common characteristics is that all arthropods have jointed legs. All arthropods have jointed legs. Secondly, they do not have a backbone. Now, I teach my students, when you are writing an answer concerning anything, avoid using a negating statement, like they do not have this. So you can just say absence of backbone, okay? Yeah, because some students, when you ask a question, they write no. No as an answer. Okay? Yeah, so you should always give your answer in scientific statements. All right? Yeah, so you can say that there is absence of backbone. Now, they have an external skeleton referred to as exoskeleton. They have an external skeleton referred to as an exoskeleton. Now, I want to mention something about the exoskeleton, is that the exoskeleton is what makes them to be able to live on land without drying up. You can imagine how tiny they are and how conditions can be harsh. All right? So the exoskeleton actually protects them from desiccation, from drying up. So that's important to note. It's also important to note that they all have segmented bodies. They all have segmented bodies. So some have 2 body parts, some have 3 body parts. It depends on the class. So what we have just mentioned is applicable to all. Yes, Enoch.
Since you are using all, that means you still use some.
Some have? No. We are looking at characteristics that are applicable to all arthropods. Then now we will narrow down to the 4 subunits of arthropods. All right? So we have 4 classifications of arthropods. We have insects. We have 1. We have arachnids, Insecta arachnida. We have crustaceans. And we have myriapods. we have myriapods. So I asked you to come and look at the images here in this chart because you don't have them. You do not have them in the handout, okay? So after we classify the 4, you will tell me the preserved one belongs to which classification group here. Are we together? Now let's start with insects. Insects. Give me examples of insects. Sorry. Give me examples of insects. Sarah. Houseflies. Bees. Enoch? No. No. Yes, Darlene. Butterflies. Ants. Imelda, you're quiet. Hey. No, my sister. Okay? Let me disagree. Yes, Fabian? Wasps. Yes? Dragonfly. And all other types of? No. Mosquito, it is. Yes, Alvin? Grasshopper. Sesefly and all other types of what? Flies. Are we together? Now, let's talk about the characteristics of insects, okay? Now, of course, we know that insects are arthropods, so they have segmented bodies, they have jointed legs, and they have an exoskeleton. Have we agreed on that? Yes. Now, when it comes to the segments, they have 3 segments. Insects have 3 segments. We have the head, the thorax. Very good students. Head, thorax, abdomen. So they have 3 body parts. Head, thorax, and abdomen. All right. And of course, I have mentioned everything we had written as a characteristic of arthropods is applicable to insects. Are we together? Yes. So, any other unique feature of insects that you can remember seeing here? Yes, Haron again. They have wings. Good. Now, they have 2 pairs of wings, but some do not fly with all the 4 wings. Okay? Some fly with 2 wings, but they all have 2 pairs of wings. Let me hear other characteristics. Let me hear from Lenny.
Can you say they have compound eyes?
You can say. Yes, they have compound eyes. Yes? They have 3 pairs of legs attached to the thorax. Guess what? 3 hours done. Evo to 63 to go. Huh? All right, so they have 3 pairs of legs or 6 legs. Now, don't just say legs, but say jointed legs. Okay? And then they live on land and breathe through the trachea. Now, if I decide to go to discuss the breathing system of insects, it will take us another 3 hours. So let's not go delve into that, okay? Yeah, but just mention that they are terrestrial. They are terrestrial and they breathe through the trachea. So we have discussed about examples of insects. So let's go to arachnids. Arachnida. I want to hear your your examples of arachnids. Yes, Sarah. Spiders, yes. Ticks. By the way, who has never seen a tick? Tick. Are you sure you've all seen ticks? Yes. Where did you see ticks? On cows? Yes. Alvin, please. Alvin has never seen a tick. Huh? Yeah, so ticks are examples of arachnids. Yes, Bramwell? Crab. No. No. You. Yes, Dama. Fleas. Yes. Fleas are, and lice. Lice. You see, like the lice that is in somebody's head. People who don't wash their braids, their heads. Yeah, that used to be common. It's actually common in pets. Fleas are common in pets, okay? All right, so we have others like scorpions. Are we together? Scorpions are arachnids. So I won't repeat the general characteristics, but we can discuss the specific ones to arthropods, all right? Now, the first thing you need to know is that arthropods, now remember we said insects breathe through trachea. Arthropods breathe through gills. Arthropods breathe through gills. So they are terrestrial, but they have what? Gills as the exchange surfaces, gaseous exchange surfaces. Then arthropods have how many pairs of jointed legs? 4 pairs of jointed legs. In total, 8 legs. Now, before I mention where the legs are attached, I don't know where it was going. It's behind here. Before I mention where the legs are attached, we need to note that arachnids have 2 body parts. Arachnids have 2 body parts. We have the cephalothorax, which is like a combination of head and thorax. Okay? Now, cephalo means head. The head. So, cephalothorax is a body part that has both the head and the thorax. So, the 4 pairs of jointed legs are attached to the cephalothorax. So, 2 body parts. We have the cephalothorax. And we have what? The abdomen. Cephalothorax and abdomen. So I want to show you through my electronic device one. So I'll go around. Are you done? Don't be scared. It is in the iPad. You know, I hear people saying, oh, I have a phobia for spiders. So even when they see a spider in a book, they want to run away. All right. You can smile. You're not contributing in class. You're not contributing in class. Huh? Is it clear? So that's an example of an arachnid, specifically a spider. All right? All right. So we are done with arachnids, then we can move to crustaceans. We can move to crustaceans, and this is an example of a crustacean. All right? Now, crustaceans breathe through gills because most of them are aquatic. They breathe through gills because most of them are aquatic. They have more than 4 pairs of jointed legs. I was surprised when you said that this crab has 4 pairs of jointed legs. 1, 2. Some of the limbs have been tampered with for this one. Okay? Yeah, so crustaceans have, some have 8 pairs, others have 12 pairs of jointed legs. Are we together? Depending on how big the organism is. This is among the smallest crabs. Are we together? You can have a crab as big as this. Are we together? Yeah, so the bigger the organism, the more legs it has to enable it move from one point to another, okay? Now, the other thing you need to mention is that the mouth parts of both arachnids and crustaceans are modified to be able to bite and suck fluids from their prey. Their mouth parts are modified to be able to suck fluids from their prey. And that's why a tick can attach itself to an organism like a cow. Okay? And it will not fall off unless it is removed. So that shows you how strong their mouth parts are, even fleas and all those organisms. So lastly, we look at myriapods. Now, myriapods are divided into 2. Myriapods are divided into 2. We have millipedes, and then we have centipedes. Okay? Now, it's important for us to look at both classifications of this, because one of these is poisonous. And for your own safety, it is important to know the difference so that you don't see the one that is harmless and you jump. And then you don't see the harmful one and then you go to say hello to the harmful one. Are we together? Yeah, so it's important to know that actually one of the reasons why we study organisms is for our own safety as well. Eh? Yeah, so that when you find a small child playing with a snake, you know what you're up against. Are we together? Yes. Now, millipedes comes from the word million. Are we together? Meaning that they have numerous legs. Okay? Now, how we are going to describe the legs of millipedes is, we start by saying that millipedes have numerous body segments. I'll show you the photo of a millipede and that of a centipede. So millipedes have numerous body segments. And in each body segment are 2 pairs of legs. In each body segment are 2 pairs of legs. Full stop. Mention that millipedes are dark brown or black in appearance. Millipedes are dark brown or black in appearance. And then millipedes are friendly and herbivorous. So that means a millipede may not really bite you because by nature they are friendly and herbivorous, meaning that they feed on plants. All right, so let's go to centipedes. Centipedes have numerous body segments. Centipedes have numerous body segments, with each segment having a pair of legs. With each segment having a pair of legs. With each segment having a pair of legs. Centipedes are poisonous and carnivorous. Imagine. Centipedes are poisonous and carnivorous. Have you started feeling cold? You can close some windows. Not yet. No, don't say no, not yet. I'll see you at 3 a.m. All right? Then we need to mention the color. Centipedes are light brown or red in color. Centipedes are light brown or red in color. So I'll ask Haron to go round, showing you the image of a millipede versus a centipede. Musimuangalie vibaya. No. Why are you shaking? Are you okay?
Yes.
So we have an exam on Friday. Wow. Huh? And the exam, this one is asking marks. And the exam will cover everything we will have learned from the first hour to the 65th hour. Yes. So the 66th hour will be an exam, okay? Yeah, so you'll sit very far away from each other. Hey, Haron, you're only showing the students. So, so if you are to meet with two living things, a millipede and a centipede, would you recognize the difference? Yes. Yes. So now you know who to say hi to and who to evade or run away from. So millipedes are harmless, totally harmless. If you take a millipede, it will just coil itself on your finger, but it is not harmful in any way. Okay? Yes. And I think that marks the end of the animal kingdom. All right? Have we gathered something? Okay, thank you, Haron. Now, we are going to the second kingdom. And here we need to get a complete plant. Draw this plant and label it indicating the uses of the plant parts. Do we have a complete plant here? I'll call someone on the board before Mark Davis gets us a complete plant. Now, some people need to go for their health break. That is group. Group 2, please go for your health break and enjoy before you come back. Yeah, group 2, they definitely know themselves. Email, okay, group 2 is Clarice, Ramwell, Damaris, Were, Maston, Sarah, Omol, and Gideon. Please go for your health break and come back as soon as possible. All right. We are waiting for you. Okay, so you have to go and plug. Okay. So I need 2 students to accompany Mark Davis. Hey! To accompany Mark Davis. Okay, it's okay. You can go. To accompany Mark Davis to bring us 2 complete plants. We just pluck, even if it's outside here, a plant that has all the parts. Meanwhile, I'll call Martin to come and draw for us a complete plant on the board. Right? So let me write for you the topic. Now we have different colors of pens. We have blue, if you need to show us some plant organs in blue. And I think we should be having red somewhere. Excuse, we are drawing a complete plant. Thank you. Sorry? Okay. I think I can have someone on the side drawing another version of a complete plant. Please come. Dolin. So stand over there and draw for us a complete plant. Thank you for those who have gone to get for us the specimen. We appreciate. distribute it round. At least let everyone have access to a complete plant. Now please look at the plant you have there and draw it in the space provided in the workbook. Engineering students, hello? Thank you. So any part of a complete plant that you know, Dorleen and Martin, include it there and label. The rest of you, please draw a complete plant, a complete labeled plant in your book. Harold, you know, even if you look at me, I'm not going to draw it for you. Huh?
I was thinking of
two types of plants.
Yeah.
Okay. I think that should take us 3 minutes. So by the 5th minute, we should be done. By the 26th minute. By the way, you are allowed to stretch if you feel like stretching, okay? Yeah. As long as it doesn't interfere with the lesson. Thank you, Martin. Thank you, Dorleen. Let's clap for them. Okay, now let me talk about the plant. We have two types of plants. We have flowering plants and non-flowering plants. All right? Now, for all plants, we have the shoot system and the root system. Shoot system and root system. Now, the shoot system is anything above the roots. The stem, the branches, the leaves, the flowers, all that is the shoot system. So on Martin's diagram, the shoot system comes up to that part. Shoot system. And then going down, we have the root system. All right. So I'll give you 1 more minute to complete drawing your diagram and labeling it. Wow, Dolene's diagram is very interesting. Wow. And Martin's as well. I think they have really tried, yeah? Yes. Drawing on the board is not easy. Yeah. It's actually easier drawing on a book. Now, alongside the parts, write the function of each part that you have labeled. Then I'll get to hear from some of you what you wrote. Now, please, the challenge is not for enduring cold, okay? If you feel cold, please put on your hoodie or a sweater and a lab coat on top. We will not get more marks when we endure cold, okay? Yes. So I want to start hearing from you the parts that your plant has and the functions of those parts. Chito? Stem?
Transport minerals to different parts of the plant.
Yeah, the stem transports minerals, but not just minerals. You've limited yourself. What else does the stem transport? Water. What else? Or should I spare you that one until we do translocation? Now, I'm just wondering whether I should spare them the other function of the stem until we do translocation. But anyway, the stem transports water and minerals, okay, to different parts of the plant, and also transports the products of photosynthesis from the leaves to different parts of the plant that could be needing those nutrients. So you have exhausted the need for the stem. Another function is supporting the plant. Imagine a plant without a stem. Interesting, huh? Yeah, so that's the other function of the stem. All right, which other part do you want us to discuss? The roots. Roots. Let me hear. Yes, Fabian?
Anchors the plant to the ground.
The roots anchor the plant to the ground. So that is, we call that anchorage. And then for the stem is support. Okay? Yes. So the function of the root is anchorage. Another function, yes.
Absorbs water and mineral salts from the soil.
Sorry?
Absorbs water and mineral salts from the soil.
Yes, absorbs water and mineral salts from the soil, and of course relays them to the stem. Then the stem now takes them up. Any other? Yes? Food storage. Any examples of plants that you know store their food in the roots? Yes? Cassava, yams. No, for potatoes, that is the stem. Potatoes are stem tubers. So the potato is actually a stem. Okay? Yes. Carrots. Yeah. Yeah, sweet potatoes. Yes. It's just the Irish potatoes are stem tubers. Okay? Yes. For gaseous exchange in some plants. Aquatic plants. Thank you. All right. We go to which other part? The branches. The branches. To which part are the branches connected? The stem. And what's the function of branches? Supporting other organs. Okay? The branch supports other organs like leaves, fruits, flowers. Now within the branches we also have vessels that help in transport of water, mineral ions, and food substances produced through photosynthesis. Now, let's go to another part. Now, we go to the leaf. I think we can move a bit faster. The leaf. Yes.
Where photosynthesis takes place.
Yeah, leaves contain the green coloring pigment, chlorophyll, where photosynthesis takes place. So they are basically the organs that produce food for the plant. What have we not talked about, Maitha? Sorry? No, what have you labeled in your plant that we have not talked about? Flowers. Lenny, what are flowers for in a plant? Stop doubting yourself, because you started by saying the right answer, then you doubted yourself. Yes, flowers are reproductive organs. So this is where reproduction takes place, sexual reproduction in plants. Now remember, we are talking about flowering plants. I said that plants are divided into two, flowering and non-flowering. Angiosperms and gymnosperms. Yes. Gaseous exchange in plants. Yes. Yes. Now quickly in your exercise books, we can look at non-flowering plants. And the non-flowering plants, in non-flowering plants we'll refer to ferns. Who has not rubbed the board yet? Have you rubbed the board? Everyone will rub the board. Trust me, by 66 hours, all of you will have rubbed the board. Who is this putting their hoodie in the sink? You've already done it. Do you have a big head? So ferns are actually complete plants, but they are non-flowering plants. All right? Fans. So one thing to note about fans is that they are green, meaning that they perform which process? Photosynthesis. Now their leaves are called fronds. Their leaves are called fronds. I'll go around showing you how fronds look like. I don't know if they're here in this chart. Fronds. Fronds. Now, can you register how actually? No. Fronds. All right. All right. Now since they do not have flowers, they reproduce by spores. They reproduce by spores which are on the underside of the fronds. They reproduce by spores which are on the underside of fronds. Now the reason why we went for complete plants is because I want us to skip to 1.7. 1.7, where we are going to look at now the two categories of flowering plants, which are monocots and dicots. Now I'm happy because from the specimens that have been brought, it's still okay. From the specimen that have been brought, I'm able to see monocots and dicots. So it's good because we are going to see, no, this is dicot. So it may not be 100% clear, but at least we have some that we can refer to. Are we together? Yes. So make sure at least you can see a monocot. We'll describe how they look like and then write, draw, describe, view them. Yes. So these unique types of leaves, what do we call them?
Network.
Huh? Network veins. No. Fabian, no. Variegated leaves. Let's clap for Sarah. Now, these variegated leaves have some parts that do not have chlorophyll. Or rather, this part of the leaves does not have chloroplasts. Are you together? Yeah, so that's just an example to show you. Now we are looking at monocots and dicots, and the aim is to fill this table. Are we together? Now, do we have a complete plant of a monocot? Where is it? Is it a complete plant?
Yes. Yes.
No. This is not a monocot. A complete, good, perfect. So this is a complete plant of a monocot. Are we together? So the first factor that we are looking at here is the roots. You will need to leave your sitting space and come to the front where I'm going to place this monocot. Observe the roots. Tell me whether these roots are fibrous or tap roots. And then you draw the feature as you have observed. Okay? So we'll do feature by feature. Now I have a complete dicot as well. A complete dicot plant. Here it is. So I'm going to place the monocot on the left, my left, and the dicot on my right. So you come and view. All I want is in 2.5 minutes, we should have done both the roots of the monocot and the dicot. Let's get moving. So the dicot is here. The monocot is here. Whose book is this? Feel free, feel free. Niko sawa. Nilikuwa nataka kuchapa 6 ndipo tupate 30 minutes. Tunaona tunaenda 4. Kuoga na kukula hiyo 30 minutes. Nikipata homa na ni day 1 maji wataniumia. Five and a half. And then they bring a car. They bring a car somewhere here. A car. When you tell them, they'll just, even if you tell the security lady, she'll do it. No, he has gone for a church service and then he's coming. He has gone for prayers. We should be here before 10 p.m. Okay. Oh, interesting. Okay. Okay. So, thank you. Yes. 30 more seconds. We conclude on the roots. Now, please follow the instructions as it is in the table. Now, under monocots, you're saying whether it is fibrous or taproot. You're just saying. And then now, there is a whole space there given for drawing the feature as it has been observed. Okay, now, so I need to hear your observations. Now, for monocots, what type of roots do we have? Fibrous roots, meaning that they are all originating from the stem, okay? And they are not interconnected. Have you observed that? Okay, what about dicots? They are taproot or a main root. And other smaller roots are originating from the taproot, okay? Now let's go to the leaves. Now, using the same plants, walk to where the plant is, observe the leaf venation. We have two types of leaf venation, parallel and network. So observe still from the two plants that we were using. Write for us which kind of leaf venation is there, and then draw the feature as observed. So I think you'll have two diagrams in that space for drawing, yeah? Yes. So those who have just come from the health break, we are in 1.7 in the workbook. We are looking at the characteristics of monocots and dicots. So we have already looked at roots. Then now we are looking at leaf venation. So I'll push to 6. I'm not seeing people walking to the plants and observing the leaf. Please don't assume. It's a practical session. You're supposed to observe and draw what you have observed, not what you know. So look at the full leaf and draw it as you have observed. Now, if you feel like the observation from the plant is insufficient, you can come to this chart as well and look for the leaf venation of different plants. The cotyledons, yes, Fabian? Yeah. That table empty, all right? Okay, let's go back to where we were. Now let's go to fungi. Let's go to fungi. How many love bread? How many love bread? Oh, the ones who are not raising your hands, you don't love bread. You love it. Okay. Anyway, when bread takes a long time, or rather when it starts becoming stale, okay, then there is fungi growing on that bread, what we commonly call molds. Are we together? Yes. Now I'm opening where my all right, I'm opening where my notes for fungi are. Good. All right, now I had said earlier that we used to classify living things in two. You remember? Two kingdoms only. We used to have animal kingdom and plant kingdom until through further analysis of the characteristics and the features, we now ended up with 3 more kingdoms. So fungi is actually a kingdom, and for a very long time, fungi were classified as plants, okay? Now, they belong to their own kingdom, all right? And examples of fungi are mushrooms. Mushrooms are fungi. We also have the mold that grows on bread. Now, fungi are very important because we use them to make antibiotics like penicillin. We use them to make antibiotics like penicillin. And some fungi are harmful. Some fungi are harmful, and they are responsible for food decay. So, of course, you know, when you take food that is decaying, you'll get a few diseases. And some diseases not related to the digestive system that are caused by fungi are ringworm and athlete's foot. Athlete's foot at some point used to be very common. I don't know, are you aware of that disease? How many have been to boarding school here? Now, when you bathe and you don't wipe in between your toes properly, you end up getting cracks. Anyone who ever experienced that? And you have to put some antifungal powder. Okay? So that is a fungi that causes, a type of fungi that causes athlete's foot. All right? Now, characteristics of fungi. Number 1, they do not have chlorophyll, meaning they do not photosynthesize. They do not have chlorophyll, meaning they do not photosynthesize. And they feed in 2 ways, because we have to account for how they feed. If they cannot make their own food, then we have to account for how they feed. Now, they feed in 2 ways, saprophytically and parasitically. Do you remember those? So modes of feeding of fungi. Now, what's the difference between these 2? When an organism is feeding saprophytically, it means that it has attached, yes. Louder. Saprophytically. Yes. So they attach themselves to dead and decaying matter. Okay, and they absorb the nutrients that they require from the dead, decaying matter. So it doesn't matter which decaying matter we are talking about. It could be an animal and it could be a plant. So that is saprophytic feeding. And what about parasitic feeding? Yes, Clarice? Yes, for us to qualify it as parasitic feeding, then they have to attach themselves to a live, living organism, whether it is a plant or an animal, all right? Now, the third way in which they feed is by absorbing organic matter. By absorbing organic matter from material like feces. Are we together? Could be feces of cows, like feces of any animal. So you'll find some fungi growing on such organic material and absorbing nutrients from this organic material. All right? So those are modes of feeding of fungi. Now the cells of fungi have nucleus. Of course, one of the main reasons why they were classified as plants is because their cells have a cell wall. Are we together? Their cells have what? A cell wall. So that was qualifying them to be plants and not any other classification. So I think I'm done for fungi. We can move on to the next kingdom. What's the next kingdom in your book? Protoctists. It's proctists. It's actually protoctists. Please correct that. It's protoctists, not proctists. Protoctists. Protoctista. Protoctists. Now, an example of a protoctist is seaweed. Are we together? Now, the cells of protoctists have nucleus, but there are some that have chloroplasts. Are we together? So the ones that have chloroplasts, they tend to behave like plant cells. But because of other features that they could be having, they are not classified as plants. Now I'll give you two examples and I'll show you the images of these two examples. We have paramecium. We have paramecium and we have chlamydomonas. Chlamydomonas. Now, I'd like to mention that most protoctists are pathogens, meaning that they are organisms that cause what? They cause diseases, okay? So you can see the chlamydomonas has chloroplasts, but because of the other features that it contains, it actually even has a cell wall, but because of those other features, it is not really classified as a plant. So there's actually a thin line between all these. Actually, the distinct separation is in plants and animals. Like you can't confuse features of plants and animals. Are we together? But when it comes to protoctists, and even we are going to look at prokaryotes, the line is thin, the separating line, yeah, for the features. So I want to show you paramecium. And I want to show you chlamydomonas. You will see chlamydomonas is quite unique because it has almost all the features of a plant cell. All right? So, oh, you already have it? Ah, nice, nice. Okay, so then we can write the features. So the ones that have chloroplasts, they make their own food through the process of photosynthesis. And the ones that do not have chloroplasts, they feed on organic substances made by other organisms. So they feed heterotrophically, the ones that do not have chloroplasts, by absorbing food or nutrients from other organisms. So let's go to E, which is prokaryotes. I have provided you with a diagram of a prokaryote. Now, we will refer to that diagram again after we look at plant cells and animal cells. All right? Because I'll want us to draw a table indicating the differences between a plant cell and a bacterial cell. Okay? Reason being, they have almost the same features. So we need to know where the differences are. So when it comes to prokaryotes, this is where bacteria falls in. Okay? So prokaryotes basically carry the bacteria. Prokaryotes carry the bacteria. Now, the most interesting thing about the bacteria is that they do not have a nucleus. That's the most unique feature of bacteria cells. They do not have nucleus, but the DNA strands are coiled. So, you know, ideally, the DNA is inside the nucleus, but for this, the DNA strands are just coiled and are somewhere centrally placed within the cytoplasm. So, there are some terms that you may not understand at this point, but when we look at the cells and the parts of a cell, now you'll be able to connect the features I am talking about, okay? So please note down that they do not have a nucleus, but have a strand of DNA, strands of DNA coiled, strands of DNA coiled within the cytoplasm. Now, other features is that some bacteria carry out photosynthesis, meaning that they have chloroplasts. And in the chloroplasts, we have chlorophyll. Another important fact is that bacteria are unicellular, meaning they are single-celled organisms, complete as a single cell. Unicellular. Now, they have cell walls, and their cell walls are not made of cellulose, like the way other plant cells are, but their cell walls are made from a substance called peptidoglycan. Peptidoglycan. So they have cell walls made of peptidoglycan. All right? Now, most bacteria cause diseases. For example, typhoid. Typhoid is caused by Salmonella typhi bacteria. Salmonella typhi. Now, Salmonella typhi is a scientific name, meaning that we'll write it following the binomial nomenclature rules. Salmonella typhi. Okay. And then cholera. So this bacteria is responsible for the typhoid disease. All right. Now, cholera is caused by a bacteria called Vibrio cholera. So these are responsible for the cholera disease. And many other diseases, like even throat infections, many blood infections come as a result of over-multiplication of bacteria within the body system. All right? Any question about the 5 kingdoms? I would want to bring classification to a close. I don't know if there are other students going for a health break at this point. Okay, if you're going for a health break, please go now. Then, which group is going for a health break? So group 3, we have Imelda, Faith, Bilha, Cynthia, Lenny, and Haron. So take a quick health break and come back. Okay, we continue. So now we are going to the dichotomous keys. Now, dichotomous keys help us to identify organisms that we do not know. Di actually means two. Bi, di means two, okay? So, dichotomous keys help us to identify organisms that we do not know, using their features, So these features are given in sets of 2 descriptions. So hence why we are saying dichotomous, okay? So we basically look at the physical appearance of different organisms, and also you can actually construct your own dichotomous key and identify the features of the organisms that you're trying to classify, all right? So I have a dichotomous key there, or rather I have an example there that we are meant to do together, and we are meant to construct a dichotomous key. Now I want you to go to problem 2 and problem 3, in the next page, problem 2 and problem 3, just to see how a dichotomous key should look like before we start constructing our own. So the first set of descriptions, the first pair, which is 1A and 1B, should generalize, like it should be able to separate those organisms into 2, all right? Into 2 distinct groups. Then now it will keep leading us to the next set of descriptions. And now through keen observations of the features present, at the end of the dichotomous key, you'll be able to say organism 1 to organism 10, you'll be able to identify them by their names, and using the flow of the characteristics, you can tell the features of those organisms. Are we together? So let's go to the example. We will do this dichotomous key together. Okay, so we have organisms A to E. Are we together? So we are supposed to construct a dichotomous key. Then through that dichotomous key now say A has these features, B has these features, like that. So give me a set of descriptions that will divide the organisms into 2. Give me 1A and 1B. Yes, Bramwell?
A has a backbone and B has no backbone.
As far as I'm concerned, organism A, B, C, D, and E, none has backbone. None has a backbone. They are all invertebrates. Bramwell, you okay? Okay. Yes, Marlon.
The presence of limbs, we have A has limbs and B has no limbs.
So presence of jointed limbs and absence of limbs. Do we all agree that's a feature that separates them? So 1A, absence of limbs, We are constructing this together, okay? Absence of limbs. Which organism is that? Which organism is that? A. Now, presence of jointed limbs. Now, because we have several that have jointed limbs, it will direct us to description 2. So we say go to 2. All right? Now, let's go to 2. Now, other than A, look at all the other organisms there and give me a feature that will again divide those organisms into 2 distinct groups. Yes, Marlon?
The body parts.
Mm-hmm.
We have a particular group that has 2 and the other has more than has 3.
So which words would you use to separate this into 2 features?
Has 2 body parts, and for B has 3 body parts. Or we can just say it has a cephalothorax.
Okay, you see here, we have 2 organisms that have cephalothorax. We have one that has 3 body parts, and we have another one that has numerous body parts. So the way you're describing the body parts may not really give us 2 descriptions. It will end up giving us 3, and the dichotomous key should have a set of 2. Yes, Marston? Again?
Has 2 body parts.
Uh-huh.
Has more than 2 body parts.
Great. 2 body parts. And then more than 2 body parts. Now, for 2 body parts, it will take us to 3, okay? Now, leave this one pending for now. Leave this one pending for now, all right? So, let's go to 3. So, 3A and B. Tell me. Hey, where? This area. Tell me. So we are looking at the ones that have what? We are looking at the ones that have 2 body parts. That's D and E, right? Yes. Aha. It's very easy to separate those 2. It's very easy to separate those 2. Yes?
For number 2, couldn't we have the presence of wings so that we could exclude E and then
we could
have the rest?
Yeah.
For number 3.
Yeah, we could. He has a very valid question. He's asking, for 2, couldn't we have said presence of wings and absence of wings? And I'm telling him it is correct. If we had gone the direction of wings, it would have been correct, and we would have classified organism C at 2A for presence of wings. And this is where now it's going to get interesting when we start constructing these dichotomous keys independently. So you'll find that your dichotomous key may not look like your friends, but at the end of the day, the dichotomous key is describing those organisms, okay? So it's still correct, all right? But because we have taken the direction of body parts, we continue with that. So can we now separate the organisms with 2 body parts? Yes? Is it visible from this diagram that D has more than 4 pairs of legs? So we can't use that. We are only using visible characteristics. Open your eyes wider. You must have the name. But you see, those are limbs that have just been modified to something. Okay, they are called pincers. Okay. But can we describe using the shell? Yes? Yes, Jelimo? No, darling. They are all arthropods. And we said that arthropods, all of them have exoskeleton. You may not see it, but it's there. It's just that for D, it's a shell that is visible. Okay? So do you agree with me that we can say has a shell and then presence of shell, absence of shell? Okay. Now, which organism has a shell? Sorry? D. And then absence of shell. Which organism has two body parts but with no shell? Sorry? E. So we have classified that. We come back to 2B, and 2B leads us to, tells us to go to 4. So give me a set of descriptions that will now separate the two. Yes? Presence of wings and absence of wings. The other thing you can say is presence of 3 body parts and then presence of 2 body parts. Many body parts. If you can count them, the better. We said that in science we are specific. All right? So minus the head, you can count the number of body parts. I don't know if we are all going to get the same number. Well, I've counted 9. So now, just to be safe, let's not use body parts to describe, okay? Yes. So we use presence of wings and absence of wings. Good. Presence of wings is of organism. Sorry? C. And then absence of wings is B. Okay. Now, using this dichotomous key, now let's write the characteristics of each organism using the dichotomous key without even looking at the diagram again. All right? Now, give me characteristics of A. Has no limbs. Now, which path have we followed to conclude this? Which path have we followed? 1A. Okay? Now, let's go to B. So what we are doing now, for us to get the characteristics, we start from where we have identified it, working backward, from known to unknown. Okay? So what is the first characteristic or feature of B? Sorry? Absence of wings. Absence of wings. And that is 4B. 4B. Another characteristic. Yes, because this is where we came from. So, has more than 2 body parts, and that is 2B, right? The third characteristic of B, presence of, okay, presence of jointed limbs. So are you seeing that using the key, it's very easy to describe an organism now? Because before you could not describe the organism. But after constructing the key, you're able to extract features of that organism from the key. So that's 1B. And so the path we have followed to identify B is 1B, 2B, and then we went to 4B. Are we together? Let's do for C. Now, where did we get C? All right. So the first feature is presence of wings, and that is 4A. The other one is has more than 2 body parts here. More than 2 body parts, and that is 2B. What about the third one is presence of jointed limbs? That is 1B, right? So what's the path for identifying C? What's the path for identifying C, someone? 1B, 2B, 4A. All right? I don't want to go to D, E. Is there F? So let me give you around 3 minutes to do for D and E. Hey, congratulations. Because you're not the owner of the channel. Because you're not the owner of the channel. Are we almost done? All right. Now there's a very interesting activity ahead of us. we are going to construct a dichotomous key to help someone identify 5 of our teachers. So in this case, I'll ask for 5 volunteers who are not students. Can be a volunteer from the media, can be a timekeeper, can be an independent witness, so that they can come and stand in front of the class, 5 of them, and then allow us to make a dichotomous key using the features that we can observe. Okay? Now, this is the criteria that we are meant to, observe. We are meant to ensure that each pair of characteristics describes one contrasting feature. Now, let's be careful about the comments we make as we are describing, okay? Okay, don't say flat tummy versus big tummy. Or don't say black versus white. Hey, we be careful and sensitive. Are we together? Yes. Yeah, so no derogatory descriptions allowed. You can describe the color of clothing. You can describe the type of clothing. You can describe, no, you can't describe height, because height then you will need to give specifications of measurements. Okay? Hair color, type of hair, is it long, is it short? Presence of beard, absence of beard. So I'm looking for 5 volunteers. Could be from the fraternity of lab technicians. So I just need 5. I'll sit somewhere at the back of the class and rub the board for me so that we make a dichotomous key. I want Jennifer, not Jennifer, Jessica. Sorry? Yeah, I'll just sit here. So we have 5. We need one more, and preferably a man. Thank you. So we have someone writing the dichotomous key. All right. We have someone writing up the dichotomous key. No, you're staying there with a pen. So we have 5 organisms in front of us, and we are supposed to identify them. You can give them letters. Yeah, so are we starting from the left or the right? Okay, so we are starting from the right. You need to stand close to each other so that we are able to contrast your features. Thank you. So first contrasting feature, someone? Yes, Martin? Presence of spectacles, absence of spectacles. So 1A and 1B. wait, we do that one. Mwalimu, write faster, please. Absence of spectacles. What should we do now with that? So we have already identified D. Yes, we have already identified D. And the only feature we have used to identify D is presence of spectacles. So D, thank you very much. Let's remain with the other 4 organisms. Clap for organism D. All right. Yes, you had raised your hand. Now, what measure are you using?
Let's say 30 centimeters.
You can't guess measurements. Yes, Fabian?
Presence of boundaries.
Yeah. It's actually a description. But is he fully bald? Receding? Yeah.
Interesting.
Eh? Okay, we can use baldness as a parameter here. Okay. Yeah. So let's classify B. So 2A, bald. Yeah, you can just write one word. Bald to identify B. All right, and then with hair, not absence of baldness. With hair, so that is 2B. Make sure you indicate it's 2B. Hey, you're mixing colors. So with hair now. Okay, now close in a bit. Okay, continue class. Thank you, organism B. Thank you. Yes, Evans?
Yes.
Presence of beard, absence of beard. Excuse me. The presence of beard is beards. Beards. Thank you. Okay, so we have identified organism E. All right. It's getting tougher. Huh? Yes, Alvin. Okay. Can we use another feature? Deborah.
Presence of lipstick, absence of lipstick.
Hi, even dimples.
Yes.
Yes, Cynthia. Presence of blazer, absence of blazer. Yeah, those ones you can see. Yes. Tall and short. What parameter are you using to conclude that the one who is short is short? And no, but do you have measurements to prove your point? So I think we can use what Alvin said. Okay? One is wearing a red long-sleeved shirt. Short-sleeved shirt. And then the other one is wearing a long-sleeved black top, or whatever you want to call it. So the red shirt is organism A, and then the black top is organism C. Yeah, let's clap for our organisms. Woo. Thank you. Okay. So we have done problem 1. So please write down your answer for problem 1. Now, That should take like 2 minutes. Writing or rather answering problem 1. Now, if you're done with problem 1, swiftly move to problem 2 and problem 3. Do them together. All I'll need from you is feedback from the 2 problems. I don't want you to work individually this time as part of testing that concept. So problem 2 should take you 2 minutes. Problem 3 should take you 2 minutes as well. If you have a question and you're stuck, raise your hand. I'll come to where you are. And we have permanent markers of what colors? For 4, yeah. Maston, I know you are done. Wait for us. You always go ahead of the teacher. So I think 1 more minute for us to conclude problem 3. Please let's use the permanent markers for Manila. I still insist we are not enduring cold, okay? So that we don't end up falling sick. I'd like a volunteer to come up and give us their findings for problem 2. Another volunteer on the right to give us their findings for problem 3. Maston, you can come up. I need one girl. I need one girl to give us her findings for problem 3. Now, if anyone is contending with their findings, we can discuss that. If we all agree with their findings, we move on to the next thing. So Marston, you're doing problem 2. I think this sweetheart here, mind me only. Go up in Tami. I want you to go and do problem 3. You have not yet done it. Did I give you less time to do the problems? Yes. Okay, let me add you some time. Those just coming in from their health break, we are doing problem 2 and problem 3 in dichotomous key. So you'll need to catch up with this. Okay. So please don't have any gaps in your workbook. Catch up when you come back. Sorry? I can't hear. The words like for the cat. Like this, I think. Chin. Chin, sini hapa. Sawa. Marston, please wait first. Wait first so that they finish. So let's look at problem 2 first. Let's all finish problem 2, and then we discuss it, then move on. Anyone going for health break? Okay. Is it? It has spikes.
It comes to long and skinny.
Mm-hmm.
2, 6.
Long and skinny.
Oh, wait.
Long and skinny. Yeah.
Oh, okay.
Yes. When we are all done with problem 2, let's raise our hands so that we discuss it. We should be finishing this topic in the next 12 minutes. Are we all done with problem 2? Students, hello. We are taking too long in problem 2. Please, if you're done with problem 2, just let us know. If you're done with problem 2, raise your hand. Up straight. The ones who are not yet done, I'll give you 30 seconds. Where have you seen it? Let me see. Go happy. Or chin whiskers. The ones that nywele zenye ziko kwa chini. Please, if you need clarification of a feature, raise your hand. Okay, I think we have dedicated enough time to problem 2. If you are not done, we will guide you. It means you're stuck somehow. How many are not done with problem 2? Okay, so Marston, come up. Give us all your findings from 1 to 9. All your findings from 1 to 9. And then if anyone contends with your findings, then they'll tell us how they find yours different.
We have problem 1.
No, don't explain. Just write for us your findings. As you tell us the organisms, like organism 1 is dog, organism 2, yeah.
Dog.
Right.
Organism 1 is dog. So it is 1A, has 2 or 4 legs. 1A.
Excuse me? No, that's not what I'm asking. Just write the name of the organism. So if everyone gets it the way you do from 1 to 8, then it means we all know the steps of identifying these organisms.
Organism 1 is dog. Organism 2 is, we have dandelion. Are we all in agreement? Organism 3 is house sparrow. Organism 3, organism 4, that is, sorry, that is, how do you call this? Nawal. Are we all in agreement? Yes. Then organism 5, Ponderosa pine.
Ponderosa pine.
Is Ponderosa pine, sorry. Organism 6, we have Balantidium.
Balantidium.
Are we in agreement?
Yes.
Excuse me, class. Are we in agreement?
Yes.
Now who, okay, do up to number 8 and then we'll
Organism
discuss.
7 is king cobra. Then the last one is stendak.
All right, let's appreciate him. Now, while he's still standing there, is there anyone who is contending with his findings? Yes, Alvin, tell us. Number 6 and 8. Come up to the board. 6 and 8. You're saying that 6 is stentor and 8 is Balantidium. Let me hear your views, class. Six is stentor. Okay, what feature have you used to say that 6 is stentor? Thank you, Maston. Alvin, come up. Alvin, come up. What feature have you used to classify 6 as stentor? Face the class, please.
I'm saying that because number 8. Where?
No, answer the question. What feature have you used to classify stentor as 6? Sorry?
Number 8 looks like a water plant.
Number 8 looks like a water plant. Looks like one. But does it have any feature that has been described there indicating that it is a plant?
No.
Yeah, so you need to switch the two organisms because of the features. So you can't say that 6 is stentor, there is stentor. Because stentor is anchored to the substrate. Are we together? Now when you look at number 6, it is not anchored to anything. But when you look at number 8, is it anchored somewhere? Yes. So actually that already disqualifies your answer. All right? But thank you for that input. Now, are we done with problem 3? Are we done with problem 3? Who had I selected to do problem 3? There's a girl I had selected. I'm yet to know all your names, but I will by the 66th hour. It's you I'm looking for. Diana, you're not done. I want a female species who is done. Thank you. So write for us all your findings for problem 3. If anyone feels her findings are not acceptable, they can raise their hands. So we should finish this in 1.5 minutes so that we go to another topic. You can write in bigger letters so that the people at the back can see. Use this to wrap. Thank you. For those who have not done, don't copy. Get findings. Get your own findings. All right. Let's appreciate her. You still need to stand there. Now, is there anyone contending with those findings? Anyone? Jalimo, are you contending? With which one? 7 and 9? So your 9 should be, your 9 is 7 and your 7 is 9? So what organism have you found for 7? 7. Trumpet fish. 7. Has pointed fins. Yeah, I'm trying to look at which feature we're using. Do you agree with our findings? We accept your apology. For some reason, you had me doubting myself also. Yeah. So I think with those many remarks, we are done with classification of both plants and animals, and we are also done with 5 hours. Yes. Yeah. We are done with 5 hours. Is there anyone who has not gone for a health break? At what point? Okay. Group 4 is the last group, or we have 5 groups? Okay. You'll tell us when they need to go? At 10. Okay. In the next 5 minutes. So let's go to 1.9. 1.9. Now, in 1.9, I'll divide you in groups of 4. So say 1, 2, huh? They have already divided you. So you know your group mates? Now, it's a very interesting activity ahead. Send one group member, and please choose wisely. Send one group member to come up to this chart and look at a plant cell and an animal cell. I don't see, oh yeah, there's an animal cell. Send one person to look at a plant cell and an animal cell. Listen to instructions. The person must observe how the cell looks like and at least be able to come out of here, Bramwell, with at least 3 main parts for the plant cell and 6 main parts for the plant cell and 3 main parts for the animal cell. In short, take a photo of the cell with your eyes so that when you go to your group, you will describe to them what you saw, the parts you saw of the cell, the animal cell and the plant cell. Then using this manila paper and the permanent markers that you've been given of different colors, you will make for me a chart. One side, or rather divide this chart using a ruler into 2. Draw for me an animal cell and a plant cell, clearly labeled. So how your chart will look like is dependent on the person you send over there. Thank you. Yes?
We only have one.
You only have one? There are some marker pens. Zile permanent zenye wanaweza tumia. Permanent zimeisha. Wanaweza tumia hizi zingine basi. Mtapewa.
There were only 2 groups.
okay, okay. Wacha watumie hizi zingine. Thank you. Alvin, you can give the other group. Is there a group without markers? Which one, miss? 2 groups didn't have markers? Okay, I think they are now sorted. Yeah, they are sorted. Now, if you need, listen, of course I will award marks for every group. If you need to use a different color of a marker, you can leave your desk, go take from another group, use and return to them. Okay? Be as creative as possible, and speed is of essence. So I'll be going around seeing what you're doing. Bekira kula na wewe.
Sikire kafuti.
Nasikia aje?
Niko sawa. Nasikia vizuri kwa hapa na wewe aje. Hata kama nisikanishi vitu vingine.
Thank you for this. Nishaanza kuwa pressed, but I've seen I can sustain 6 hours. I hope you have sent one person, please. If you are 2 from a group, exit. Okay, time for viewing is over. Now go back to your group and make the chart. I told you to take a photo of the cell with your eyes. Divide the manila. If your manila is torn, we can give you another one. Thank you. The faster, the better. The faster, the better. Are you working as a group?
Yes.
Okay. Hi Fabian.
Hi.
Are you well? You look happy.
Yes.
Okay.
So they are magnifying it because I'm
Okay. So I'll need the masking tape because I'll pin people's charts on the board. Also give your group a name. The names are also very interesting. Scientific names, please. Okay. We open one first. Okay, thank you. don't spoil the leaves. Okay? Don't spoil them yet. Yet.
Very nice. On the plant side, you can look at the location of the yes, I remember. These are the pixels. But still,
Nimerealize nikienda washroom naweza kaa 6 hours. Ndio sasa ndio nimeanza kusikia Now, once you're done, you come for the tape, and in your own constructive way and scientific way, use this tape to stick your. No, actually, we won't stick it on the board. I'll just need the camera people to go around taking photos. We are going to stick it on the bench. So you create space on the bench and stick it there so that it's flat enough. Then we can go around as if we are going around the museum, checking what people have done. Health break for group 4. Health break for Jessica, Evans, Jelimo, Alvin, Martin, and Brian. Health break for those. If you don't go for the health break now, I don't know up to what time. The activity is interesting. You don't want to go? Group 4, you don't want to go for your health break? Okay, you can stay. For everyone. Okay, group 4, please go. So if you are left alone, you'll have to do it alone. Nothing stops. You have to go observe. If you're not the one who observed, then you come and do it. Please go for break. If I have mentioned your name, wewe nimesoma jina yako Jessica, go for break. Yani we are forcing you to go for break. Keep walking, keep walking. Now, please don't go back to the chart. We were only viewing the chart once. I'm breaking in the next 45 minutes when it clicks 6 hours. This group, you're just laughing. What is it? Eh? Fabian?
Yes.
What's happening?
He doesn't have a clue of what he's doing. That's why.
Is he the one who went to see?
And then you add mitochondria.
Okay, can we take another, how many minutes? The whole of this group have gone for their health break. They have gone to compare. Who are those? Please don't go to somebody's group to check what they are doing. So in the next 4 minutes, you should be sticking your work on the bench. Stick your work on the bench. Allow us to come and view. Yeah. Is this the same experience you had when you were in high school?
Yeah, of course.
You had such a good experience?
High school, maybe more time for more explanations. So you just rush. But
Okay.
this one, it is really enjoyable.
Okay. Nice.
Good teacher. I wish I was in your school.
Thank you.
Yeah?
Thank you.
Maybe
You would have passed.
I could join nursing.
Okay, we can't use the light microscopes now. We can't. Oh, you didn't get? So we can't do microscopy, but we can do usual magnification. Okay. What specimen do you have that we can use for magnification? Anything? We can use the hand. We can use the hand. Yeah. I'll use. Yeah, I know what to do for magnification. Yeah, without a lens. Because what will we be viewing in the lens? No, we do free hand drawing. We measure length of drawing versus actual length. Yeah, and we have rulers already, so we'll do that. Okay, in the next 2 minutes, we should be sticking our work on the bench. Stick your work. The tape is here. Come, cut tape, stick. Even how you stick indicates something. Where are your group mates?
Yes.
Where are your group mates?
The man is here and the Dan is there.
Okay. Were you the one who went to observe?
Yeah, the animals. Okay, anaitanga Jessica ndio alikuwa ameenda, alafu sasa akifanya alienda kuna kingine sana.
Ati unasema ini cell walls, no. Cell wall, this is cell membranes, no. This one here.
Your back?
Yes. Venye mimi mzee. This is mitochondria. Chondria. Opposite one. Reticulum.
Mitochondria.
This is smooth. More smooth than the plastic.
Reticulum. I'm looking forward to the first group to tell me they have stuck their work.
Oh, this is golden. Ikiwa moja si ni gold ya apparatus. Ikiwa moja ni apparatus Okay, the tape is here. The tape is here. In 36 minutes. Now, you see what you have drawn? You see what you have drawn? Stick that and stop drawing. Please take the tape and stick it. Stick it, clear your space, step away from your work so that other members of other groups can view what you have done. And that we can take images of your work. Hello? Stick what you have drawn. Stop drawing. Take tape. Take tape. Take tape. Stick and step away. Why did you fold? Sorry? How will you stick for us to see? Because at some point we'll need to see the difference between a plant cell and an animal cell from your diagram. That's why I said one should be on the left. So anyway, just do this because you've decided to do your own things. Which one are you going to stick? Your plant cell is circular. Active.
That's why.
Yeah?
That's why.
Si basi ufanye hivi. Yeah, they are both on the same side.
You'll have to
transfer
stick this one, unfortunately.
I'll transfer it before it's too late.
Quickly then. Aha! Let us stick our work. Final call. Stick your work on the bench. Clear. Allow others to come and view and criticize. Now, you need to write the name of your group so that we can mention your diagram in accordance to your name. Yeah. Choose a name. No. Choose a group name, not somebody's name. What is the meaning of alpha? Please write names of groups. Just don't call any group Manchester United. Tape iko mahali. Once you're done with the tape, pass it to the next group. Now, once you're stuck, step away from. Go and view for others. Just close the pen. Yeah. Close the markers. They are supposed to last us until 66 hours. Thank you. How do you pronounce this?
Thank
you. Holland. Holland. Interesting. You're the one who has chosen the name.
Me.
Now, can you move around, criticizing the diagrams and the charts that other groups have made? Stick it. And you should also be willing for your diagram and your chart to be criticized as well. Criticism is a mode of learning. Stick it. Stick it. Why are you mixing capital and small letters? Aki wewe Martin. Is this Martin? Bramwell. Can you go round? Na sisemi mchekeleane. Just criticize. Go round viewing everybody's. Okay, once you have viewed for all the groups, go back and improve your own in 2 minutes based on what you have collected from others' work. Are you hearing the instructions?
Yes.
Yeah, view and then go back and improve yours in 2 minutes. In 2 minutes so that we move on to the next thing. Sorry. Okay, we are taking an extra 2 minutes. So in 5 hours, 33 minutes, we should be done improving our own drawings. the next 2 minutes, we should be done improving our own. I don't see people improving. So that is what we call peer learning. Are we together? Working together, looking at what other groups have done, and improving your own work based on their work. All right, group work is over now. Everybody back to your seat. Let's proceed. We have a few minutes to 6 hours, so we need to finish this topic. Okay, let's sit down. Group work is over. Maston and your group, Clarice, back to your seat. Thank you. Now, what is the cell? Go back to your workbook now. Back to your workbook, topic 1.9. Now, the cell is the basic unit of life. So if I am to take a living organism and try and disassemble that living organism into components that make that living organism, I would end up with billions of cells. Billions of cells are the components that make living things. So the cell basically is the basic unit of life. So plant cells have a different cell. Plant cells are different from animal cells in terms of the organelles. So the organelles are the parts of cells. It's important for you to mention that as well. Organelles are parts of cells. Now, before I even go to spatial cells and cell organizations, I want to draw for you just a simple animal cell and a simple plant cell. I think I need a green pen, green whiteboard marker. So I'll start with an animal cell. One thing you need to know about an animal cell is that it has an irregular shape. Animal cells, they have an irregular shape like that. Okay? Yes. Now inside the animal cell we have the cytoplasm, which is the jelly-like substance. Are we together? Yes. Then we have a central nucleus. Then we have mitochondria. Then we have the smooth endoplasmic reticulum, and then we have the rough endoplasmic reticulum that has granules called ribosomes. And that is how you easily draw an animal cell. That's just what I needed to see. Okay? So can we label it? This is a cell membrane. Now, when we are labeling biological diagrams, we label using horizontal straight lines. Are we together? The horizontal line should touch what you're labeling. I said this is mitochondrion. When there are many, they are mitochondria. Then we have the jelly-like substance called cytoplasm. Then we have the central nucleus, or you can just say nucleus. Then we have the smooth endoplasmic reticulum. Then we have the rough endoplasmic reticulum. And then what makes them rough endoplasmic reticulum are the ribosomes. In a minute, how long did I take to draw and label this? I think because I've been explaining, if I was not explaining, I would have taken around 45 seconds. So in 45 seconds, draw an animal cell on the space provided in your workbook and label it before I rub it and go to the plant cell. So the reason why I was asking you to draw on the charts, to make the charts, is as you draw, you now get the photograph of the cell in your mind. So it becomes very difficult for you to forget about, I don't think you'll ever forget about the cell, really. Yeah? So in a few seconds, let's finish. We are drawing using a continuous line, Mr. Haron. Good. This, you are supposed to draw this in the workbook. Following of instructions. 1.9 here. We are drawing in the workbook, not in the exercise book. Remember, this is not an art class, so don't take too much time producing for me perfect diagrams, okay? Yes. Permission to rub? Okay, I want to rub now. Okay, but there's space though. Let me use this side of the board. So I'm drawing for you now a simple plant cell. Well, I may not draw to the detail of this, okay? But you can be sure I'll capture most of the organelles that we require for this study. So the first thing we know is that a plant cell has a regular shape. So let's give it a regular shape, all right? In addition to having a cell membrane, a plant cell also has a cell wall, all right? Now, unlike animal cells, plant cells have a large central vacuole, and surrounding the large central vacuole, we have the jelly-like substance called cytoplasm, where all the other organelles are suspended. This large central vacuole just has water, salts, and sugars. Are we together? And as we continue with the lesson, you'll get to understand why the vacuole is very, very important in each and every plant cell. Now we have the nucleus. We have mitochondria. All right. Then the green marker I had requested for is for drawing the chloroplasts. So we have chloroplasts suspended within the cytoplasm. Now, without going into further details, let's label this. Now, because of space, I'm going to give them letters, all right? So this is A, this is B, cytoplasm is C, mitochondria is D, and chloroplast is E, cell membrane is F, cell wall is G. Are you together? Now, A, large central vacuole. B, nucleus. C, cytoplasm. D, we have, where is D? Mitochondria. We have E as chloroplast. We have F as cell membrane. And we have G as cell wall. So this one at least I'll give you 1.5 minutes to draw and label in your workbook. Now, I believe probably you don't have space to write the functions of the organelles, so you can switch to the exercise books so that we look at functions of different organelles. So by the end of this, we should know that each organelle has its own unique function within the cell. Now, I'm going to list them, and then we look at them one by one. We have cell wall, cell membrane, nucleus, cytoplasm, chloroplast, mitochondria, large central vacuole, eight, we have ribosomes. All right. So quickly, let's go to the cell wall. Functions of different organelles. Now, the cell wall surrounds plant cells and is made of a carbohydrate called cellulose. The cell wall surrounds the plant cell and is made of a carbohydrate called cellulose. So sometimes you will hear me call it the cellulose cell wall, because like we said earlier, the cell wall of bacteria is not made of cellulose, it's made of peptidoglycan. So when I'm saying cellulose cell wall, I'm specifically referring to the cell wall of a plant. Are we together? Now, so the work of the cell wall is basically to protect the internal structure of the cell and give the plant cell its form. To protect the inner structure of the cell and give the plant cell its form. So basically the cell wall supports what? The cell. Are we together? Yes. Is the support for the cell. Now sometimes a cell, okay, don't write this, I'm explaining. Sometimes a cell can be exposed to a lot of water and it ends up absorbing a lot of water through a mechanism that we'll discuss later. So the cell wall protects the plant cell from bursting. Are we together? If an animal cell is exposed to the same conditions, it will burst because it doesn't have what? A cell wall. So that's why I'm saying that the cell wall is the support for the cell. Now the next one is cell membrane. Now cell membranes are semi-permeable and they are found in both plant cells and animal cells. Cell membranes are semi-permeable or partially permeable. Or partially permeable. All right. Now, the cell membrane selects what goes in and out of the cell. I always call it the sieve of the cell. Are you together? Because it is selectively permeable. It selects what goes in and out of the cell. Now, it is a thin layer made of protein and fat. It is a thin layer made of protein and fat. Organelle 3, nucleus. This is where genetic information is stored. When you hear that they are doing a DNA test, they are extracting genetic information not from the whole cell, but only from the nucleus. Now, genetic information is stored in chromosomes, which are strands found within the nucleus, chromosomes. So the chromosomes are strands like this. And then along them now is where you find the genes and the codes for the genes. Are we together? Yes. So all those are found within the nucleus. So the chromosomes are made of DNA. Now, if we are to look at the nucleus in, or rather under a high-resolution microscope, you would clearly see the chromosomes. Okay? All right. Then we have cytoplasm. Cytoplasm is a clear jelly that is 70% water. If you're from UK, you can say water. Huh? And if you're from the US, you can say water. 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 Who says water? Oh, Nyandarua people. Yeah, so the cytoplasm is 70% water And different metabolic reactions take place in the cytoplasm. Now, please don't be shaken by the word metabolic. I simply mean chemical reactions that take place in the body or in a living organism. Okay? Yeah, so metabolic reactions take place in the clear jelly, which is the cytoplasm. Then I go to chloroplasts. These ones are never found in the animal cells, but they are found in green plants, in cells of green plants, and they contain a green pigment called chlorophyll. Okay, chlorophyll. And they also have starch grains in them. They also have starch grains in them where the products of photosynthesis are temporarily stored before they can be translocated to other parts of the plant. At this point, it's important for us to note that plants store food in form of starch. Are we together? That's why when you're eating ugali, rice, potatoes, you're eating starch. That's how plants store food. Swiftly, we move to mitochondria. Now, the mitochondria is a highly folded, double-layered organelle. Highly folded, double-layered organelle, also referred to as the powerhouse of the cell, because this is where respiration takes place. I repeat again, mitochondria refers to highly folded, double-layered organelles, also referred to as the powerhouse of the cell, because this is where respiration takes place and we get energy through the mitochondria. So, for example, our muscles have a lot of mitochondria in them because we need a lot of energy in our muscles for movement. True or false? And then there are some cells that do not really need a lot of mitochondria, all right? Like the skin cells, for example, all right? Beneath the skin cells, we have the muscle cells that have a lot of mitochondria. So you may find some cells with numerous mitochondria and some have less. But I've already given you a hint that muscle cells have what? A lot of mitochondria. Then I go to the large central vacuole. Now, the vacuole has the cell sap that contains a solution of salts and sugars. And it also presses outwards, giving the cell its shape. I've said again, the vacuole has a solution of sugars and salts and presses outward, giving the cell its shape. I may not go into the details of the vacuole, all right? We'll discuss further about the vacuole when we are talking about osmosis. Yes, yes. In 4 minutes. Then we have the ribosomes. The ribosomes are those small granules that you're seeing there that make a smooth endoplasmic reticulum to be a rough endoplasmic reticulum. Are we together? Yeah, so they are attached to the endoplasmic reticulum, and their work is to make proteins. The work of ribosomes is to make proteins. So some are bound to the endoplasmic reticulum. The endoplasmic reticulum basically is a layer of membranes, interconnected membranes, all right? So some are attached to the endoplasmic reticulum, and others are scattered within the cytoplasm, but the function is the same regardless of the location of the ribosomes. So the work of ribosomes is to create, or rather make, proteins from amino acids, all right? Now you need to note that ribosomes are found in all types of cells, whether it's bacteria, whether it's protocysts. I mean, all cells require proteins for growth to occur. So we find the ribosomes in all types of cells, and their function cannot be ignored. So, without going into the complexity of the cell, basically that is the structure of the cell. So you can compare what we have talked about with what you drew there and see what you would have done better, all right? So any question? Any question about the cell? So the next thing we are going to look at is before we even go to specialized cells, we are going to make a table for the differences between plant cells and animal cells. So I would want you to be thinking ahead about the differences between plant cells and animal cells. Are we together? All right. I want to show you how some of these cells look under a microscope, okay? Or rather, even some of these organelles look under a microscope. Like, for example, the mitochondria. I said it's double layered. So the first outer layer, and then the inner layer is highly folded. The inner layer is highly folded. So you can see. So when we use a stain and put this under a light or high resolution electron microscope, this is how a mitochondria looks like. It's the same way it looked like in the diagram. All right? All right? You see? I'll be back after 30 minutes. Bye. Plug this one. Plug this one to
CPF is a financial services company that offers a whole host of solutions to the Kenyan public and across the globe. We have been recognized both locally and internationally as a trusted brand, and the following are some of the reasons why you should be working with us. Currently, we provide fund administration services to the largest schemes in the country. One of them is Lab Trust, which is the oldest. Having been established in 1929, it currently has a fund value of over 30 billion Kenya shillings and membership of about 20,000 members. The County Pension Fund, which is also one of the largest in the county space, and the Public Service Superannuation Scheme. Overall, we have total assets under management of 100 billion. One of the biggest challenges in the social security sector has always been enabling people save towards their retirement. And one of the solutions that we have developed internally as CPF is called Rukisha. Rukisha is a concept that we developed primarily to address people in the informal sector, people with small businesses, people with big businesses as well. And the intention is to help them save towards their retirement. We have incorporated a concept called Save As You Spend into the platform, where for every transaction you make, you're able to save a percentage of it. And over time, you're able to see your retirement funds accrue. One of the other benefits of utilizing Rukisha is you also have access to other solutions within the CPF group of products, among them being investments through the CPF asset managers. You should be able to save towards a specific goal under the CPF asset managers. You should also have access to the CPF insurance products under the Laser Insurance Brokerage Services, as well as the real estate products within the Laser Property Management Services. For more information on Rukisha, visit www.rukisha.com. You can also access it through the shortcode *391# or download it in the Google Play Store as the Rukisha app. Talk to us, reach out to us, and we shall help you achieve your retirement goals.
At CPF Financial Services, we've been able to package the solution for both for the individual, for the corporate, and also for groups. At the individual level, we've come up with products that are able to take care of the member both at before retirement and after retirement. For before retirement, we have training for the member to be able to prepare themselves to go out there and be able to save for themselves. Also at that particular level, they can be able to save individually on a continuous basis with as low as 50 shillings every day or 500 per month to be able to take care of themselves at the point of retirement. At corporate level, we have solutions where we carry out fund administration for corporates that have already existing schemes, or they can be able to join our umbrella DC schemes within this called Taifa. We also do gratuity administration to assist corporates be able to administer the gratuity plans for their different staff within the organization. We also have solutions for chamas where we can be able to open up opportunities for them to be able to save and invest as chamas and also enjoy welfare solutions which are always covered under our trust fund called the Momba Trust Fund. As part of our solutions under the management and training arm, we also do management consulting. Under management consulting, we consult for you to do governance audits, we do strategy development, among other consulting services that you might request. We also do trainings. Under trainings, we have trainings that are bespoke to the organization, or they can already be able to come in at best prices to attend some of the trainings that have already been packaged by the CPF arm. For more information, visit our website on www.cpf.ke, or you can be able to access the information on the CPF app on the Play Store or the iOS Store.
Prayo bwana, asante kutupeleka holiday. Lakini na swali. Uliniambia tuna save na CPF. Kwani ukisave unapata pesa wapi?
Boni, unajua first una save, halafu una spend. Nilikuwa nishaweka kitu CPF kabla sherehe.
Oh, okay. Na kama sina kitu this month nafanyaje?
Usistress. Ukiwa na CPF, unaweza convert Safaricom Bonga Points zinakuwa contribution yako kwa M-Pension. Na ni rahisi sana. Dial *289# au piga 0111 114 000 na CPF watakusort.
Hello, my name is Faith Wanjiru Kinyanjui. I'm a 4th year student here at Jomo Kenyatta University of Agriculture and Technology. I'm pursuing a degree in horticulture, and this is my final semester. So I lost my dad in 2018 when I was in first year, second semester, and it was a 1 week illness. After his death, my life was kind of difficult because I didn't know if I was going to continue with my studies because my mom is a housewife. And so when I joined second year, my first semester, my mom introduced me to Lab Trust after she received some phone calls from my dad's workplace. And so we went with her because I'm usually here in Nairobi. So when we went, they assured me that they were going to pay my school fees and I didn't have to worry. So that was like a saving grace for me. And since then, my school fees has always been paid. My upkeep is always in check and my house is always in check. I've never lacked anything since then in second year, and up to now I'm in my fourth year, final semester. And as you can see, due to Lab Trust, I'm able to carry on my project. Here is one of them, and I'm studying the plant diseases, and I'm using a treatment known as silicone. Then I'm controlling the disease to see if it is going to be controllable. And this has become my passion, and I love agriculture so much. Right now I'm in my final semester, and by next year in January I'll be done with school. And my plan is, if I'm going to get a job, I can join the scheme, the Lab Trust scheme, and ensure even if when I'm going to have kids later in future, their lives are going to be catered for even in my demise, because CPF has done that for me, and I'm very grateful. Because if it weren't for them, I don't know if I could be even here in school. And thank you so much, CPF, for fulfilling our lives. I have two sisters at the moment, one in college and the other one is in grade 4 in primary school, and they have been paying for their fees as well. And we can say our life has never been the same, and we are so happy for CPF and how they have helped us. And thank you, CPF, for fulfilling our lives and making us smile again after everything.
In an uncertain world, trust is everything. Introducing Tamka Security Services Limited, your trusted partner in security solutions. At Tamka Security Services Limited, we understand that security is not just about protection, it's about peace of mind. That's why We specialize in providing comprehensive security solutions for homes, residential areas, and malls. Our team of highly trained security around-the-clock surveillance and protection. From guard services to K9 units, from installing electrical fences to providing quick response in times of emergencies, we also offer bodyguards and event security. Tamka Security Services Limited is your one-stop solution for all your security needs. With our commitment to excellence and swift action, you can rest assured that your safety is our top priority. Choose Tamka Security Services Limited for security you can trust. We are located at Rimpa along Magadi Road, and you can contact us on 0202 595098. Tamka Security Services Limited, protecting what matters the most.
His Excellency Mike Mbuvi Sonko, the Good Deeds Ambassador, crowned for his generosity in helping the needy. Sonko's move to help the needy is his way of life and started way before he joined politics. Hundreds of needy people from all walks of life can attest to this. Mariam Abdallah has been in and out of hospital, but Governor Sonko has always been there for the family.
Namshukuru sana mheshimiwa, yeye na familia yake, anawaombea sana kila nikiswali Mwenyezi Mungu awajalie kila la kheri.
Natoa shukrani zangu kwa mheshimiwa Sonko kwanza. Mwenyezi Mungu amjaze kila la heri. Amuondoshe matatizo yake, mazito amfanye mepesi. Familia yake Mwenyezi Mungu aijalie salama. Amenifariji mimi na amenisaidia mtoto wangu. Sikupata usaidizi wowote Mombasa zaidi ya kwamba ni hao katika wale wataja. Hamna mheshimiwa yote alikuja kunisaidia. Lakini nasema Mwenyezi Mungu yuko pamoja na yeye. Tumekuja naye karibu vizuri. Alhamdulillah, na ubaguzi. Ni mwanamume ambaye sijui niseme nani. Anifadhili kwa kila kitu.
Tunakwambia rudi after 2 months, lakini umetupatia karatasi ile kule Mombasa. Unajua umeshona na chuma ile kutumia. So watamtoa.
Umeshakatia ndege
kila kitu waziri alipasha shughuli.
Ni sawa. Kidogo ya dawa na supu damu ile kidogo. Haya, shika tuenda kununua na dawa. Sawa.
Kwa majina naitwa Mariam Abdallah Kombo kutoka Mombasa. Nimeshukuru sana kusaidiwa na mheshimiwa. Operesheni zile zangu za kwanza alinisaidia nikafanyiwa, na hizi za pili tukarudi tena pia amenisaidia yeye. Namuombea Mungu sana yeye na familia yake. Mwenyezi Mungu ampe afya, ampe umri, ampe nguvu na amlinde na azidi kuwa na imani na kusaidia.
Not once or twice has Governor Sonko intervened when the elderly are being neglected by the community.
Wewe nani mheshimiwa?
Hapana, hapana, wewe kuja mama.
Wacha kufanya hivyo.
Hapana, mama, wacha mama ingie ndani yake. Hapana, hapana. Hapana, haiwezekani. Twende mami.
Sasa ile
hapana
hapa.
Nimembariki nimempa baraka. Nambariki zaidi. Apande juu. Amen. Ile yote tutaweza. Ubarikiwe na Mungu. Tusikutane nangu.
Asante.
Asante sana. Baraka kubwa.
Hakuna mtu atakutoa hapa. Sasa uko na court order uko naye.
Times society neglects elderly people. A 100-year-old granny in Embo was forced to spend nights in jail for contempt of court, unable to pay a fine of 100,000. Sonko came to her rescue. Same story for a 106-year-old granny who was evicted from her land in Pangani, but Sonko helped her get it back. Several other people have also gotten back their grabbed land through the help of Governor Sonko.
Itakuwa registered kwa hiyo title yako na utarudishiwa hii shamba. Shamba yako itarudishwa kwa sababu tunaregister hii imetoka kotini. Kwa hivyo itarudisha hiyo shamba kwako sasa. Yes. Please. Hiyo tutafanya mara moja na itarudi.
What I have to say is that today I have managed to have access to Mheshimiwa, which not many people can have. I think it was God's grace that maybe our dad had done something very good for us for today Mheshimiwa to be standing here and assisting me, because we just seen Mheshimiwa in the papers, we hear about him, but today I've seen it with my own eyes what work he does.
He has such a compassionate heart.
Ninaguzwa sana na moyo wake wa huruma.
You know there is politics.
Kuna siasa.
And there is a core.
Na kuna mwito.
This man is not a politician.
Huyu si mwanasiasa.
When I watch the way he handles the poor people,
ninapoona jinsi anawashughulikia watu maskini,
then I know
basi najua
there is something extraordinary in his life.
Kuna kitu kisicho cha kawaida ndani yake.
Governor Mike Sonko, through Sonko Rescue Team, has continued with his charity work, which he began even before joining politics. Meet baby Kyla, a 1.5-year-old baby. Governor Sonko met Kyla's mother in Westlands, who narrated her daughter's woes to the governor. Sonko was touched by the story of young Kyla, who had lost her eyesight at a tender age and vowed to help her seek medical attention in India. Weeks later, she is back after the surgery. Kyla was received by Nairobi County First Lady after landing at JKIA.
Wow, you can see God is good. It's a miracle.
Wow. Since the day she was born, I noticed that she had some problems with her eyes, and I came to meet Sonko, and I told him about my story, and he decided to help me.
Beautiful baby Candy Chelangat, whose life was threatened by a cancerous tumor in her eye. Sonko took the initiative to pay for her medical attention in India. She is now a happy child in school. It is a story of joy.
Happy today, so thank you Sonko for everything you've given me. May God bless you. Thank you very much.
Late March 2019, Governor Sonko donated tons of relief food to the drought-stricken counties of Turkana and West Pokot. The governor traveled by road to Turkana, where he distributed the assorted foodstuffs and set a medical camp for the needy.
He has brought a lot of food. We have gotten a maize meal, vegetables, fruits, water. He brought bowsers full of water, rice, sugar, all different types of food. We want to also appreciate the quality of food because people who are hungry and weak are not able to chew hard food like maize. And so the maize meal that he has brought and other softer foods are going to be of help to these people.
Ningependa kutoa shukrani yangu kubwa zaidi pamoja na viongozi wengine wa Aloima na Turkana County na watu wa Aloima kwa jumla. Tunataka kutoa shukrani yetu kwa Sonko, Mike Sonko, Mbufi. Tunataka kumshukuru zaidi kwa sababu ya mazuri ambayo ametutendea.
Welcome to Heaven Trinity Motors, your premier destination for quality cars and exceptional service. At Heaven Trinity Motors, we bring you a heavenly experience in the world of vehicles. Discover a world of possibilities with our range of fresh import used cars. Each vehicle We offer competitive rates for your trade-ins and ensure a hassle-free process when you choose to sell with us. Explore convenient bank financing options tailored to suit your needs, making your dream car more accessible than ever. Call us today on +254 707 073 551. Heaven Trinity Motors. Your journey starts here.
Introducing Champion Security, where protection meets peace of mind. In an ever-changing world, security is paramount, and we're here to ensure your safety with unmatched expertise and cutting-edge technology. Whether it's securing your home, business, or event, our team of dedicated professionals is committed to deliver top-notch solutions tailored to your specific need. With 24/7 monitoring and rapid response capabilities, you can trust us to be vigilant guardians. Don't leave your security to chance. Choose Champion Security and take the first step towards a safer tomorrow. Contact us now to learn more about our comprehensive security service and join countless satisfied clients who have made the smart choice for their protection needs.
In an uncertain world, trust is everything. Introducing Tata Security Services Limited, your trusted partner in security solutions. At Tata Security Services Limited, we understand that security is not just about protection, it's about peace of mind. That's why we specialize in providing comprehensive security solutions for homes, residential areas, and malls. Our team of highly trained security guards equipped with state-of-the-art technology ensure round-the-clock surveillance and protection. From guard services to K9 units, from installing electrical fences to providing quick response in times of emergencies, we also offer bodyguards and event security. Tata Security Services Limited is your one-stop solution for all your security needs. With our commitment to excellence and swift action, you can rest assured that your safety is our top priority. Choose Tata Security Services Limited for security you can trust. We are located at Rimpa along Magadi Road, and you can contact us on 0202 595098. Tata Security Services Limited, protecting what matters the most.
CPF is a financial services company that offers a whole host of solutions to the Kenyan public and across the globe. We have been recognized both locally and internationally as a trusted brand, and the following are some of the reasons why you should be working with us. Currently, we provide fund administration services to the largest schemes in the country. One of them is Lab Trust, which is the oldest. Having been established in 1929, it currently has a fund value of over 30 billion Kenya shillings and membership of about 20,000 members. The County Pension Fund, which is also one of the largest in the county space, and the Public Service Superannuation Scheme. Overall, we have total assets under management of 100 billion. One of the biggest challenges in the social security sector has always been enabling people save towards their retirement. And one of the solutions that we have developed internally as CPF is called Rukisha. Rukisha is a concept that we developed primarily to address people in the informal sector, people with small businesses, people with big businesses as well. And the intention is to help them save towards their retirement. We have incorporated a concept called Save As You Spend into the platform, where for every transaction you make, you're able to save a percentage of it. And over time, you're able to see your retirement funds accrue. One of the other benefits of utilizing Rukisha is you also have access to other solutions within the CPF group of products, among them being investments through the CPF asset managers. You should be able to save towards a specific goal under the CPF asset managers. You should also have access to the CPF insurance products under the Laser Insurance Brokerage Services, as well as the real estate products within the Laser Property Management Services. For more information on Rukisha, visit www.rukisha.com. You can also access it through the shortcode *391#, or download it in the Google Play Store as a Rukisha app. Talk to us, reach out to us, and we shall help you achieve your retirement goals.
At CPF Financial Services, we've been able to package the solution for both for the individual, for the corporate, and also for groups. At the individual level, we've come up with products that are able to take care of the member both at before retirement and after retirement. For before retirement, we have training for the member to be able to prepare themselves to go out there and be able to save for themselves. Also at that particular level, they can be able to save individually on a continuous basis with as low as 50 shillings every day or 500 per month to be able to take care of themselves at the point of retirement. At corporate level, we have solutions where we carry out fund administration for corporates that have already existing schemes, or they can be able to join our umbrella DC schemes within this called Taifa. We also do gratuity administration to assist corporates be able to administer the gratuity plans for their different staff within the organization. We also have solutions for chamas where we can be able to open up opportunities for them to be able to save and invest as chamas, and also enjoy welfare solutions which are always covered under our trust fund called the Momba Trust Fund. As part of our solutions under the management and training arm, we also do management consulting. Under management consulting, we consult for you to do governance audits, we do strategy development, among other consulting services that you might request. We also do trainings. Under trainings, we have trainings that are bespoke to the organization, or they can already be able to come in at best prices to attend some of the trainings that have already been packaged by the CPF arm. For more information, visit our website on www.cpf.or.ke, or you can be able to access the information on the CPF app on the Play Store or the iOS Store.
Brayo bwana, asante kutupeleka holiday bwana. Lakini na swali, uliniambia tunasave na CPF. Kwani ukisave unapata pesa wapi?
Boni, unajua first una save, halafu una spend. Nilikuwa nishaweka kitu CPF kabla sherehe.
Oh, okay. Na kama sina kakitu this month nafanyaje?
Usistress. Ukiwa na CPF, unaweza convert Safaricom Bonga Points zinakuwa contribution yako kwa M-Pension. Na ni rahisi sana. Dial *289# au piga 0111 114 000 na CPF watakusort.
Hello, my name is Faith Wanjiru Kinyanjui. I'm a 4th year student Kenyatta University of
plant cell has a regular shape, while an animal cell has an irregular shape.
Perfect. So plant cells have regular shape, and animal cells have irregular shape. Like that. So we have talked about the shape. The shape is often regular. For animal cells, it is often irregular. Any other difference? Yes, Sarah? Great. So presence of chloroplasts in plant cells, absence of chloroplasts in animal cells. Yes, Bilha? Yes. So how you can trace it is animal cells only have a cell membrane, and for plant cells, they have a cell wall in addition to a cell membrane. Yes. Yes, Haron?
Plant cell have a tonoplast while the animal cell do not have a tonoplast.
All right. Clarify for us what a tonoplast is.
It is a membrane that's around vacuole.
Okay, so a tonoplast is basically the large central vacuole. Are we together? Yeah, so plant cells have a large central vacuole, and then animal cells, some have vacuoles, tiny vacuoles for excretion, but not the large central vacuole. Sawa sawa?
Yeah.
So that's good to note. So maybe I can mention others. Now plant cells store food in form of starch in starch grains. Plant cells store food in form of starch in starch grains. And then for animal cells, they store food as glycogen. Animal cells store food as glycogen in glycogen granules. in glycogen granules. So of course we have some similarities, like they both have a cell membrane that is used for selective access into the cell, okay? So, and they both have a cytoplasm, they both have a nucleus. So can we list the three main organelles that are absent in an animal cell but present in a plant cell? Three organelles absent in an animal cell, present in a plant cells. In plant cells. Quickly. Chloroplasts. Yes, Bramwell. Large central vacuole. You're not wrong. I just choose to use these words, okay? You're not wrong. Then number 3. Yes, Chebi. Cell wall. So majorly, those are the three main organelles absent in animal cells but present in plant cells. Now let's go to specialized cells. That is topic 2.0. Now initially I'd wanted to describe the cell to you. And then based on my description, you draw what you imagine that cell to look like. Okay? So I want you to close your workbook. Please stop peeping. Close your workbook and open your exercise book. And the first cell I will describe for you is the nerve cell. The first cell I'll describe for you is the nerve cell. Now I'm describing to you the nerve cell, and then I'll give you an opportunity to draw based on your imagination. All right, just a minute, let me open. Now, first of all, I want to say what specialized cells are. These are special cells that have developed certain characteristics in order to perform particular functions or specific functions. These are specialized cells that have developed certain characteristics in order to perform particular functions or specific functions. So in short, specialized cells were once just the normal cells. They have just undergone differentiation. So they have attained some features that are not common in other cells, making them specialized cells. Now I'm describing the nerve cell, so you need to pay attention. Then draw for me a nerve cell and exchange with your friend and get to see what your friend has come up with, okay? Now, a nerve cell is long, all right? It's extended. It has extensions and branches for easy communication with other nerve cells, muscles, and glands. It has cytoplasm. It has a cell body, and it is covered with a fatty sheath. The sheath is like, you know the way we cover cables with the insulating material? Something like that. So based on that description, so it's long, it has branches, it has a cell body, and remember, because it is a cell, it still has all the other parts of a cell. Still has cell membrane, still has cytoplasm, still has a nucleus. In a minute, come up with a nerve cell and exchange with your friend, and I'm interested in seeing what. Fifteen more seconds. Well, I'll let the nerve slide because some of you had seen, but still, don't overthink, just draw. It's elongated, remember? Can we teach ourselves to be drawing faster than we've been doing? Yes. Now, as soon as you're done, exchange with your friend. Let your friend criticize, compare with the diagram. No, don't compare first. Don't compare with the workbook first. Let's finish the descriptions. Okay. Still okay. Okay, has your friend seen your work? So at the end of all this, we are going to compare the actual appearance of the cell to what you drew. Then I'm going to see the reaction on your face. Stop opening the workbook. Close the workbook. Thank you. So have you shown your friend? All right. The next one is the ciliated epithelial cell. Ciliated epithelial cell. Now I'm describing the ciliated epithelial cell. Now, one of the functions of the ciliated epithelial cell cells rather, is to move mucus away from the lungs, because the mucus traps dust. Have you ever been to a very dusty place? How come the dust never got to your lungs really? Because you have a lining of mucus along your windpipe, the trachea. So the work of the ciliated epithelial cells is to waft, to sweep away the mucus upward so that it does not get to the lungs. And that is how you end up blowing your nose or removing kikohozi. What is kikohozi called? Sputum. Sputum. Okay? Yeah. So, now it has extensions of the cytoplasm at the surface of the cell. Has extensions of the cytoplasm at the surface of the cell, forming hair-like structures called cilia. Forming hair-like structures called cilia. And remember, this is an animal cell that has all the parts of an animal cell. Now, you don't draw one cilia, draw like 3 cilia next to each other, okay? Because they form a ciliated epithelial lining. Are we together? Yeah, so they can be 3, they can be 4, but for now, just draw 3. Just draw 3 and show us your ways. Show us your works, your drawings. Make sure every diagram you draw is a labeled diagram. Are you listening to the description? Okay. Well, some people appear to have already seen, but I'll still get them. Alvin, what are you doing? All right, we should be done with a labeled ciliated epithelial cell. Pass your book to the person behind you, and if there's no one behind you, pass it to the person in front of you. Yeah, I didn't say to the person on your side. In front of you or behind you. I'm afraid of looking at some of your diagrams because I may end up being traumatized. Please label your diagram. Mole. Okay, mole. Sawa. Hey! Let me see. What? I think the cameraman should just go around because... Open, I want to see. Wait. We have a long way to go. I am shocked. Why are you rubbing? Why are you rubbing? Just leave it there because you need to have something to compare with the actual. So, are you not able to draw the cell based on the description? Oh, interesting. Okay, let me go to the third one. Haron, I hope you're not looking at my book. The third one is the red blood, is the root hair cell. Root hair cell. Now, I want to describe the root hair cell. This is a plant cell, so expect it to have all the parts. Hey, why are you looking? Expect it to have all the parts of a plant cell. Are we together? Yeah. Now, a root hair cell is thin and elongated with no chloroplasts. A root hair cell is thin and elongated. Please, show me what you have. But I saw you looking at my notes. I saw you looking. Damaris, are we okay? So this is scientific imaginative drawing. Are we together? Yeah. When something is described to you, when you become a doctor and somebody comes and describes, are you able to say what that is from the description? It's a skill. Now finish drawing the root hair cell and label it, and then show us. Remember, it has no chloroplasts. Unless roots are green in color. Well, I can see that most of you have an idea. The one who doesn't have an idea, I highly suspect has never done. Oh, stop rubbing. Okay? Just draw what you imagine a root hair cell to be and label it. Even this should be labeled, this should be labeled. A diagram is not complete without labels, please. A diagram is not complete without labels. Architecture? Architect? Where? While you're trying. But being a plant cell, it should have a cell wall as well. Martin, please label that diagram. All right. Wait. This one I have to show people. This one I have to show people. Please give me permission. Why? Why? For root hair cell. Please. Allow us to have 1 minute of fun. Okay? See, we are a family of this class. Leo ni wewe, kesho ni mwingine. Sawa? Just give me permission. Not all of them? Now, who should I not show? Huh? So I show the ones? I only show these ones. The ones who are seated there, we don't show them. But you know, by the way, thinking about it really, probably this is what I described. Sindio? By the way, he has made effort. If I show you for somebody who is seated over here, without mentioning names, it is worse. Sorry. Okay. Now the next specialized cell we are looking at is sperm cell. Draw it. That one I won't even describe. Yeah, these things you know. Sperm cell. Maston, you know how it looks like. Yeah. Anyway, for purposes of describing, okay, a sperm cell has a head and a tail. The head contains the nucleus, and the tip of the head has an acrosome that contains digestive enzymes that helps the sperm penetrate an egg. So along the tail we have a midpiece which has mitochondria, packed with mitochondria, to release an energy needed to swim and fertilize the egg. I think that is more than enough description. But you know, it's very interesting. Some are drawing the sperm as if it is standing, like the head and then the tail. The head like this and then the tail going down. Now remember, there is a mid piece along the tail. There is a mid piece that has mitochondria, numerous mitochondria. Alvin, you seem stressed. Are you okay? Sharpener. We have sharpeners. There's a carton that has sharpeners here. Sharpeners. Thank you. I am going round now. Please make sure you label. Damaris, traumatize me all you want. Enoch, welcome back. Are you really sharing these diagrams? By the way, the whole of this book is yours. Stop saving the book, okay?
Yes.
Okay, let's continue. Please show your friend, we are not using the workbook. Show your friend your diagram of a sperm cell, and then we can proceed. Let your friend criticize you as you also criticize them. Okay, we have 2 more left, just 2 more. No, 3 more. We have 3 more. We have 3 more left. At least I can see we have done 7 hours. Wow. Okay, the next one is the red blood cell. Now, it is a biconcave disc-shaped cell that has no nucleus. Draw that. Biconcave nucleus, sorry, I repeat, biconcave disc-shaped cell that has no nucleus. So I understand there is a group that is supposed to go for a health break. Do you already know your groups? Like if I say group 1, you can tell it's you? Yes. Okay. So it's group 4? Group 2. Okay. So group 2, once you have drawn the red blood cell, please go for your health break. Draw a red blood cell, give your friend to criticize. And then we move to the next one. The next one is a xylem. Okay. Xylem cell. The next one is a xylem cell. And I'm going to describe it briefly. Are we drawing? Now the xylem cell, its work is to carry water and minerals up the plant. Are we together? So it is a tube, a continuous column, okay? It has thickened wall. And the tube is formed as a result of many xylem cells interconnecting, forming a continuous hollow tube. Now, draw that. That should take you 10 seconds. You can't believe I'm asking you to draw that, Evans. It has no top and bottom walls. So it's a continuous hollow tube with thickened walls. A continuous hollow tube with thickened walls. And then the last cell that I'm going to describe so that we can now get to see our imagination versus the real thing is the egg cell, also known as the ovum. It is a large cell that contains a lot of cytoplasm with a nucleus that has the female haploid cell. With a nucleus that have female haploid genetic material. So based on that description, please draw an egg cell. So I believe as I was writing the description, you are also writing the work of the cell. So can we draw the egg cell in 10 seconds? Let's draw the egg cell in 10 seconds. 7, 6, 5, 4, 3, 2, 1. Label it. Bilha, draw the egg cell, please. Kindly. Nikuseme ama ninyamaze? Now, his egg cell has a cell wall. Think about that. I hope you are given rubbers. Rubbers, sharpeners. Sharpeners, we just bought a few. You don't need your own personal one. They should just be on the benches when someone needs to rub or sharpen. Now, please open your workbook and compare what you are drawing to what is there. Just go diagram by diagram. And now you can see how your descriptive imagination is. Damaris is not there. Yeah, so you don't have to correct because the workbook is yours, okay? Yeah, you don't have to correct. All you need to note is the function of each and every specialized cell, all right? So I think we are done with that. And the last thing that we are going to do is cell structure and organization, which is 2.1. Now, we said that the cell is the basic unit of life. Now, at what point, or rather through which steps, do we move from basic unit to a real organism now, a complete organism? Who can tell us? Tell us how we move from a cell to an organism. What do you think happens and what steps are taken? What organization takes place? Now, we have different types of cells. We have different types of cells, and we have listed them there, we have drawn them, we have described them, all right? Now, when cells that perform the same activity are found together, they form a group of cells called a tissue, okay? Now, give me examples of cells in your blood. Yes, Enoch? White blood cells. Other types of cells? Yes? Red blood cells. And then? Yeah. Platelets are not really cells, okay? Yeah. So when these cells are together, they give us a tissue. You had a question? No, plasma is not a type of a cell, okay? It's the fluid in which the cells are found, okay? The fluid part of, the liquid part of blood, but it's not necessarily cells, okay? Now, so these cells, are performing the same activity. They give the general role, the role of the blood. So that means that the blood now, in this case, is the tissue. All right? So this tissue now has different cells performing functions that have a common aim. All right? Now, when tissues work together, they form what? An organ. So we are still organizing. So organs. Now, in this case, we have several tissues. We have blood, we have muscle tissue. Okay, give me other types of tissue. We have epithelial tissue, which forms the linings, etc. So when all these tissues are working together, okay, to perform one function, for example, the function of circulation of blood, for example, we may now have them forming organs, for example, the heart. I'm trying to give you something that is related to the cells that we chose, all right? So here we have the heart, okay? And different organs can work together with the heart, all right? For example, the lungs also, they play a major role in transporting humans, all right? Now we have blood vessels, vena cava, pulmonary vein, pulmonary artery, aorta, okay? So they all work together to give us an organ system. And then now, in this case, what will be the organ system? The organ system will be the circulatory system for this. Circulatory system. Then all these systems working together. Now you derive the systems from the characteristics of living things. For example, respiration is a characteristic. The systems that are performing that function are the respiratory system, the breathing system, the gas exchange system, okay? Then we have nutrition, for example. So what's the organ system related to nutrition? Digestive system, okay? So you can derive all the systems from the characteristics of living things. Then now, many organ systems now give us what? An organism. And that's when we can clearly say that this organism has these 7 characteristics of living things. So that is cell structure and organization. So an organ system has different organs, but they all have related functions. Now, sometimes I think you should be writing as I explain, so that so we can bid biology bye-bye for some time, okay? Can we do some chemistry? Yes. Nice. Is it Wednesday yet? Oh, wow. Good morning. Good morning. Ah, nice. Oh yeah, today is Valentine's. Please wish your friend happy Valentine's. You can officially wear your red t-shirt. Okay? Yeah, so let's go to states of matter. Let's go to states of matter. Okay, states of matter. Now, we have 3 states of matter, and they are solids. Wonderful. You open the chemistry. Right. So we have 3 states of matter, liquids, gases, and solids. Now, in states of matter, we have the particle theory of matter. Now, what is a theory? What is a theory? Is an explanation for something, okay? So through the particle theory, we are able to explain the behavior of liquids. We are also able to explain the behavior of solids, and we are able to explain the behavior of gases. Now we have five pointers, or rather 5 explanations within the particle theory, all right? Now the first one is that all matter is made of particles. All matter is made of particles. Now the second one is that these particles are held together by attractive forces. That's the second one. These particles are held together by attractive forces. The third one, particles that make up matter are always in motion. If I'm fast, you say you're fast, kindly pardon. That the particles that make up matter are always in motion. Now the movement of particles, number 4, the movement of particles is increased by an increase of temperature, and the opposite is true. Movement of particles is increased by an increase in temperatures, and then the opposite is true. Then lastly, each matter is made up of its own type of particle. For example, water is made of water particles. Carbon dioxide is made of carbon dioxide particles. So each matter is made up of its own particles. Now, we have a table to fill there where we are expected to distinguish properties of solids, liquids, and gases, and we are considering 3 factors. We are considering 3 factors. So I want the 3 forms of water. I want us to be able to display the 3 forms of water. I want us to be able to display steam. I want us to be able to display solid water and liquid water. So as they plan for that, we are going to start with the first one, which is arrangement of particles. Arrangement of particles. So on the board, I'm going to draw the particle theory for the 3. and then we discuss the arrangement. So I'll start with solids. Now, solids okay, so this is a block of ice. Are we together? Before it is brought to us physically. Now, you will find the water particles arranged in this manner. Well, I've tried to draw a 3D representation. So the same on this side and on this side. We said we are not in an art class. Sindio? Yes. Haya, tuendelee basi. So there is no one judging us. Okay, I know you'll draw us. That is why I'm peaceful. So basically, that's like just a 3D representation of particles within a solid, and then a liquid, I assume most likely is within a vessel, okay, like a jug or a cup, and the particles are within something like that. All right? And then for a gas, I assume the gas is free. Are we together? So the gas particles can be anywhere, including there. Anywhere. Even where you are. Yes, 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 yes. So we are placing them on a tile? We are hitting them. Okay. All right. So we are still organizing how you're going to see the 3 states of matter. Chebi, were we drawing this in the table? Did I give that instruction? We are still under particle theory. Yes. So we are still under particle theory of matter. Now, please draw what I have drawn. Especially for the solid. So if I disagree with your diagram, you will just repeat. Let's draw with a pencil, okay? Excuse me. Did you notice how I was drawing? Draw that way. It's important for us to draw that first before we fill the table. There's a reason why. I am seeing that most people did not look as I was drawing. Analytical chemistry students, muko mbele. Naogopa. Let's be faster, please. Let's be faster. Now, as soon as you finish drawing that, now we can move to the table. We can move to the table comfortably. And I want us to talk about arrangement of particles. And since I feel like some of you did not draw the right thing as you should have, I'd like you to look at the board. I'd like you to look at the board and comment on arrangement of particles of a solid. Comment on arrangement of particles of a solid. Where else? Can I hear your input? Yes, Chebi? That falls under separation of particles. We are talking about arrangement. We are talking about arrangement of particles. Yes, yes, Imelda? So packing in a row, not row, in a row means that is regular arrangement. So that is the comment you put under solids for arrangement of particles. Regular arrangement of particles. For liquids, irregular arrangement. And then for gases, it's random. Random scattering of the particles. So you're being provided with some apparatus for use. It is at this point that I request we wear our lab coats, those who have not worn. Where is my hoodie? Ulipewa hoodie yangu? Hoodie yangu iko wapi? Okay. reagents. Are we together? Yeah, we are dealing with water, okay? Water is harmless, so it's important for me to let you know that. Are we okay? All right, so now let's go to the second part of, of the table, where we are talking about separation of particles. Now look at the particles I have drawn and tell me, comment about the separation of those particles. How far apart are they? Are they touching each other? Yes, Jelimo?
In solids, they are closely packed.
Mm-hmm.
In liquids, they have a bit of spaces. Then in gases, they are widely spaced.
Okay. Yeah, so in terms of separation, she's very right. For solids, they are closely packed together. So comment about that. For solids, they are tightly packed together because of the strong forces that hold the particles together. Now for liquids, they touch each other, okay? They touch each other, but have minimal spaces between them. For solids, there are no spaces in between the particles because of the strong forces holding them together. So those are the words you use to describe the separation of particles in the three states. Now we move on to the third one is the movement of particles. From the diagram, you may not be able to tell the movement of particles, but for solids, the particles only vibrate on the spot. The particles only vibrate on the spot because remember, as we have said before, there are strong forces holding them together. So they only vibrate on the spot. So any solid you see, the particles are vibrating on the spot without leaving their position. Then when we go to the liquid, the particles are able to slide over and under each other. And that is what gives liquids the ability to flow. When you pour water and it flows, is because the particles are moving over and under each other. Now we have not commented about the separation of particles in gases. Now particles in gases are far apart and can move as far as the space has been provided, okay? So when you spray something gaseous, those gas particles are free to move as far away from each other as possible. That's the nature of gases. And that is because there are no forces holding the particles together. So they move, they bounce on each other and keep moving randomly. Then the movement of particles for gases is random. Random movement, random and free movement for gas particles. So Now we can go to the investigation of changes of state, and then we'll describe them. So what's happening? From the lab technicians. Sorry? Okay. All right. So we can be describing the changes of states before. All right? I'll use two diagrams to describe this. The first one is the triangular one. Whereby we have the solid at the top, we have the liquid on one side, and we have the gas on this other side. So the change of state depends on where the arrow is pointing. Okay? Guys, are we together? Now, if the change of state, if the arrow is pointing this side, liquid to solid, what change of state is that? Liquid to solid. The arrow is pointing from liquid to solid. Freezing. Just think about water. Liquid to solid. That is freezing. Now, when the arrow points to the opposite direction, we have melting. Right? And we can move to this other side. But before we go here, let's go here. Now, from liquid to gas, we have evaporation. And what is the opposite of evaporation? Condensation. Now we have unique changes of state whereby a solid moves straight from being solid to being a gas. That is sublimation, so the arrow points this way. Sublimation. And what is the opposite of sublimation? The opposite of sublimation is deposition or desublimation. Okay? So that's one way that you can use to describe the changes of state. The other one is just writing them horizontally, starting with solid, liquid, gas. So, and then you have one crossing from solid to gas and vice versa. Then the arrows so you can give them letters A, B, C, D, E, F. So do this one and then do this one and write the changes of state for each letter. Are we done? Now we are going to provide for you ice cubes in beakers. Hope our ice cubes have not started melting. Some have. So how many groups do we have? 6 groups. Now using the thermometer you have, get the volume, not the volume, sorry, get the temperature of the ice cubes provided. Please get the measurement of the temperature before they melt. They fully melt. Is there any group without ice cubes? You must make sure that the thermometer is in between the ice cubes, please. I'm interested in hearing your findings. Okay, imetosha. Imetosha. Now please make sure you record your findings. All right? We are still under changes of states. We are still under changes of states. Nini? Tuna combustion tube.
You need to be visible kwa camera. You need to be visible kwa camera. We don't have nose masks. We don't have nose masks.
Can each group representative give me the temperature? I put it in this. All right. Yes? 6 degrees. Interesting. So that shows it's already started melting, eh? Okay. Yours is 3 point? You're scientists. You're saying points. Mm-hmm. 2.0. So there must be room for error. Because you can all see how we are measuring, isn't it? Yeah, so some investigations definitely have some error in them, and it is up to us as scientists to find ways of improving our methods of data collection. What is your volume? What is your temperature? 5 degrees, you're sure? Okay. Mm-hmm. 4 degrees. It's still going down. Mm-hmm.
1.0.
1.0. I think these guys have been able to measure the temperature the best way. Their error is minimal compared to the rest of you. You see how they have inserted the thermometer right in between the ice cubes. So every time you're doing an investigation, you make sure you reduce on the probability of error. All right, so we are going to heat that water and check at which temperature it starts boiling. Now, you have to be very keen so that you don't allow it to boil for a long time before you take the temperature, okay? I want that point, the boiling point of your water. So you'll get a Bunsen burner, a tripod stand, and a wire gauze. So you will put your reagent on top of the wire gauze and heat as you observe the temperature changes. Is everything okay? Can we try another one that is working? Okay, please return the pipe. Now keep checking for any variations of temperature. Keep checking for any variations of temperature. We have not tested this. Is the main gas tap on? Okay. Please don't burn yourself. Okay. So this group you can measure before. All right. Heat your amount and tell me at what point it boils. Please don't switch on the gas taps without an authorized person assisting. What is your volume? What is your temperature? Now, I don't know why I'm not seeing thermometers inside the beakers, kindly. We are observing the behavior of the matter as temperature rises. The point at which it starts boiling, remove the thermometer and give us the temperature. Careful, don't get so close to the Bunsen burner, please. Anyone having a problem with their investigation? Why is it that water is taking long to boil today? And the way at home, you guys are almost there. At what temperature is that?
Temperature 4 now.
So initially it was 80, no?
84 now.
How can you reduce?
It's because you're moving the thermometer from a part of, you know, this heat is not evenly distributed, so that is a source of error.
Sorry, I started.
Yeah, you can stir. If you want even distribution of the heat, you stir. If you want even distribution of the heat, you can stir. Please don't touch the beaker with your bare hands, kindly. For even distribution, try and stir a bit, okay? For even distribution of heat. I need now the final temperatures. The initial temperatures versus the final. I think you can give me the final, Clarice, and your team, because it's boiling. 84 degrees. It's rising because you're still heating. At what point did it boil? 84 degrees. Any other group? So you can stop heating. You can stop heating. Once you get the temperature at which it is boiling, you stop heating.
82.1.
Now, what do you think is the source of error? Considering theoretically we know that water boils at 100 degrees. Yes, Jessica? Impurities, I disagree because impurities raise the boiling point and lower the melting point. Yeah. But you have thought about it scientifically only that it's the opposite of. Now, was the temperature of the water evenly distributed? That could be a source of error. Then secondly, was the whole part that should measure the temperature inside the water, or some of it was outside? So you find part of the thermometer was taking the room temperature, part of it was taking the water. Okay? Yeah. The surroundings, yes. Yeah, the surroundings. So anytime you get unexpected results, look for the source of error and redo the experiment to get accurate and reliable data. All right? Can we proceed to something else? Thank you. The lab techs, please switch off the Bunsen burners for us so that we move on to the next thing. Thank you very much. It was a simple activity but enlightening, isn't it? Yes. And we have done 8 hours. Yeah. So imagine we have just 50-something hours to go. You look scared. All right, so let's move to the next thing. And what I want to discuss next are the heating and cooling curves. Heating and cooling curves. For diffusion. Yeah, we will. Oh, great. We'll do it.
Do they have even one for demonstration? Not even one. The normal ones for COVID?
I don't. Heating and cooling curves. So we can start with the heating curve. Okay? And what we are considering here is heating ice. Now, heating and cooling curves are graphs that help us to describe the changes of state. Heating and cooling curves are graphs that help us describe the changes of state. So you see what we were drawing before using the arrows and all that? That can be described using heating and cooling curves. And we'll start with the heating curve for water. Now, we need the graph papers so that we can draw accurately a heating curve that took around 7.5 minutes, okay? 7.5 minutes to heat ice and move it from solid all the way to gas. So that means that we are heating from negative something temperature all the way to 100 degrees, because that is the range in which we move from ice to gas. Are we together? Yeah, so the y-axis in this case, so you'll be provided with a graph paper. So the title for the graph is Heating Curve for Water. And the y-axis, we have temperature. And which units do we use to measure temperature in this case? Degrees Celsius. Good. So for the temperature, we'll start at -25 and go all the way to 150. All right? So that means that you need to choose an appropriate scale that will help you draw the heating curve. Remember, we are starting at -25 all the way to 150. Now, the graph paper you've been given, we are not folding it, Alvin. We are supposed at least to occupy half the graph paper to a maximum of 3/4 the graph paper. Half the graph paper to a maximum of 3/4. So, so I need you to choose a scale for the y-axis. I also need you to choose a scale for time. In this case, we are measuring time in minutes from 0 to 10 minutes, but we got to the final change of state at 7.5 minutes. So at 7.5 minutes is when we see the final change. So I'm not asking you to draw the graph yet. I'm asking you to label, to give the graph a title, choose a suitable scale, and now fill the scale. Once we are done with that, we'll now draw the heating curve. You choose an appropriate scale to occupy between half the graph paper to a maximum of 3/4 the graph paper. Okay, I think that's enough time. So please follow the guidelines I'll give you to be able to draw a good heating curve that will indicate the 3 changes of state. Now at -25 all the way to 0, remember we are still at solid. Are we together? So we are heating, because it's a heating curve, we are still at solid. And at 1 minute, so we are plotting at 1 minute versus 0 degrees Celsius, melting takes place, so the curve goes flat. Please follow instructions so that you don't draw something different. So at 1 minute is when melting happens. So as long as the graph is diagonal, it means we are heating. So between point A and B, that is melting. So probably we take 2 minutes for the full melting to take place. So at 3 minutes, we are now fully liquid, okay? And heating continues. And at maybe 7.5 minutes, boiling happens and evaporation starts to happen. So all this is versus 100 degrees Celsius. All right? And when now it boils and keeps on boiling, now it becomes steam beyond that point. So point C and D, that is boiling, and also evaporation is taking place. Evaporation is also taking place. And that is the heating curve for water that took 7.5 minutes to move from solid to gas. Anyone with a question? Anyone who needs clarification? Now, as soon as you're done with this, you will be given a second graph paper. As soon as you're done with this, you'll be given a second graph paper in which we will draw the cooling curve for water. We have done heating curve, now we go to cooling curve for water. Now, I'll give you the guidelines for the cooling curve. I will not draw it on the board, but I'll give you the guidelines for the cooling curve and see if you're able to come up with the cooling curve for water based on the heating curve and the guidelines I will give you for the cooling curve. Okay, please provide us with a second. Okay, I think, can we use the back side of that? Is it still in order? Who is unable to use the back side of their graph paper? If you're unable to use the back side of your graph paper, raise your hand. We'll supply you with another graph paper. Anyone? Now, the cooling curve is the opposite of the heating curve. The cooling curve is the opposite of the heating curve. So that means if the heating curve is starting here, where is the cooling curve starting? Up here, all right? All right? Okay, I am tempted to guide you. I need a red pen. Red whiteboard marker. Red whiteboard marker. Red, here. No, that's permanent. So same concept, same substance. Cooling curve. We are starting from 150, okay? And coming down. What is happening at 100? What's happening at 100? At point E to point F. Condensation. Excuse me, pay attention. What's happening at E to F? Condensation, because we are moving from gas to liquid. All right? So condensation. All right? Then we continue cooling, okay, up to around maybe 6 minutes. And then we have point EF, G to H. What's happening at G to H? At 0 degrees? Freezing, good. It's just the opposite of this, yeah? Freezing. And then it can go down to lower temperatures. Thank you. So please draw an independent, a separate cooling curve. If you are going for your health break, please do so and then come back as soon as possible. Okay. Okay, gloves. Gloves. 2 of them. Okay. Yes. Yes. I didn't give notes on diffusion. Sija capture diffusion number. Still. So are we done with the heating and cooling curves? Right. Now we switch to our, or rather let's finish on effects of temperature and pressure on volume of gas. Effects of temperature and pressure on volume of gas. Now, what is gas pressure? And I need to hear your views. What is gas pressure? Now, gas pressure, anyone with an idea? Hey guys, can we stand? Can we stand? Let's stand. Stand, stand, stand. How are you feeling? Huh? You're feeling fantastic. I'm giving you around 30 seconds to stretch. It is healthy to stretch for circulation of blood, even circulation of blood. All right? Once you feel satisfied with the stretching, you can sit. Yes, Maston, powerful. Yeah, so what is gas pressure? Can we write this down? Yes, yes, Clarice. Now, you can't use pressure to describe pressure. We cannot use pressure to describe pressure. You can't use a word to describe the same word. Yes, Bramwell.
Gas pressure is the force
confined by a gas in a certain environment.
Please repeat your statement.
Gas pressure is the force that is confined by a gas in a...
Is the force confined by a gas?
Say in a container.
In a container. Yeah, his answer makes a lot of scientific sense, okay? Because pressure is a force. Are we together? Yeah. Pressure is a force, but this force comes about as a result of the gas particles knocking on the walls of the container that they are in. All right? So if I have a balloon, I wish I had one, as I blow the air into the balloon, the pressure increases because there are more gas particles hitting on the walls of the container that is holding them, okay? So there is a maximum number of particles that each container can hold. Like a car tire, there is a maximum number of gas particles that a car tire can hold. And when that, when we try to pump excess air, what happens? It bursts, and even balloons burst, okay? So you have exerted so much force and forced so many particles to fit into that space that they are hitting on the sides of the particles so much, and they end up tearing the container, and that is what we call bursting. Are we together? Now, temperature increases the movement of particles. It increases how vigorously they move and how faster they move, okay? And that's why we say that increase in temperature causes expansion, because it makes particles move faster because they have gained kinetic energy. And this explanation is called kinetic theory. Ever heard of kinetic theory? Now, I hope everyone has drawn the heating and cooling curves. Is there anyone who still has an issue with heating and cooling curves? All right. So we are at kinetic theory now, explaining the effects of temperature and pressure on the volume of gas. So first of all, we have said that temperature increases the kinetic movement of particles, okay, making them to move faster and more vigorously. Maitha, you're still drawing heating and cooling curves. We give you a minute to finish. Okay. Finish. Finish and catch up with us. So would I be right to say that as you increase temperature, you increase pressure and you increase volume? So as you increase temperature, you increase volume. And since you are not changing the vessel, yes, as you increase temperature, you increase volume because the particles move more vigorously and farther from each other. But again, remember, they are confined within a certain space. So that is what leads to increase in pressure. Pressure, because you're forcing a bigger volume to fit within the same space that it was in before. Make sense? Yes. So you can conclude the effect of temperature on the volume first is that it leads to an increase in volume due to increase in kinetic energy. So if these particles are moving more because they have gained energy, it means they hit on the wall of the container more vigorously and more often. Now, vigorously and often refer to two different things. Okay? Vigorously means how hard they are hitting on the walls of the container. Oftenly means how many times are these particles now hitting the wall of the container. So there are two parameters that are increased here as you increase the temperature. I've used a lot of energy to explain that one. That one I'm sure you have understood. Please write it down in your own words. Assume that question was 3 marks. What would you have written to get 3 marks? Now you have noticed so far that when you're answering science questions, the choice of words is very important. There are key words that we look for. Anytime you're talking about temperature and particles, you must mention kinetic energy, the energy for movement. Increasing the temperature causes particles to gain energy, move faster and more vigorously. $60 seconds for that. Now, there was nothing to write in interpreting heating and cooling curves. Maybe just an explanation, because we have drawn them in the graph papers. A graph is incomplete without a title. I'm still seeing graphs without titles. A graph is incomplete without a title. A graph is incomplete without the y-axis and the x-axis clearly labeled with units indicated. Okay, there's a subtopic that is not in the workbook, and that is diffusion of gases. So we'll go back to our exercise books. And the case study in this case is ammonia gas and hydrogen chloride gas to give us ammonium chloride. Now, in chemistry, what is diffusion? Why am I insisting in chemistry? Because there is a different definition of diffusion in biology. Are we together? So for this particular time, I want the definition in chemistry. Yes, Jelimo. Uh-huh.
Movement of particles from a region of high concentration to a region of low concentration.
Mm-hmm. Mm-hmm. No, say it. No. No, you have spoiled it.
From a region of high concentration to a region of low concentration.
Mm-hmm.
This something else.
You're done?
Yeah.
Okay, say it again now. Is a movement of... Say it again now for them to hear.
Is it molecules and
Particles. Particles.
Okay, diffusion is the movement of particles from a region of high concentration to a region of low concentration.
Good. Movement of particles. Now, for chemistry purposes, add random movement because there is no order in which the particles move down a concentration gradient. There is no order. So diffusion is the random movement of particles from their region of high concentration to their region of low concentration. Now, there are several factors that affect diffusion, but before I go to the factors, we want to do a demonstration here using ammonia gas and hydrogen chloride gas, okay? So as I am describing the investigation, I'll need you to write down that description for the investigation because it's not in your workbook. So you're basically writing this experiment down, the demonstration. Then I'm going to demonstrate it. You'll come and view and note down your observations. All right? Right. So who is helping me in that? So I think we'll do it from here. So the reagents we are using in this case are fumes of ammonia gas. And then we are also using fumes of hydrogen chloride gas. Are we together so far? Yes, so we are going to dip cotton wool in each of these liquids and then place them on different ends of a combustion tube. Let me show you a combustion tube here. We would have wanted everyone to attempt this, but where our fume chambers are, we may not be able to use the fume chambers, considering we are recording this lesson, okay? Yeah, so I'm just going to do a demonstration. You will come and view. Are we together? So this is a combustion tube. It's open end to end. So we will put cotton wool that is soaked in ammonia. And then we will also put cotton wool that is soaked in hydrogen chloride and give them time and see what happens, all right? Yes. Then eventually now we are going to write our observation and write a word equation for that reaction. So, Mark, you're the one helping me. What are we using to close this end and this other end? Okay. Now, why do you think I'm wearing 2 pairs of gloves per hand? Per hand. Is it 2 pairs? A pair per hand. Why? Are you seeing what we are talking about here? Thank you. I care for my hands. And we know that hydrogen chloride is an acid that is corrosive. Where is the mask? I hope it's a mask that no one has used. Okay. Okay. So we can demonstrate from here. So we'll need the 2 liquids, and then we'll need something to block end to end after we insert forceps for both. All right. Feels like I'm about to perform a surgery. So this is hydrochloric acid. Once we dip the cotton wool in it, all right, as it starts diffusing, as it starts diffusing, it will now give us the hydrogen chloride gas, okay? And this is ammonia solution. Same concept. Once we dip and evaporation starts happening and diffusion starts happening, it will give us ammonia gas. So, tutafunika aje hapa na hapa. Okay. So I think you can come closer, but not so close for safety purposes. Kwani hii imefungwa aje? Okay. You dip. You dip. You dip. Okay. It's concentrated. Excuse me, sir. The fumes are too many for hydrochloric acid. The fumes are just coming off a lot. Please, if you feel some irritation, you can step aside. Okay, we are done with hydrochloric acid. We are done with hydrochloric acid. We can have so I want you to be very keen when observing, okay? I think we can open this window. Okay. That's ammonia. We need to be faster for security purposes. Now please make the observation quickly so that we finish. Where is the cloud? Is it towards the ammonia side or the hydrogen chloride side? Has everyone seen?
Yes.
Has everyone seen? Is it clear enough?
Yes.
It is closer to the ammonia side than the? Thank you. Are we okay? Science students, are we okay? Yes. Thank you. So can we write down the observation? I think this can be taken away. Yeah. Please write the observation. Okay. Now, it's just that we were doing that under pressure to finish. Are we together? Yeah, if we were to do it in a fume cupboard, which is the ideal situation, we would have observed a ring of white smoke. Are we together? Now, so I'm going to write the word equation for that reaction. And then, when we get to writing symbol equations, please remind me, we write a symbol equation for that one. Okay? All right. Okay. So word equation. Are you okay? Okay. So we have ammonia plus hydrogen chloride gas react to make ammonium chloride. Now this ammonium chloride is what forms the fumes, the white fumes that you saw in the combustion tube, all right? Now, another thing I want to talk about is why did the white fumes form closer to the ammonium or closer to the ammonia? Closer to the hydrogen chloride, all right, and further from the ammonia. So this is where we look at factors that affect the rate of diffusion. Rate basically means the speed of particles diffusing, all right? Yeah, so the reason is because in terms of mass, hydrogen chloride is heavier than ammonia gas. Are we together? Now, we may not calculate the mass now because it's ahead, all right? But when we get to the point of calculating the mass, you'll see that hydrogen chloride is indeed a heavier gas than ammonia. And as a result, those particles All right, I think now we can go back to the workbook. We can go back to the workbook and go to subtopic 2.3. Go to subtopic 2.3. Elements, compounds, and mixtures. So the first part basically is just for defining, the four aspects that have been mentioned there. But as time moves on, we are going now to interact with, okay, we may not interact with atoms, okay, but we will make models of atoms, all right? Yeah, we are going to use material that is readily available in our environment to make atoms, elements, compounds, and mixtures. Now, we start with atoms. We are defining. Atoms are the smallest substances, atoms are the smallest particles that make up a substance, any substance. Remember, in the particle theory, we said that all matter is made of particles. So these particles are actually atoms. So atoms are the smallest particles of any substance. Atoms are the smallest particles that make up a substance. Good. Now I'll go to elements. And I'd like to hear what idea you have of elements. Sarah, any idea of elements? No. Allow me to disagree, Imelda. Substances that can take part in a chemical reaction. Hey. But don't you think compounds can also take part in a chemical reaction? Even mixtures can take part in a chemical reaction. So we may not use that to describe what an element is. Anyone else with an idea? Yes, sir. You are Maitha, right? Uh-huh. Hey, you had read in advance. Please repeat again. Mm-hmm. Good. So stop there, into anything simpler, okay? Yeah, so an element, there are four things that you can mention about elements. And the first one, as he has said, is that elements are pure substances. That's the first thing you mention. Now, the second thing you mention is that elements are naturally occurring substances. Elements are naturally occurring substances. Number 3 about elements is that they are made of only one type of atom. They are made up of only one type of atom. For example, if nitrogen is an element, then it is made up of only nitrogen atoms. Okay? And then elements cannot be broken down into anything simpler. Elements cannot be broken down into anything simpler. So have we mentioned 4 aspects about elements? Now, the next thing that we are going to look at still under 2.3 is compounds. Compounds. Now, compounds are new substances. Compounds are new substances that are formed chemically when 2 or more different elements combine or react. That are formed chemically when 2 or more different elements combine or react. And there are very common compounds that we know, like water. How do we write water chemically? H2O. So that means water has what and what? Hydrogen. So it has 2 atoms of hydrogen and 1 atom of oxygen chemically combined to form a new substance. All right? Now, note this, that compounds do not look anything like the constituent elements. Compounds do not look anything like the constituent elements. They are totally different. For example, water. Water exists at room temperature, it exists in liquid form, yet it is formed from an explosive gas, hydrogen, and a gas that supports that explosion, isn't it? Oxygen, yeah? Oxygen supports combustion. But when the 2 chemically combine, we get water. So that's why I was saying that the compounds do not look anything like the constituent elements. Are we together? Lastly, now, you cannot also tell which elements make a certain compound by looking at the compound. When you look at water, can you tell that water is made of hydrogen and oxygen? You can't tell. What about when you look at salad? Fruit salad, for example. Can you tell what it is made of? Yes. You can tell it's made of mango, orange, banana, watermelon. You can actually see the components of that substance. Are we together? So that is what makes compounds and mixtures different. Now, as much as compounds are made from 2 or more you know, I thought a student has fainted. Are we okay?
Yes.
What happened? You're even demonstrating. Yeah. Please push the stool forward a bit. Where? Anyway. What was I saying? Yeah. I was saying that as much as compounds are made of different types of elements, compounds are considered as pure substances. Compounds are considered as pure substances, and because they are pure, they have precise melting and boiling points. Measure of purity and impurity is boiling point and melting point. So you can't say that water is impure because it is made of hydrogen and oxygen. Yes, it's made of hydrogen and oxygen, but have we formed a new substance? Yes or no? Yes, so that new substance is a pure substance. All right? All right. Diana, are we together? Do you need water? All right. So we are done with that. Let's go to mixtures now. Mixtures. Mixtures. Define a mixture. Yes, Chebi. It is the composition of more than one compound. It is true, it is a composition. You know, I want to support your answer as much as possible. Of more than one, then when you said compound, you spoiled it. Okay? Now, a mixture is an impure substance. We start there. Like, for example, in this lab, we have mixtures. We have mixtures of students. So a mixture is an impure substance made up of two or more substances. Well, they don't have to be elements, they don't have to be compounds, just two or more substances, okay, that are physically combined and can be physically separated. That are physically combined and can be physically separated. Now, quickly in pairs, just talk to the person opposite you, okay? At least everyone should have a partner. You can discuss the three of you, right? Now, in your exercise book, I want you to come up with 5 examples of elements that you know, without referring anywhere, please. 5 elements that you know, 5 compounds that you know, and 5 mixtures that you know. Now, don't tell me about compounds that you don't know what constitutes them. Are we together? Yeah. Don't tell me adenosine triphosphate. Then when I ask you what makes adenosine triphosphate, you can't say. All right? So that should take 3 minutes. And then I'll give a few groups an opportunity to say what they came up with. Remember, we are not referring to anything. You're just giving examples, please. Just examples. Okay, thank you. Are we ready? Are we set? No. 9 hours gone? I'm looking forward to seeing you tomorrow at a time like this. We'll still be here. And even the other night at a time like this, we'll still be here. We are strong. Okay, let me select randomly. Maitha and your partner, please give us the 5 elements you came up with. Let me bring the microphone. One, two. Give us the elements you came up with.
Sodium.
Listen, please listen. Excuse me. Yes?
Sodium, lithium, potassium, zinc, and magnesium.
Interesting set of elements. And what compounds did you come up with? Speak up.
Ammonia compound.
Uh-huh. You didn't discuss. Why are you thinking? Sorry?
Ammonia,
Uh-huh.
water,
Uh.
benzene.
Sorry?
Benzene.
Benzene.
Yeah.
Uh-huh.
Like sulfate.
Sulfate. Is sulfate an ion or a compound? Okay, appreciate them. They have tried. Clarice and your team, give us your findings. Speak, take the microphone and speak. Please pay attention. Martin?
Elements.
Give us elements, compounds, and mixtures.
Elements: lithium, argon, sodium, aluminium, potassium, silicon. Compounds: carbon 2 oxide, ammonium nitrate, potassium chloride, magnesium carbonate, sodium nitrite. Mixtures: sand and salt, beans and maize, iron filings, iodine, salt and sand, crude oil.
Ah, interesting. One last group. Evans, you've been quiet since it became dark. Evans, is it the time you're starting to write on your exercise book?
No. I've written.
Okay.
Yeah.
I was worried. By the way, did you change the date?
Yes.
When we entered 14. Imagine it's Valentine's Day.
Wow.
Yeah.
So for the elements,
Elements from Evans.
we have sodium,
Hmm.
potassium, zinc, magnesium. Compounds.
Again.
Elements, we have sodium, potassium, zinc, magnesium.
Mm-hmm.
Compounds, ammonia, water, etc.
Yani, the three of you discussed ETC?
Oh, we are not finished.
Or you had not finished?
Yeah.
So you don't even have mixtures? Hii mlikuwa mnachapa story. I want to hear interesting mixtures. Now, Martin and Deborah have been talking a lot. I assume they have a lot of information for us. For mixtures, give us for mixtures.
Rice and beans, beans and maize, fruit salad.
Are you hearing their mixtures? Rice and beans, beans and maize.
Oil and water.
Uh-huh.
And crude oil.
Okay. Elements, mention them.
We have magnesium, argon, copper, sodium, potassium, and lithium.
Great.
Compounds: sodium chloride, water, carbon 4 oxide.
Can you apologize to him? Yeah, I think so. That's okay. We can proceed. Okay? Now, see somebody to rap for me, please. Thank you. So we are back to the workbook. And we look at portion 2.4, 2.5, and 2.6 in the next 30 minutes, okay? All right. Now we are filling in, first of all, we are describing the structure of an atom before we fill in that table. And I would want to draw for you an atom. We use circles to represent atoms, okay? So this is the general structure of an atom. Now, an atom has a nucleus in it, and in the nucleus we have neutrons, and we have protons. Are we together so far? Then surrounding the nucleus, we have electrons in what we call shells or orbitals, all right? So these are electrons. Then we have protons, and we have neutrons. So all these three are subatomic particles. Subatomic particles. Are we together so far? So this is the general structure of an atom. All atoms have this general structure. Then now we are going to look at specific structures of different atoms, which will be exciting. Now, over to filling in table 2.4. Of course, once you're done drawing, can give you 45 seconds to draw. You know, the good thing is that I'm able to tell how many seconds you're taking. Huh? Yes. All right, let's fill the table in 2.4. Now, all this date. So, my dear students, you didn't notice I've not changed the date? Thank you. All righty. We are filling in table 2.4. Considering the masses and the relative charges and location in an atom. All right? Now, from what I have drawn on the board, fill in the column for relative charge. From what I have drawn and what you have drawn, fill in. No, you have done the opposite. Marlon, you first of all filled the table, now is when you're drawing. It's true. Yes? Ah, okay. No worries. The objective has been met. All right, relative charge for protons. Positive. Now, it's important for you to write positive 1. Write positive 1 because a proton has a charge of positive 1. Some students need to go for a health break. Group 4. Group 4, please go for your health break. Okay, so now let's go to the column for mass. Let's go to the column for mass. Please, if you're going for a health break, do it with minimal disruption of the class. Now, in terms of mass, what do you know about the mass of subatomic particles? Mass of subatomic particles. Yes, speak up, speak up. Someone? Clarice? Speak up. All of them? No. Now, when it comes to masses, first of all, remember subatomic particles are particles found within the smallest particle of a substance. So you can imagine how small they are. So their masses are not measurable, but we are given those masses according to relative units, okay? So in terms of relative units, we say that protons have a mass of 1, all right? Neutrons have a mass of 1, and electrons are the lightest because they have a mass of 1 over 1,840. The mass of electrons. All right? Mass of electrons. They are the lightest. And so when we are looking at the mass of an atom, we don't really consider the mass of electrons. Because you can imagine already the 1 unit is a relative unit. It is immeasurable. Now divide that immeasurable unit 1,840 times. It's like non-existent, yeah, in terms of weight or in terms of mass. All right. Then we go to location in an atom. This one you can feel it. The protons and neutrons are found in the nucleus, and then the electrons are found in electron shells or orbitals. Shells, orbitals that are surrounding the nucleus. Now, for purposes of this topic, we will need to define several terms. And the first term that we need to define is proton number, also known as atomic number. Comment on that. Proton number, also known as atomic number. We're in 2.5. Yes, Marlon? Yeah, proton number is the number of protons in the nucleus of an atom. In the nucleus of an atom. Now the atomic number, which is also the proton number, also indicates the number of electrons in an atom. Kindly underline the word atom because there is a time protons and electrons will not be equal. So for this stage that we are in, we say that atomic number also indicates the number of electrons in an atom. Now, we go to mass number. Yes?
Mass number is the sum of protons and neutrons in an...
Aya louder. Let me give you the microphone.
Mass number is the sum of the protons and neutrons in the atom.
Need I say more? Mass number is the sum of protons and neutrons. Perfect. Then going to the next page, we are looking at electron configuration stroke arrangement. Yes, Sarah? Yes. So electron configuration is actually a connotation. Hey, that's a very serious English word. Connotation. Or rather, a description of the number of shells, of the number of electrons found in each shell. A description of the number of electrons found in each shell. At this point, I want to give a few facts when it comes to distribution of electrons in the shells. The maximum number of electrons that the first shell can carry are 2. All right? 2 electrons are the maximum number of electrons that occupy the first shell. Second and third shell can carry a maximum of 8, and then fourth shell can carry 18, right? Yeah, but for purposes of this, we'll just do up to the first 20 elements, so we won't need to go to the other higher numbers of electrons. Are we together? All right, calm down. Okay? Thank you. We have 66 hours. All right. Thank you. Now, we have a table there. The first thing I want you to do is to fill the first column. That is 1 to 20. Just the numbers, the atomic numbers. Atomic number 1, 2, 3, 4, like that. Now, we have a periodic table . Okay, we have a periodic table in 1.82, subtopic 1.82. Now, you're reading the periodic table horizontally. So, the lower number on the lower left side of each atom, the lower number is the atomic number. So if you're looking at atomic number 15, you'll refer to the periodic table and check which element has atomic number 15. Write the name of the element and the chemical symbol. Can we do that referring to that periodic table, 1.82? Now, remember, we are not copying. We are referring. There's a difference. When you're referring, you refer to understand. When you're copying, you are just transferring information from one place to another. Now, after this, we are going to make a model, and we'll supply you with equipment and substances to use to actually make a model. But we'll make the models after drawing them. So let's fill. You're still looking for 1.82? Found it? Now let's fill the second and the third column before we can go to the electron configuration column. All right, I believe the second and the third column should be done. Is there anyone who faced a challenge filling in those two columns? Anyone who faced any challenge? Now, on to the fourth column. The fourth column of electron configuration. Let's do this together. Let's do this together for electron configuration. Now, pay attention here. Atomic number 1, we say it is hydrogen. Now, how many shells do you think hydrogen has? 1 shell. So the EC, the electron configuration of hydrogen, is 1, because it only has 1 electron found in the first shell. Atomic number 2, helium, which has how many shells? 1 shell having 2 electrons. We are in 3. I know there are people who are not familiar with this, so let's not think it is obvious. Are we together? Now, 3 is lithium. And I'd like to know how many electrons are in the first shell and the second shell, because clearly this one has 2 shells. Yes, Bilha?
2 electrons in the
Yes, so it's 2.1. Now you can say 2.1 or 2, then put a comma, 1. Depends on what you choose. So I think the rest can flow. I'd like to ask Damaris to come and give us the symbol for the fourth element and its electron configuration. Is all well? Damaris, you can come up. Perfect. So fourth element is beryllium at 2,2. Let me have Lenny doing for us the fifth one. And then Evans. Evans has gone. Good. Fabian. Fabian, remove the hood. Yes. It will make you very comfortable. And you'll end up sleeping on the first night. Then I think you can voluntarily go and fill all the way to number 20. Someone else can go to number 7. At least make sure you hand it over to someone. Sorry? It's on this side. Oh, you decided to do all of them? Okay, can we have another person proceeding from number 11? All right. Let's have someone else proceeding from number 11. Thank you. Okay, please just do 3. Thank you. 2, 8, 1. Yeah, 281, 282, and 2834. Sodium, magnesium, and aluminium respectively. Uh-huh, 3 are enough. Now this side of the class, from over there. Can I have someone from this area? Yes, Chebi. Perfect. Now we are going to distribute some compasses, and now in the space provided, so that space provided is able to fit the 20 atoms. Are we together? If you use it wisely, it will fit. Now don't draw the protons and and neutrons. Don't draw protons and neutrons when you're drawing the atoms of the first 20 elements. So this is what you'll do. Like, for example, if you're drawing sodium, you write the chemical symbol of sodium inside. Then you just start off with the first shell. So you can use dots or crosses. Second shell. And the third shell, which is that, okay? So you don't have to draw the nucleus, including the protons and the neutrons, all right? So we have, so we have 3 compasses here. Is there anyone who came with a compass? Yeah. So this is what we are going to share. I need to open. Now, if we decide this can take us over 1 hour, but I don't want it to take a lot of time. Okay? Okay. Let me use this. Now, if you know you can draw perfect circles, you can just draw without using the compass. Okay? So this is the compass. Yeah. It may take a lot of time, but let's be as fast as possible. Now, if you don't get a compass and you can draw nice circles, please go ahead.
Can I take a 15 minutes break? Okay.
CPF is a financial services company that offers a whole host of solutions to the Kenyan public and across the globe. We have been recognized both locally and internationally as a trusted brand, and the following are some of the reasons why you should be working with us. Currently, we provide fund administration services to the largest schemes in the country. One of them is Lab Trust, which is the oldest. Having been established in 1929, it currently has a fund value of over 30 billion Kenya shillings and membership of about 20,000 members. The County Pension Fund, which is also one of the largest in the county space, and the Public Service Superannuation Scheme. Overall, we have total assets under management of 100 billion. One of the biggest challenges in the social security sector has always been enabling people save towards their retirement. And one of the solutions that we have developed internally as CPF is called Rukisha. Rukisha is a concept that we developed primarily to address people in the informal sector, people with small businesses, people with big businesses as well. And the intention is to help them save towards their retirement. We have incorporated a concept called Save As You Spend into the platform, where for every transaction you make, you're able to save a percentage of it. And over time, you're able to see your retirement funds accrue. One of the other benefits of utilizing Rukisha is you also have access to other solutions within the CPF group of products, among them being investments through the CPF asset managers. You should be able to save towards a specific goal under the CPF asset managers. You should also have access to the CPF insurance products under the laser insurance brokerage services, as well as the real estate products within the laser property management services. For more information on Rukisha, visit www.rukisha.com. You can also access it through the shortcode *391# or download it in the Google Play Store as a Rukisha app. Talk to us, reach out to us, and we shall help you achieve your retirement goals.
At CPF Financial Services, we've been able to package the solution for both for the individual, for the corporate, and also for groups. At the individual level, we've come up with products that are able to take care of the member both at before retirement and after retirement. For before retirement, we have training for the member to be able to prepare themselves to go out there and be able to save for themselves. Also at that particular level, they can be able to save individually on a continuous basis with as low as 50 shillings every day or 500 per month to be able to take care of themselves at the point of retirement. At corporate level, we have solutions where we carry out fund administration for corporates that have already existing schemes, or they can be able to join our umbrella DC schemes within this called Taifa. We also do gratuity administration to assist corporates be able to administer the gratuity plans for their different staff within the organization. We also have solutions for chamas where we can be able to open up opportunities for them to be able to save and invest as chamas and also enjoy welfare solutions which are always covered under our trust fund called the Momba Trust Fund. As part of our solutions under the management and training arm, we also do management consulting. Under management consulting, we consult for you to do governance audits, we do strategy development, among other consulting services that you might request. We also do trainings. Under trainings, we have trainings that are bespoke to the organization, or they can already be able to come in at best prices to attend some of the trainings that have already been packaged by the CPF arm. For more information, visit our website on www.cpf.or.ke, or you can be able to access the information on the CPF app on the Play Store or the iOS Store.
Prayo bwana, asante kutupeleka holiday bwana. Lakini na swali, uliniambia tunasave na CPF. Kwani ukisave unapata pesa wapi?
Boni, unajua first una save, halafu una spend. Nilikuwa nishaweka kitu CPF kabla sherehe.
Oh, okay. Na kama sina kitu this month nafanyaje?
Usistress. Ukiwa na CPF, unaweza convert Safaricom Bonga Points zinakuwa contribution yako kwa M-Pension. Na ni rahisi sana. Dial *289# au piga 0111 114 000 na CPF watakusort.
Hello, my name is Wanjiru Nyanjue. I'm a fourth-year student here at Jomo Kenyatta University of Agriculture and Technology. I'm pursuing a degree in horticulture, and this is my final semester. So I lost my dad in 2018 when I was in first year, second semester, and it was a 1-week illness. After his death, my life was kind of difficult because I didn't know if I was going to continue with my studies because my mom is a housewife. And so when I joined second year, my first semester, my mom introduced me to Lab Trust after she received some phone calls from my dad's workplace. And so we went with her because I'm usually here in Nairobi. So when we went, they assured me that they were going to pay my school fees and I didn't have to worry. So that was like a saving grace for me. And since then, my school fees has always been paid. My upkeep is always in check and my house is always in check. I've never lacked anything since then in second year, and up to now I'm in my fourth year, final semester. And as you can see, due to lab trust, I'm able to carry on my project. Here is one of them, and I'm studying the plant diseases, and I'm using a treatment known as silicon. Then I'm controlling the disease to see if it is going to be controllable. And this has become my passion, and I love agriculture so much. Right now I'm in my final semester, and by next year in January I'll be done with school. And my plan is, if I'm going to get a job, I can join the scheme, the lab trust scheme, and ensure even if when I'm going to have kids later in future, their lives are going to be catered for even in my demise, because CPF has done that for me, and I'm very grateful. Because if it weren't for them, I don't know if I could be even here in school. And thank you so much, CPF, for fulfilling our lives. I have 2 sisters at the moment, one in college and the other one is in grade 4 in primary school, and they have been paying for their fees as well. And we can say our life has never been the same, and we are so happy for CPF and how they have helped us. And thank you, CPF, for fulfilling our lives and making us smile again after everything.
In an uncertain world, trust is everything. Introducing Tata Security Services Limited, your trusted partner in security solutions. At Tata Security Services Limited, we understand that security is not just about protection, it's about peace of mind. That's why we specialize in providing comprehensive security solutions for homes, residential areas, and malls. Our team of highly trained security guards equipped with state-of-the-art technology ensure round-the-clock surveillance and protection. From guard services to K9 units, from installing electrical fences to providing quick response in times of emergencies, we also offer bodyguards and event security. Tata Security Services Limited is your one-stop solution for all your security needs. With our commitment to excellence and swift action, you can rest assured that your safety is our top priority. Choose Tata Security Services Limited for security you can trust. We are located at Rimpa along Magadi Road, and you can contact us on 0202 595098. Tata Security Services Limited, protecting what matters the most.
His Excellency Mike Mbuvi Sonko, the Good Deeds Ambassador, crowned for his generosity in helping the needy. Sonko's move to help the needy is his way of life and started way before he joined politics. Hundreds of needy people from all walks of life can attest to this. Mariam Abdallah has been in and out of hospital, but Governor Sonko has always been there for the family.
Namshukuru sana mheshimiwa, yeye na familia yake, anawaombea sana kila nikiswali, Mwenyezi Mungu awajalie kila la kheri.
Natoa shukrani zangu kwa mheshimiwa Sonko kwanza. Mwenyezi Mungu amjaze kila la heri. Amuondoshe matatizo yake, mazito amfanye mepesi. Familia yake Mwenyezi Mungu aijalie salama. Amenifariji mimi na amenisaidia mtoto wangu. Sikupata usaidizi wowote Mombasa zaidi ya kwamba ni hao katika wale wataja. Hamna mheshimiwa yote alikuja kunisaidia. Lakini nasema Mwenyezi Mungu yuko pamoja na yeye. Tumekuja naye karibu vizuri. Alhamdulillah, na ubaguzi. Ni mwanamume ambaye sijui niseme nani. Anifadhili kwa kila kitu.
Tunakwambia rudi after 2 months, lakini umetupatia karatasi ile kule Mombasa. Unajua umeshona na chuma ile kutumia. So watamtoa.
Umeshakatia ndege
kila kitu waziri alipasha shughuli.
Sawa. Kidogo ya dawa na supu damu ile kidogo. Haya, shika tuenda kununua naye dawa. Sawa.
Kwa majina naitwa Mariam Abdallah Kombo kutoka Mombasa. Nimeshukuru sana kusaidiwa na mheshimiwa. Operesheni zile zangu za kwanza alinisaidia nikafanyiwa, na hizi za pili tukarudi tena pia amenisaidia yeye. Namuombea Mungu sana yeye na familia yake. Mwenyezi Mungu ampe afya, ampe umri, ampe nguvu na amlinde na azidi kuwa na imani na kusaidia.
Not once or twice has Governor Sonko intervened when the elderly are being neglected by the community.
Wewe nani mheshimiwa?
Hapana,
hapana, wewe kuja mami. Wacha kufanya hivyo.
Hapana, mama, wacha mama ingia ndani. Hapana. Hapana, haiwezekani.
Twende mami, sasa ile hapa.
Mbariki nimempa baraka na mbariki zaidi. Apande juu. Amen. Ile yote tutaweza. Mbarikiwe na Mungu. Usikutane nangu. Asante. Asante sana. Baraka kwa hakuna mtu atakutoa hapa. Sasa uko na uko naye.
Times society neglects elderly people. A 100-year-old granny in Embo was forced to spend nights in jail for contempt of court, unable to pay a fine of 100,000. Sonko came to her rescue. Same story for a 106-year-old granny who was evicted from her land in Pangani, but Sonko helped her get it back. Several other people have also gotten back their grabbed land through the help of Governor Sonko.
Itakuwa registered kwa hiyo title yako na utarudishiwa hii shamba. Shamba yako itarudishwa kwa sababu register hii imetoka kotini. Kwa hivyo itarudisha hiyo shamba kwako sasa. Yes. Please. Hiyo tutafanya mara moja na itarudi.
What I have to say is that today I have managed to have access to Mheshimiwa, which not many people can have. I think it was God's grace that maybe our dad had done something very good for us for today Mheshimiwa to be standing here and assisting me, because we just seen Mheshimiwa in the papers, we hear about him, but today I've seen it with my own eyes what work he does.
He has such a compassionate heart.
Ninaguzo sana na moyo wake wa huruma.
You know there is politics.
Kuna siasa.
And there is a core.
Na kuna mwito.
This man is not a politician.
Huyu si mwana siasa.
When I watch the way he handles the poor people,
ninapoona jinsi anawashughulikia watu maskini,
then I know
basi najua
there is something extraordinary in his life.
Kuna kitu kisicho cha kawaida ndani yake.
Governor Mike Sonko, through Sonko Rescue Team, has continued with his charity work, which he began even before joining politics. Meet baby Kyla, a 1.5-year-old baby. Governor Sonko met Kyla's mother in Westlands, who narrated her daughter's woes to the governor. Sonko was touched by the story of young Kyla, who had lost her eyesight at a tender age and vowed to help her seek medical attention in India. Weeks later, she is back after the surgery. Kyla was received by Nairobi County First Lady after landing at JKIA.
All right, let's continue. So, I'm sure drawing the atoms. Right. Have we all finished drawing the atoms? Now, we are dividing you into 6 groups. I don't know how many we are currently. But I'm going to give you a board, plasticine, all right? And you use compass as well, and construct a model of an atom on the board that I will provide for you. So we are providing you with 6 boards. You need to show us where the nucleus is. You don't need to show us the protons and the neutrons. I'm highly interested in the arrangement of the electrons. Now please choose an element that has 2 or 3 shells. Because you can easily choose hydrogen. Yeah. Hydrogen, but I want you to work in pairs. So we are supplying you with tape, we are supplying you with, let's just place all those things on the bench. Cotton wool, skewers, tape. I need you to choose what to use and make a model of an atom. And then once you're done, display it on your bench for others to see and please let's remove clothing from the benches. Now we have gloves, we have rubber gloves here. If you are uncomfortable touching plasticine with your hands, you can pick a pair of. So of course it's one person handling the plasticine. All right. So per group, only one person is handling. Anyone else? Anyone else? Good. So using plasticine, you will mold the electrons, organize them in orbits, in shells, around the nucleus. If you need to use the permanent markers, they are within the room. All the resources you need to make that are available. If you require my input, kindly consult, call me. I will come to you. Oh, I didn't give you two. You did. Okay. Now remember, this plasticine will be reused in another activity. So
an element which is precious. Then now we made the into the
you okay? That's nitrogen you're drawing? All right. So by the time you're finishing, I want to see a clear model of the atom you've chosen. I can see nice things coming along. Scientists are also creative, right? Feel free to use as many colors as possible. I also need the pegs. And a tray. So the pegs can be put in a tray. Ten hours gone. Yay. Are these the only pairs? We took 3 dozens. There are also scissors in case you need scissors. This group is big.
So you need 2. Then?
So that first shell is empty.
The first one is sodium. It has
The
2
inner circle
because it's the
has
first
2.
innermost circle. Anasema hii.
Unapanda tu nini?
Hiyo ifai kuwekwa confuse.
What is that first circle for?
This one is for showing that it's a sodium and the nucleus.
Then use another color then.
Then you need to use another color because it indicates that it's like a shell that is. I'm looking forward to seeing the final product.
What are you doing? What is that? What is that to mix?
Which element is this? Aluminium 283.
Sodium.
Okay. Hey, people love sodium. Students love sodium element. Oh, your circles are nice.
Wow.
All right. I think I need the camera person here because wow.
An early year teacher was around to make the model.
I need the still photos of this. Now, just for the pride of it, you can label, because we are going to, of course, post this. We need the sticky notes so that we label the owners. This is amazing. What's the name of your group?
Dicots.
Dicots. Can you clap for the dicots? Yeah. So the dicots have, so I'll put that here. How many are you?
There are 3.
Shouldn't cover that.
Are you feeling?
I'm okay. So you have Dama. Bilha. And Harun. All right, I think it's ready. can place it here for a nice. Wow, so I have the first model. Quite interesting. So we are using the sticky notes to write the members of the group. Sticky notes are right using the permanent markers. How many are you? How many are you? You're 4. You're 4?
Yes.
So 4 sticky notes. Hey, you guys.
These are the Waylands. Oh, wow.
And this? Now
so
use.
Write our names.
Yes. So, which is the front side? Okay, I think because of how I have stuck, write it like that now, facing you. Write the 4 names of the members. Now you haven't labeled which atom this is. Sodium. Yes.
Ah, but then, good idea.
Just write in here. Right there, and then write the names, and then allow them to take a photo. No. The other person's name here. Oh, you're writing both your names?
Yes.
Okay. All right. 2.8. You need 2 more electrons here.
Yes.
Wow, I think you should start walking around just to see what people have done. It's quite interesting, eh? Quite interesting. There's no one who wanted to use cotton wool, and you want sticky notes? How many are you in this group? 8.
Yes, by the grace of God.
So I'll stick 4 sticky notes. You'll write 2 names per sticky note. You can just write 1 name for each member. Use the permanent markers.
Yes.
And then make sure a photo of your make sure a photo of your model is that's upside down. That's upside down. Remove that sticky note. Let me give you another one. Somebody can write for you from this end. Yeah. Okay, I've seen 2 models, 2 complete models. Speed is of essence. Is there a team going for health break? Group 1? Group 1, please go for health break. Actually, we can do this. Hold it and then. Thank you.
One more.
Okay. Okay. How many? Okay. Group 1, please go for health break.
Group 1.
Yeah, group 1. Group 1, they've seen. Just leave it there, they'll see it. Please walk around. What's the name of your group? Huh? Okay. Holland. Holland. Okay. You're from? Okay, we have another complete model here.
The most beautiful.
You mean everyone has made sodium? The Dicots made sodium, Holland made sodium. Oh, you guys made aluminium, amazing. I can see someone trying to make potassium there, or is it calcium? What are you trying to make? Oh, you're done? So there's magnesium here. need to label the members. You're 4.
Yes.
So you'll write from that side so that it's not. No? Just everybody will get their name there. All right. Kindly label your models. Wow, that's amazing. That's amazing. So please make sure that your model has been labeled and that we have an image of your model. How many are you? You're 3. Unfortunately, your whatever is full, so you can write your 3 names on that sticky note.
Plus 1.
Now, which element is this? You have not labeled. Yeah, you need to indicate that it's calcium. Now, can we move on to something else, please? Please put aside your models. No, on the YouTube channel. Okay, let's now finalize. Wash your hands. Wash your hands. Clear your table, ready to write again. Please do not dispose the molding clay, the one that has remained. We will use it again. Don't dispose the molding clay. We are going on to another activity. Okay, let's move on to the next activity. Please clear your space. I'm sure now we are okay when it comes to atomic structures, yeah? Yeah, I don't think anyone will forget this anytime soon. Now, can we be seated, ready for the next thing? Now, go to your exercise book. Go to your exercise book and write this subtopic. Go to your exercise book. Write this subtopic. Models of elements, compounds, and mixtures of both elements and compounds using different colored pegs. So I have different colored pegs. I made sure I bought 4 different colors. Now, from this, you're supposed to show me, you're supposed to create a chain of an element. So you choose, I'll just choose like 4 people just to see if they are able to do this. Now, based on the definition of an element, we have said that an element is a pure substance made of the same type of atom. Are we together? Yes. So, I need a volunteer to come and make a chain of an element using these pegs. I want to see the kind of choices they will make based on the definition that I gave you for an element. So we are making, show me a model of an element using these pegs and considering their colors. Yes, Jessica, come to the front.
An element have how many?
You can have as many atoms as possible. Amazing. Show them. Do you agree? Perfect. Thank you. Right. Now I need someone else to come and show us formation of a compound, and the compound of choice is ammonia gas. Ammonia gas is NH3, meaning it has one nitrogen atom and 3 hydrogen atoms. So using these pegs, one person can come and make for us ammonia. Yes, Imelda? Explain to us what.
These three
Face them.
These three red pegs are 3 hydrogens and this is nitrogen.
Perfect. Thank you. So you see, you can use just about anything to learn science. Did you ever imagine that you can make this using pegs? Yeah. Science is just lovely. Then I need from the group again, somebody to come and show us a mixture of elements. A mixture of elements. Yes, Haron? A mixture of elements. Please face them so that they see what you're doing. Back a bit. Yes. Please stop shaking. We are safe. We are safe. And nobody will ask you where you are on Valentine's because we are live on YouTube. Okay?
Yes.
Yes.
So this is a mixture of 4 elements. 1, 2, 3, and 4. So I can call this iron filling, this sand, another compound which is beans, and this is maize.
Now, stop there. I thought I called you up here to show us a mixture of elements.
Yeah, this is element.
Maize and beans are elements? Okay, now I have another problem with, anyone can comment on what he has made? Somebody connect, or you agree with what he has said? Yeah, please challenge him and let's see where the mistake was. Architect, relax. Relax. Lenny, you look thoughtful. Imagine you're safe. So according to him, lift it up. According to him, he's saying that this is a mixture of 4 elements. Of course, what he was mentioning earlier on are not elements. But which other problem do you have with his explanation or choice of model? I can't believe we are full in this lab and no one is seeing this. Okay, Jessica, you had raised your hand.
He's made a compound
Yes. Yeah, the fact that they are together like this, it shows that they have made a new substance. Are we together? Because the moment you do this, that is a bond. Okay? So now, can you now, again, show us a mixture of elements? Calm down, students. Why are you forming bonds? Anyway, let me relax. Do you need assistance?
Yeah.
Yeah, put it back here. Thank you. Let's appreciate him. Jalimo, come and show us a mixture of elements.
Okay, the entire ball is already a mixture.
Yeah, clap for her. Imagine. So all these are mixtures of elements. Now the next thing I want to see is, I think Lenny should do this. Lenny, come and make for us a mixture of elements and compounds. A mixture of elements and compounds. Then Clarice, prepare to make for us a mixture of compounds. Let me hold this for you. You're making a mixture of?
Elements and compounds.
Elements and compounds. Good.
Okay, let me say this is water compound. Then an element like
any element.
Yeah, any.
Yeah.
Okay, like oxygen.
All right.
Yeah.
So what have you done now?
Oh, no, I'm not supposed to. Oh, a mixture like this one.
A mixture.
Yeah.
So you have given us a mixture of an element and a compound.
Yeah.
That's okay. So Clarice, come up and do mixture of compounds. There can be as many compounds as possible. Yes, there's a color I'm not seeing being used. Okay, pick from there. Perfect. Put it on the bowl and show them. So those are mixtures of compounds. We have compound 1, yeah, that has that combination, the second one, the third one, and the fourth one. So I think we have now understood. Thank you. Now, is there anything else I should do to make you understand compounds, mixtures, elements? We are set, right? All right, so we can go to isotopes now. We can go to isotopes. Now define isotopes. Define isotopes. We are back to the workbook. Define isotopes. Yes, Faith.
isotopes are elements with the same mass now, with different mass number and the same atomic number.
Elements are, isotopes are?
Elements with the same atomic number and different mass number.
Yeah, now replace elements with atoms, okay? So isotopes are atoms of the same element we are writing. So this book didn't have a cover. We removed. We didn't have a cover. Okay. Isotopes are atoms of the same element that have the same atomic number, comma, same atomic number, comma, same electron configuration, same electron configuration, same electron configuration, but different mass numbers, due to the different number of neutrons. Different mass numbers due to the different numbers of neutrons. Okay. We move on to the next. So we'll get to understand better about isotopes when we do some examples, some calculations that have to do with isotopes. Then we'll get to understand better. So part 2.7, someone read for us part 2.7. Omol, read for us part 2.7.
Calculate the relative atomic mass of an element from the relative masses and abundances of its isotope.
Calculate the relative atomic mass of an element from the relative masses and abundances of its isotopes. So that means, because we said that elements are naturally occurring substances, it means then that they can exist naturally as isotopes as well. So for us to actually get to know the relative atomic mass of an element, we need to consider the percentages of the abundance of those isotopes naturally. Now let's look at the relative atomic mass of an element. The formula is there. We multiply the percentage times the nucleon number for the first isotope plus the percentage times the nucleon number for the second isotopes, and so on and so on. It doesn't matter the number of isotopes there are. As many as they are, you're able to calculate. So in this case, we have chlorine 35 and chlorine 37. Now the abundance of chlorine 35 is 75%. This is where you will need your calculators. The abundance of chlorine 35 is 75%, and of chlorine 37 is 25%. Now, let's do this example together. Are we together? So, we get the relative atomic mass, which is represented by AR. So in this case, we'll do 75% of 35, right? Plus 25% times 37, isn't it? So you're basically doing 0.75 times 35 plus 0.25 times 37. Please give me the figures as you're calculating. For the first one is? Please give me for the first one. We are moving step by step. Sorry? 26.25 plus, yes? 9.25. 9.25. So that tells you that chlorine 35 contributes that 26.25 units to the relative atomic mass of chlorine. Are we together? And then chlorine 37 only contributes 9.25 units of that mass. What's the total? 35.5. Good. Perfecto, correcto. Interestingly, when you check the periodic table, it will be 35.5. Or at least most periodic tables indicate that. Yeah, chlorine is 35.5. Now, let's do example 2. We are calculating the relative atomic mass of element Z. Now, we have 3 isotopes of element Z. We have Z65.9, we have Z71, and we have Z68.5. All right? Now, if the protons for Z65.9 are 40, what are the protons for the rest of the isotopes? 40, 40. Why? Hmm? Yeah, remember this is the same element, okay? The only difference is the mass number as a result of the difference in number of neutrons. So the first column we feel 40, 40. And then it is now easier to calculate the number of neutrons by subtracting the mass number given all right, you subtract the number of protons. So everything given on the first column minus everything on the second column gives you answers for the third column. So I'd like to hear the number of neutrons for the first, for the second, and for the third. For the first is? Where did you get 0.7?
This is 9.
Huh?
This is 9.
That is 9?
Yeah.
Please write it so that it looks like 9. Yes. It looks like 7. So the second one is 31. And then the third one? 28.5. Perfect. So we now have the neutrons. Now what's the nucleon number? Nucleon number is the number of particles in the nucleus. Yes? Yeah, so the first one is 65.9. Now, as you can see, we have been given the percentage of each isotope. Now, using the formula above for relative atomic mass, calculate for me the AR for element Z. Calculate for me the AR for element Z. I need to sit and do it as well. do you reset this? Shift. Is it 4 a.m.? That is someone from Harvest Family Church who is setting the alarm to wake up to pray. Is it? Still. Okay. Who is done with their calculator? Who is stranded? Can we give our answers to the nearest 2 decimal places? Let me hear what you got.
68.34.
Ah, nice. 68.34. Is there anyone who didn't get that and could need some clarification? So you guys are that good, eh? Interesting. Sorry. All right. And we can take a break from chemistry now. Okay? Yeah, let's switch back to biology. Yeah, go and do it. Now, we are looking at movement in and out of cells. Movement in and out of cells. Now, we have 3 ways in which substances move in and out of cells. But before we even go to the ways, can you discuss with your neighbor why you think substances should move in and out of cells? Discussing means you talk. Yeah. Discuss with your neighbor why you think substances should move in and out of cells. And then let me know what you come up with. Right? Okay, let me hear your findings. Why is it important for substances to move in and out of cells? Yes, my darling?
I can say excretion purposes.
For excretion purposes. So meaning that sometimes you could find waste products inside the cell, and these waste products need to be removed. So, that's a good one. Cynthia, Bilha, you know you look alike. Yes, Cynthia. For gaseous exchange, so meaning substances like carbon dioxide need to get out of cells, right? And substances like oxygen need to get into the cell. So that's important. That's one of the important reasons why substances should move in and out of cells. Any other? Any other? Yes, Bramwell. To balance the concentration of molecules. Hey, choice of words. The choice of words is a bit wanting. Probably you should have said concentration of solutions instead of molecules. Right? Yes. All right, let's go to the first mode of movement of cells in and out. Now, you need to return the compasses to the casing and then give the compasses to me. There are only 3, so I value them. Now, where is the compass for this case? All right. So we have 3 modes of movement of cells, of substances in and out of cells. Any idea about these 3 modes before I mention them? Imelda? Osmosis? Osmosis, another one? Alvid? Diffusion. And then the third one? Clarice? Active transport. Good. Active transport. Now, I'll start with diffusion. And we'll define what diffusion is. Now, we defined diffusion in chemistry. Now, I want us to define diffusion in biology. Biologia. Now, diffusion is the random movement of substances. Random movement of substances in and out of, sorry, not in and out of, from a region of high concentration to a region of low concentration down a concentration gradient. Down a concentration gradient. Now, before we write movement, please add the word net. Net or overall. So you can say diffusion is the overall movement or the net movement of molecules and ions from a region of the higher concentration to a region of the lower concentration down a concentration gradient. So there are some keywords that should not miss in the definition of diffusion. And those keywords, first of all, should be random. Random movement. Random means without any order. Random means without any order. Now, living organisms obtain many of their requirements by diffusion, and they also get rid of many of their waste products in this way. So you'll just summarize the notes as I take you through this. For example, plants need which gas? Mainly plants need which gas? Yeah, carbon dioxide or carbon dioxide. And they only get carbon dioxide by diffusion. Are we together? Yes. So the carbon dioxide diffuses from the air where it is highly concentrated, and it diffuses into the leaf where there is a low concentration of the carbon dioxide, and that way the plant is able to get one of the raw materials for photosynthesis. Now, since oxygen is a waste gas for photosynthesis, it needs also to exit from the plant, and that can only happen through which process? Diffusion also, all right? Same application when it comes to humans. When we are breathing in and we are breathing out, the gases that we need, like oxygen, are what diffuse through our respiratory surfaces in the lungs, and that way we say that we have breathed in. Are we together? So breathing in basically is the diffusion of oxygen into the lungs. Okay? So, for plants, oxygen is a waste product of photosynthesis. So then we can conclude that diffusion is the main process through which gaseous exchange in living organisms occurs. Diffusion is the main process through which gaseous exchange in living organisms occurs. So we are looking at, that one actually is under importance of diffusion in living organisms. So I've mentioned that in plants, it helps the plants obtain photosynthesis and also get rid of oxygen. Sorry, it helps the plants obtain carbon dioxide for photosynthesis and also helps the plant to get rid of oxygen, which is a waste product of photosynthesis. Now, the other application I've talked about is that it plays an important role in gas exchange, and I've talked about the way oxygen diffuses into the lungs through the respiratory surfaces, and out of the lungs comes carbon dioxide. Now, the third application in living organisms is absorption of digested nutrients, or rather products of digestion. For example, when proteins are digested, we get amino acids. So these amino acids diffuse through the walls of the ileum or through the walls of the small intestines, and we get to say that absorption has taken place. But ideally, they have just diffused randomly through the wall of the small intestines into the blood. So that is an application. And then also flowering plants that have a sweet scent use diffusion to attract pollinators like bees and wasps. So the fact that the bees and the wasps can smell the flower from a distance, then that shows diffusion has taken place. That shows diffusion has taken place, and through that diffusion, the plant is able to attract pollinators. Now, I don't know, is there potassium manganate 7? I just want to show you that the end result of diffusion is the end result of diffusion is even distribution of whatever substance is diffusing. And I want to use few crystals of potassium manganate 7. What is the color of potassium manganate 7? Purple. Wow. Hey, you guys are amazing. Potassium manganate 7. So as they get potassium manganate 7 for us, I think we can move to osmosis. Oh, sorry. Factors that affect diffusion. State and discuss factors that affect diffusion. Yes.
Temperature.
Now, Haron says that temperature affects diffusion. I'd like him to tell us how.
Increase in temperature increases the random movement of the particles, hence increasing the diffusion.
Please speak up, and then around that area you're speaking when someone else is explaining. So you may not hear what he's saying. Now, Harold, repeat what you've just said about temperature.
Increase in temperature increases the randomness movement of particles, so that increase the rate of diffusion of that substance.
Okay, temperature is a factor, but probably your explanation is not sufficient. I've not said it's wrong, but it's not sufficient. It's not really showing me how temperature affects diffusion. Anyone with another explanation? Clarice? Yeah, you may. Yeah, so increase in temperature leads to particles absorbing heat.
Kinetic energy.
Particles gaining energy for movement. So we say that kinetic energy has increased. All right? So if kinetic energy increases, then the particles move faster, collide with each other more, and so they diffuse faster. So that's correct. Another factor that affects diffusion. No. Deborah. Concentration gradient. Please clarify, explain. Oh, sweetheart, speak louder.
Increase in concentration gradient increases the diffusion.
Increase in concentration gradient increases diffusion. How? I agree. You're not wrong. Okay? Bring out the science in that. You seem to have a very powerful point. Concentration gradient is what we are trying to explain. Oh, no. We don't say the higher the this, the lower the that. That is not science. Yes?
You can say when you increase the concentration of substances, it increases the concentration gradient as one point will have a higher concentration as compared to another point, so it will lead to an increased rate of diffusion because the concentration gradient has increased.
Now, I agree, although you have used a lot of words. Yeah? If it was literature, you'd have gotten all the marks. Anyway, now, when it comes to concentration gradient is basically the difference in concentrations between the higher measurement and the lower measurement. So, how steep it is will determine how fast the particles will randomly move to spread evenly. Remember we said that the ultimate goal of diffusion is even spreading of of particles. Sawa sawa? Yeah, so that is what, that's one factor to consider. There's one more that I'm looking for. One more that I'm looking for. Factors, yes? Surface area to volume ratio. For biology, yes. Please explain.
We say for a bigger person has a tendency to, okay, for a small person has a tendency to have an increased surface area to volume ratio, and this will increase the concentration. Not the concentration.
Okay, slow down. Start again.
Okay, so if a person is small, the surface area to volume ratio is large. So this one will help in increasing the rate of diffusion because like the increases the large surface area to volume ratio increases the rate of diffusion.
The point is correct. The explanation is partly correct. Okay? Now, surface area to volume ratio, as she has said that if the surface area is large, are we together? There is more diffusion happening. Now, do you know why? Because there are more particles moving across at the same time. That's now the sufficient explanation. Okay? Yeah, so the fact that the surface area is large, it means that it gives room for as many particles to move randomly as possible compared to if the surface area was limited. All right? Now, I can see blanks on people's workbooks. I don't know what's happening. Like for you, importance of diffusion, you have not written. Please, let's not tire. We keep working. So, can I give my point that I like?
Yes.
About factors that affect diffusion?
Yes.
The thickness of the membrane through which diffusion is taking place. Now, if diffusing particles have to move through a thick membrane, it will take a longer time for diffusion to take place. But if they are just going through a thin membrane, it's like trying to get into a homestead that has 3 gates and into a homestead that has 1 gate. Which one is it easier to access?
1 gate.
The one that has 1 gate. So same concept. If the membrane is thin, then the particles are able to move through faster, all right? And many more now keep moving through at the same time, so you have increased, that way you have increased the rate of diffusion, okay? Now, we have not exhausted, yes, Jelimo? The size of the particle and also the mass of the particle. As we said when we were looking at this in chemistry, that the size of particle will determine how fast that particle can move. So if the particles are light, then they can move faster and many at the same time. But if the particle is large and heavy, then the movement is limited because of the size. So as it is, we have met that objective. We've been able to define diffusion. We've been able to define the importance of diffusion. We've been able to state the factors that affect diffusion. So we want to do just a small demonstration. So I'll use this 500 ml beaker, okay? And I'll fill it with water. Is it powder or? Okay. So this is water. And I want to put a few crystals, just a few crystals of potassium manganate 7. Just a few. You see what I'm putting? Yes. Then we see how fast it will diffuse. Now, trust me, There is no force that is making these particles to collide with each other. It is purely random. That's why I say it is random movement. Now we can do some things to fasten it and quicken it, like stirring, okay? Heating the particles so that they have more energy and they're moving and they're moving and then they diffuse faster. But if I leave this here, after some time, you can see it's not evenly distributed now. After some time, you're going to realize that it is all evenly distributed without the influence of anyone. Sawa sawa? Yes. Can you describe that investigation there? The diffusion activity. What are we using? What apparatus are we using? And you leave a space for observation because after some time, I will ask you to come and observe. Na mtu asikoroge, please. Thank you. Let it diffuse and mix evenly by itself. I think I'm sorry. Hey, karibu yanguke. I'm done with it. Now, before I go to osmosis, I want to talk about properties of water. Before I go to osmosis, I want to talk about properties of water. Now, I'm talking about properties of water in relation to biology. And then later, now I'll link it up with osmosis. Are we together? Yeah, so don't wonder where is water coming from again now. We must study, for us to understand osmosis well, we must study the properties of water. All right? Now, number one, you need to note about water is that many substances are able to dissolve in it. Many substances are able to dissolve in it, and so water is a favorable solvent. I forgot to tell you that we have done 11 hours. When we see we have done 40, we can clap. Okay, and then so water makes a good solvent because many substances are able to dissolve in it. Now, the fact that many substances are able to dissolve in it, it means then that we can easily transport substances using water. So it is a medium of transport in living things. Now, water does not just transport useful substances. It also transports waste products of metabolism. For example, urine. In urine, we have water, but also we have urea, which is a toxic substance that is excreted by the kidney. So water is a medium of transport to escort the urea out of the body. Are we together? Yes. Now, another thing is that water is an important part of the cytoplasm. We said the cytoplasm is the clear jelly-like substance found in cells. It forms an important part of the cytoplasm. And so, because this is where metabolic reactions take place, then we say that water is very important in terms of metabolic reactions. Okay, so I've given you properties of water, and I think I have linked it up with the roles. Have you noticed? Yes, I've linked it up with the roles. So now that we know the importance of water, we can define osmosis, okay? Do you feel like stretching? Please stretch. That one has gone out without permission. Huh? It's okay, it's okay. Okay, let's be seated now. I really need to remove this, I don't know, media. I need to remove the lab coat because it's hot, apparently. Okay, let's define osmosis. Let's define osmosis. Now, I'm sure it's not the first time you're hearing about osmosis. And I'd like to hear, without my input, how would you define osmosis? How would you define it without my input? Yes, Evans, I can see your back.
Yes. Movement of substances from a region of low concentration to a region of higher concentration.
Where? Movement of substances from a region of low concentration to high concentration. Allow me to disagree totally with your answer. Okay? Have you allowed me to disagree? Yes.
It is the movement of water molecules from hypotonic solution to a hypertonic solution.
Well, he says that it's a movement of water molecules from hypotonic solution to a hypertonic solution. Now, please, we are still here. We are still observing, yeah? Yeah. So Alvin says it's the movement of water molecules from hypotonic to hypertonic solutions. Yes, his answer is right, but for someone who has never heard these terms, it would be difficult to really understand what osmosis is. Yes?
You can see the movement of water molecules from a region of high concentration to a region of low concentration along a semi-permeable.
Why slowly, Sarah? Unajua ni saa 9 ya usiku. I speak systematically, slowly, so that I understand.
Okay. It's a movement of water molecules from a region of high concentration to a region of low concentration along a semi-permeable membrane.
Okay, so movement of water?
Molecules.
From a region of?
High concentration to a region of low concentration.
Okay. High concentration of what?
Or solids.
Of? That's where now we mess it up. So I'll take you systematically. And actually osmosis has 3 definitions depending on how deep you are going in biology. Are we together? Now the first definition of osmosis, first of all, okay, is the movement of water molecules, okay, from their region of high concentration. Now, we are talking of a region that has many water molecules. That's why I'm saying, in fact, I see some textbooks writing that osmosis is the diffusion of water molecules. Have you ever seen that? Yes. Yeah, because truly thinking about it, the water molecules are diffusing from where they are highly concentrated to where they are lowly concentrated. Thank you. So osmosis is the movement of water molecules from their region of high concentration to their region of low concentration across a semi-permeable membrane or across a selectively permeable membrane. Let me give you 2 minutes to write that. Just 2 minutes as you think about it. Okay, so it's down here. It's here. Now this region that has a high concentration of water molecules, in terms of dilute and concentrated, what do you think it is? I'll pose the question again because silence means 2 things. You either didn't understand the question, all right? Yeah, actually it means you didn't understand the question or you understood the question but you have no answer for it, okay? Anyway, in terms of dilute and concentrated solutions, which solution has a higher concentration of water molecules? Dilute solution. So can you now comfortably say that osmosis is movement of water molecules from a dilute solution to a concentrated solution? Write it. See, I told you I'll take you systematically. Before we get to Alvin's answer, we'll have written like another 2 definitions. Yeah, so you are justified and you're right to say that osmosis is movement of water molecules from a dilute solution to a concentrated solution. Now, a dilute solution is also known as a hypotonic solution. A dilute solution is also known as a hypotonic solution. A dilute solution is also known as a hypotonic solution. And a concentrated solution is known as hypertonic solution. When someone is hyper, like me, it means they have a lot of energy. Yes. So hypotonic means dilute solution. And then hypertonic means concentrated, solution. Are we together? So then I can comfortably say that osmosis is movement of water molecules from a hypotonic solution to a hypertonic solution. Write it. Across, okay, thank you. Every time it is across a semi-permeable membrane. Actually, osmosis does not take place minus the semi-permeable membrane. Thank you for reminding me that. You're almost doing half a day. Yeah. Now, one thing you need to know about a hypotonic solution is that it has a lot of water molecules, so we say that its water potential is high. Are we together? So now we are defining osmosis in terms of water potential. So hypotonic solution has a high water potential because it has more water molecules, and then a hypertonic solution has low water potential. Okay? Now the difference between a high water potential and a low water potential is a water potential gradient. All right? Are we together? Yes. So now I'm about to unveil the grand definition of osmosis. Are you ready? Yes. You're ready? Yes. So now I can say, without fearing that you're not understanding, I can say that osmosis is the net movement. This one, if I were you and it is the grand definition, I would have written it in a different color of a pen, but it's okay. Depends on the passion you have. Anyway, osmosis is the net movement of water molecules from a region of high water potential. All right? I'm sure now it makes sense, eh? Yes. To a region of low water potential, down a water potential gradient, across a partially permeable membrane. Isn't that a nice definition? Sounds very scientific, eh? Well, I don't know. Does it sound scientific to you? Okay. Pardon? Thank you. Net movement of water molecules from high water potential to low water potential, down a water potential gradient, across a partially permeable membrane. I feel so nice that we have been able to get there. So I told you, depending on how deep you're going in biology. So someone who is deep, they'll give the fourth definition. Someone who is shallow will give maybe the first one. Yeah? Yeah, so we keep going deeper every day. Now, a dilute solution, think about it. A dilute solution, which particles does it have more? Solute particles or solvent particles? Solvent. Very nice. What time is it? And the way you are alert. Huh? It's 4 a.m. Wow, 4:15. Amazing. Yeah? Wow, morning people, yeah? Then, that means that the water molecules are moving from, in terms of the diagram. Can you look at the diagram that is after the page you are writing the definitions? Now you can clearly see the first part of the solution. It has large solute molecules that are unable to pass through the membrane. That's why we say the membrane is partially permeable, because it only allows particles of a certain size to pass through it. And then now the small water molecules are able to pass through the membrane. So that is actually a description of osmosis taking place. Now I want us to define a few terms before we move on. All right? Yes? Have you called me miss? Okay. Now the first term I want us to define is turgid. 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 Or turgid. Turgidity. We are spoiling even. Turgid. Turgid. All right. Now, turgid. This is a state of a plant cell. I am specifically insisting on plant cell because an animal cell does not experience turgidity. Okay? Yes. So, this is the state of a plant cell where the large central vacuole is full of water molecules and it presses against the cell wall. Visualize that. Visualize that. Turgid. The large central vacuole is full of water and it presses against the cell wall. So this makes the cell firm. Are we safe? So this makes the cell firm and even gives the cell its shape. Are we together? Now, Target pressure is the second one, right? Now, the Target pressure is the force exerted by the large central vacuole. The Target pressure is the force exerted by the large central vacuole on the cell wall. So it's the Target pressure that actually comes from turgidity. So Target pressure is the force exerted on the cell wall by the large central vacuole. Now, Group 2, please go for your health break. Please move faster. Okay, let's go to the third term, which is plasmolysis. Plasmolysis. Now, plasmolysis is the shrinking Plasmolysis is the shrinking of the large central vacuole. Plasmolysis is the shrinking of the large central vacuole. Plasmolysis is the shrinking of the large central vacuole. And it even pulls away from the cell wall, making it to pull away from the cell wall. Making it to pull away from the cell wall and lose its shape. And lose its shape. So basically, you can see that a plasmolysed cell is the opposite of a turgid cell. Yeah. All right, what next? Flaccid, okay? So a flaccid cell is a plasmolysed cell, is a shrunken cell. So we say this cell is turgid, this cell is flaccid. They have opposite meanings. So a flaccid cell is a shrunken cell. Now, in the next page, I've already defined for you a hypotonic solution. I've defined for you a hypertonic solution. Now, an isotonic solution refers to a state of solutions having similar or equal concentrations. So if I have solution A and solution B, and they have the same concentrations, then we call that isotonic. We say they are at an isotonic state because comparing their concentrations are the same. Okay? Any question? Now, because I want you to be very active, we are going to go to the activity that investigates the effect of plant cells. Now, the investigation we'll do is for plant cells using potatoes. We'll use potatoes. So these are the following things that we are going to need. We are going to need, first of all, to be in groups of 4. Okay? And then we'll need potatoes. We'll need rulers. Now, each group will need 2 beakers. We will need scalpels. If we need anything else, we are going to communicate. So the person, I need 2 people. I need 2 people in every group who are going to cut the potato slices. Okay? If you didn't wear gloves the previous time, it's a privilege to wear gloves. Huh? Who has not worn gloves since we started the lesson? Dolin, hutaki gloves? Wear gloves. Now, once you're done with gloves, you dispose them. Whose are these? Meston. We're a Meston. Don't worry, you will still get a chance to wear gloves. Alvin, your hand is up. I want gloves. The cutting surface, we will need probably tiles. I can give them. Who else needs? Now we are doing the investigation. We are doing the investigation whereby we are going to immerse plant matter that we will extract from the potatoes. Now these are the instructions. So you can write the instructions as I give them. One person can write the instructions. Now when you receive the potatoes, cut them into equal cuboids. Cut them into equal cuboids. I'm really waiting to see what you will do. Like you slice the potato and extract matter from it. All right? And in the second beaker, we are going to use distilled water. So let me allow you to just do what you're doing step by step. Have you received your plant matter? Cutting surface? All right. Mm-hmm. Like a tile. How many groups are there? 1, 2, around 6. Could we get 6 tiles? Okay. Okay. Now I want to see the cuboids. Now, if you can't get cutting surface, you can just place on the bench. We will wipe. Don't worry. Science is also messy. Huh? Thank you. Now we need filter papers because after cutting the 2 cuboids, so make sure you label the I don't know how you'll identify cuboid A and cuboid B. Also take their masses. We are going to place them on a filter paper and take their masses. So we'll switch on those weighing balances. We are making, sorry? I think 2 because we are placing one in a hypertonic and another one in a hypotonic. So 2. Yeah, it's just 2. The sockets are not working. So we'll need filter papers for them to place their cuboids on the filter paper. So make sure when you are cutting, those 2 cuboids have the same length, width, and height. Doesn't matter. And then also get the mass. It's something we need to check. So we need sodium chloride, we need stirring rods. Don't waste the potatoes, please. Don't waste them. That is food. You are playing. Jelimo, I can see you're doing well as a group. So once you get identical cuboids, all right, go and measure their weight one by one. And now you don't confuse them. I don't know what you'll use to identify them, but at a time.